The demand for DevOps professionals is booming. Companies want people who can make their software development and operations work together smoothly. However, DevOps is more than just speed and efficiency. It's a way of working that fosters collaboration, innovations, and continuous improvement. It's a field where engineers and developers unite, breaking down barriers to deliver top-notch products and services. Hello everyone and welcome to this session on the DevOps Engineer Full Course. Join us on this exciting adventure as we explore the full course of DevOps. Learn about the DevOps tools, methods, and the ideas that are shaping the future of technology. Whether you are an experienced IT professional or just starting to explore the tech world, DevOps offers exciting opportunities and a chance to tackle new challenges. But before we get started, let's take a moment to outline the agenda for today's session. First, we will start with a brief overview of DevOps, laying the foundation for your understanding. Following that, we will dive into version control by exploring Git, including its installation and setup. Next, we will introduce GitHub and learn how to use this platform effectively. We will then move on to the CI/CD pipelines, followed by understanding what Jenkins is and going through the Jenkins files, the installation and setup procedure. Afterward, our focus will shift to DevOps tools such as Docker, Kubernetes, Terraform, and Ansible, which empowers teams to automate, accelerate, and collaborate in the software development and deployment journey. As we move forward, we will explore Prometheus. In this section, we will explore topics such as continuous monitoring with Prometheus, its architecture and installation. We will also explore AWS DevOps, where you will gain the expertise in building CI/CD pipelines on Amazon Web Services. Additionally, we will dive into Azure DevOps and its key components. As we conclude this course, we will provide insight into DevOps engineer salaries and share essential DevOps interview questions to help you succeed in the DevOps interviews. Before we begin, please consider subscribing to our YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also, visit the Edureka website for DevOps training and certification courses, the link to which is in the description box below.
What is DevOps? DevOps is basically a combination of two words, development and operations. So what do we get when we combine these two? Simply speaking, DevOps is a culture that implements technology in order to promote collaboration between development and operations team to deploy code to production faster in an automated and repeatable way. The goal of DevOps is to increase an organization's speed when it comes to delivering applications and services. Many companies have successfully implemented DevOps to enhance their user experience. Let's take for example, Facebook's mobile app, which is updated every 2 weeks, effectively telling users, you can have what you want and you can have it now. Ever wondered how Facebook is able to do this so smoothly? It's the DevOps philosophy that helps Facebook ensure that its apps aren't outdated and that its users get the best experience. Facebook accomplishes this through a code ownership model that makes its developers responsible. That includes testing and supporting through production and delivery for each kernel of code they write and update. It's through policies like this that Facebook has developed a DevOps culture and has successfully accelerated its development lifecycle. Industries have started to gear up for the digital transformation by shifting their needs to weeks and months instead of years while maintaining high quality. As a result, we will soon see that DevOps engineers have more access and control of the end user than any other person in the enterprise. So what are you waiting for? Don't be in the sidelines when that happens. To master your skills, enroll in Edureka's DevOps Certification program and become a leader.
Why do we need DevOps? The birth of DevOps occurred when there were some drawbacks with the existing software development models for application development. The first model we'll be addressing today is the waterfall model. So the waterfall model is a model of software development which is pretty straightforward and linear. So this model follows a top-down approach, as you can see in the image. It has various phases starting with requirements gathering and analysis. So the first phase is where you get the requirements from the client for developing an application. So after this, you try to analyze these requirements that you've acquired. Next comes the design phase where you prepare a blueprint of the software. So in this phase, you think about how the software is actually going to look like. Once the design is ready, you proceed further with the implementation phase where you begin with the coding for the application. So here the team of developers work together on various components of the application. And once the application is developed, it is tested in the verification phase, that is the fourth phase. Here there are various tests conducted on the application such as unit testing, integration testing, performance testing, etc. After all of these tests on the applications are done, it is finally deployed on the production servers. At last, that is the fifth phase, is the maintenance phase. So in this phase, the application is monitored for performance. So any issues related to the performance of the application are resolved in this phase. But unfortunately, this model, that is the waterfall model, has some major drawbacks. So the first drawback is gathering and documenting your requirements each step of the way can be extremely time consuming, not to also mention difficult. It is hard to assume things about your product so early into the project. And because of the same reason, your assumptions might be flawed and different from what the customer expects. The second drawback is that now, if the above case is true, your customers are basically dissatisfied with your delivered product. Adding changes to the product can be expensive and most of all difficult to implement. So the third drawback is that in general, the risk is extremely high with the waterfall approach because the scope for mistakes is extremely high. If things go wrong, fixing them can be hard as you have to go a couple of steps back. The next model is the agile model. So agile is an iterative based software development approach where the software project is broken down into various iterations or sprints. So every iteration has phases like the waterfall model, such as requirements gathering, design, development, testing, and maintenance. You can see each of these iteration in the image. So each of this iteration generally lasts for about 2 to 8 weeks. So the difference between agile and waterfall model is that you release the application with some high priority features in the first iteration. After its release, the end users or the customers can give you feedback about the performance of the application. So the necessary changes are made to the application along with some new features. And once these features are added to this application, it is again released, which is in the second iteration. This procedure is repeated until the desired software quality is finally achieved. Now, in spite of being used often, the agile method has a few disadvantages. The first one is that for the approach to work, all the members of the team must be completely dedicated to the project. That is, everyone must be involved equally if you want the whole team to learn and do better on the next run. And this is mainly because Agile focuses on quick delivery. There might be an issue with hitting deadline. The second drawback is that the approach may seem extremely simple, but it is hard to execute. So it requires commitment and for everyone to be on the same page, ideally in the same physical space. The third drawback is that documentation can sometimes be ignored. Because agile methodology focuses on working software over comprehensive documentation, things might sometimes get lost through each stage and iteration. As a result, the final product can feel different from what it was first planned. So these are the few drawbacks that the agile model or the agile methodology gives us. So in delivering valuable software to customers, development and operation teams are always in conflict with each other. While development wants to deliver its changes to customers quickly, operations want stability, which means not changing the production systems too often. So the gap between the development and operations team occurs on three different levels. The first one is the incentives gap. This is because of different goals of development and operations. The second one is the process gap, which is the result from different approaches of development and operations and how to manage changes, bring them to production, and maintain them there. The third one is the tools gap, which results from the fact that development and operations often use their own tools to do their own work. And this is resulting from the fact that development and operations often use their own tools to do their work. As a result, from all of these reasons, development and operations often act like silos, as they are two distinct teams. So the conflict between development and operations is because of two reasons. The first one is need for change. This is because development results in change. That is, they're always working on new features, bug fixes, etc. It wants the change to quickly roll out to production. And the second one is fear of change. Once the software is finally delivered, the operations department avoids making changes to the software to ensure stability. This is the major conflict between both of these teams. So this is where DevOps comes into picture. DevOps links software development to operations. I hope that is clear. That is, DevOps bridges the gap between agile software development and operations experiences. It is important to know that DevOps is a set of principles to break down silos. Specifically, DevOps is all about culture, automation, measurement, and sharing. So the first one is culture. So in culture, people and processes comes first. If you don't have a culture, all automation attempts will be fruitless. The relationship is important in culture because its functions include engage early, engage often, destroy silos, be open to options, and stop blaming. And the second one is automation. So once you understand your culture, you can simply start with automation, right? Now you can finalize various tools to achieve automation for DevOps. That is tools for release management, provisioning, configuration management, systems integration, monitoring and control, and orchestration becomes extremely important pieces for DevOps. The third is measurement. So if you cannot measure, you cannot improve. Makes sense, right? A successful DevOps implementation will always measure everything it can as often as it can. Performance metrics, process metrics, people metrics, capacity planning, trend analysis, fault finding, etc. All of these have to always be measured. So the last one is DevOps is about sharing. Sharing is the loop back in the cycle. So creating a culture where people share ideas and problems is extremely critical. So exposing ideas can create great open feedback that in the end it helps to improve shared ideas, share metrics, give DevOps shell access, see what technology can be leveraged, etc. So DevOps is all about these four particular features. I hope this is clear. So now let's move on to the next part of today's session, that is Introduction to DevOps. So finally, we will address what is DevOps. DevOps is simply a combination of two words. You can see that. One is the software development and the second one is operations. So this allows a single team to handle the entire application lifecycle. That is from development to testing, deployment, and finally operations. So DevOps really helps you to reduce the disconnection between software developers, quality assurance engineers, and system administrators. That is, it basically promotes collaboration between the development and operations team to deploy code to production faster in an automated and repeatable way. So DevOps basically helps to increase organization speed to deliver applications and services. It also allows organizations to serve their customers better and compete more strongly in the market. It can be also defined in another way, that is, it is also a sequence of development and IT operations with better communication and collaboration. So, in the market, it has become one of the most valuable business disciplines for enterprises or organizations. With the help of DevOps, the quality and speed of the application delivery has improved to an extremely great extent. Organizations that have adopted DevOps notice a 22% improvement in software quality and a 17% improvement in application deployment frequency. They have also achieved a 22% hike in customer satisfaction. Overall, a 19% of revenue hikes as a result of the successful DevOps implementation has been achieved. Moving on, DevOps workflow is another important concept. So, what is a DevOps workflow? So, it basically provides a visual overview of the sequence in which input is provided. Also, it tells about which one action is performed and output is generated for an operations process. So basically, DevOps workflow allows the ability to separate and arrange the jobs which are top requested by the users. Also, this workflow gives the ability to mirror their ideal process in the configuration jobs. Moving on, let's see some of the DevOps principles. So the main principles of DevOps are continuous delivery, automation, and fast reaction to the feedback. But there are 6 other principles that we'll be discussing today. The first one is the end-to-end responsibility. So DevOps teams need to provide performance support until they become the end of life. It enhances the responsibility and the quality of the products engineered. The second one is continuous improvement. DevOps culture focuses on continuous improvement to minimize waste. That is, it continuously speeds up the growth of the products or the services that has been offered. The third one is automate everything. Automation is an essential part of the DevOps process. We'll be discussing about this later on in this session. This is for the software development and also for the entire infrastructure landscape. The fourth one is custom-centric action. So the DevOps team must be customer-centric so that they should continuously invest in products and services. The fifth one is monitor and test everything. The DevOps team needs to have robust monitoring and testing procedures. The last one is work as one team. In the DevOps culture, role of the designers, developers, and testers are already defined. So all they need to do is work as one team with complete collaboration. These principles are achieved through several DevOps practices, which include frequent deployments, quality assurance automation, continuous delivery, validating ideas as early as possible, and in-team collaboration. Moving on, if you want to become a DevOps engineer or be a part of this ideology, it is extremely important for you to be familiar with some DevOps related tools. Today, I will be talking about 7 important DevOps tools. Now, before we understand the tools DevOps engineers use, it is important to understand containers. So, what are containers? Containers allow you to package your application and its dependencies together into one manifest that can be version controlled, allowing for easy replication of your application across developers on your team and machines in your cluster. This is exactly why container-based microservices architectures have profoundly changed the way development and operation teams test and deploy software. Containers really help companies modernize by making it easier to scale and deploy applications. But they have also introduced new challenges and complexity by creating an entirely new infrastructure ecosystem. IT companies are now deploying thousands of container instances daily, and that's a complexity of scale they have to manage. How do they do it? Here is where Kubernetes comes to the rescue. Kubernetes is a container management technology developed in Google to manage containerized applications in different kinds of environments, like physical, virtual, cloud infrastructure, etc. So it really is just an open source system which helps in creating and managing containerization of applications. Its container management responsibilities include container deployment, scaling and descaling of containers, and container load balancing. It is extremely important to remember that Kubernetes is not a containerization platform, it is a multi-container management solution. Now let's move on and discuss some of the features of Kubernetes. The first one is automated scheduling. So Kubernetes provides an advanced scheduler to launch containers on cluster nodes based on their resource requirements and other constraints, while not sacrificing availability. The second feature is self-healing capabilities. So Kubernetes allows you to replace and reschedule containers when nodes die. It also kills containers that do not respond to user-defined health checks and does not advertise them to clients until they are ready to serve. The third feature is automated rollouts and rollback. So what Kubernetes does is it rolls out changes to the application or its configuration while monitoring your application health to ensure it does not kill all your instances at the same time. So if something goes wrong with Kubernetes, you can simply roll back the change. The fourth feature is horizontal scaling and load balancing. Kubernetes can scale up and scale down the application as per the requirements with a simple command, using a user interface or automatically based on CPU usage. Now let us understand the architecture. The Kubernetes architecture has two main components. The first one is the master node, the second one is the worker node. So the master node is responsible for the management of Kubernetes cluster. It is mainly the entry point for all administrative tasks. There can always be more than one master node in the cluster to check for fault tolerance. So there are few components in the master node that I'd like to discuss. The first one is the API server. So here the API server is the entry point for all the REST commands used to control the cluster. The second one is the controller manager. It is a daemon that regulates the Kubernetes cluster and manages different non-terminating control loops. The third one is the scheduler. So the scheduler schedules the tasks to worker nodes. So what it really does is it stores the resource usage information for each worker node. The fourth one is the etcd. So the etcd is simple distributed consistent key value store. So what it mainly is used for is to share configuration and service discovery. Now that we know how the master nodes work, let's move on to the worker nodes. So these worker nodes contain all the necessary services to manage the networking between the containers, communicate with the master node, and assign resources to the scheduled containers. So the first component that I'll be talking about in this worker node is the Docker container. So Docker runs on each of the worker nodes and runs the configured pods. The second one is the kubelet. The kubelet gets the configuration of a pod from the API server and ensures that the described containers are up and running. The third one is kube proxy. So kube proxy acts as a network proxy and a load balancer for a service on a single worker node. The fourth one is pods. So a pod is one or more containers that logically run together on nodes. With this, we come to the end of the first tool in DevOps tool. Let's move on to the second tool, that is Docker. So what is a Docker? Docker is simply a containerization platform that packages your application and all its dependencies together in the form of containers to ensure that your application works seamlessly in any environment. So each application here will run on a separate container and will have its own set of libraries and dependencies. It must be really convenient to move around these containers, right? So containers also ensures that there is a process level isolation, meaning each application is independent of other applications, giving developers surety that they can build applications that will not interfere with one another. Now, the quality assurance team need not install all the dependent software and applications to test the code, and this helps them save lots and lots of time and energy. This also ensures that the working environment is consistent across all the individuals involved in the process, starting from development to deployment. So here the number of systems can be scaled up easily and the code can be deployed on them effortlessly. There are some basic concepts of Docker you must be aware of. That is Dockerfile, DockerImage, and Docker container. So a Docker image is created by the sequence of commands written in a file called Dockerfile. When this Docker file is executed using a Docker command, it results into a Docker image with a name. So finally, when this image is executed by Docker run command, it will by itself start whatever application or service it must start on its execution. So I hope Dockerfile, Docker images, and Docker containers are clear. We'll understand what is Docker Hub now. So Docker Hub is basically a cloud registry where you can find Docker images uploaded by different communities. Also, you can develop your own image and upload on Docker Hub, but first you need to create an account at Docker Hub. So let's move on and understand what a Docker engine is. So the Docker engine is the heart of the system. It is simply the application that is installed on your host machine. Basically, it works like a client-server application. It uses a server, which is a type of a long-running program called a daemon process. It also uses a command line interface client. And finally, it uses an REST API, which is used for communication between the CLI client and Docker daemon. As per the image, in a Linux operating system, there is a client which can be accessed from the terminal and a host which runs the daemon. We build our images and run containers by passing commands from the CLI client to the daemon. However, in the case of Windows or Mac, there is an additional toolbox component inside the Docker host. So this Docker toolbox is an installer to quickly and easily install and set up a Docker environment on your Windows or your MacBook. So this toolbox installs Docker client, machine, Compose, which is only present in Mac, and VirtualBox. With this, we come to the end of Docker. We'll move on to the third tool of DevOps tools, that is Git. So Git is an extremely important tool for software developers. It is a free open source distributed version control system designed to handle everything from small to very large projects with speed and efficiency. It was created by Linus Torvalds in 2005 to develop Linux kernel. Git has the functionality, performance, security, and flexibility that most teams and individual developers need. It also serves as an important distributed version control DevOps tool. So Git is primarily used to manage a project comprising a set of code or text files that may change over time. Now, before we go further, let us take a step back to learn about version control systems and how Git came into existence. So version control is the management of changes to documents, computer programs, large websites, and other collection of information. There are basically two types of version control systems. The first one being centralized version control system. The second one is distributed version control system. So Git is a distributed version control system where every contributor, that is the user, has a local copy or clone of the main repository. What is a repository? A repository is simply a storage space for your project files. Here, everyone maintains a local repository of their own which contains all the files and metadata present in the main repository. So the local repository is usually on the local machine of the user. So every programmer maintains a local repository, which is actually the copy or clone of the central repository on their hard drive. The central repository may be present on a web hosting platform like GitHub. They can commit and update the local repository without any interference. They can also update their local repositories with new data from the central server by an operation called pull and affect changes to the main repository by an operation called push from the local repository. So I hope everyone understood how Git works. Now moving on, let us understand the role of Git in DevOps. So Git plays a very vital role when it comes to managing the code that the collaborators contribute to the shared repository. So this code is then extracted for performing continuous integration to create a build and test it on the test server and eventually deploy it to the production. Tools like Git enable communication between the development and the operations team. When you're developing a large project with a huge number of collaborators, it is extremely important to have communication between the collaborators while making changes within the project. Commit messages in Git play a very important role in communicating among the team. The bits and pieces that we all deploy lies in the version control system like Git. To succeed in DevOps, you need to have all of the communication in version control. Hence, Git plays a very vital role in succeeding at DevOps. Now let's move on to the next tool, that is Selenium. Selenium is one of the most widely used open source web user interface automation testing suite. It was originally developed by Jason Huggins in 2004 as an internal tool at ThoughtWorks. So Selenium supports automation across different browsers, platforms, and programming languages. So this tool can be easily deployed on platforms such as Windows, Linux, Solaris, and Macintosh. Moreover, it supports operating systems for mobile applications like Windows and Android. Selenium supports a wide variety of programming languages through the use of drivers specific to each language. Languages supported by Selenium include C#, Java, Perl, PHP, Python, and Ruby. Currently, Selenium WebDriver is the most popular with Java and C#. Selenium test scripts can be coded in any of the supported programming languages and can be run directly in most modern web browsers. Browsers supported by Selenium include Internet Explorer, Mozilla Firefox, Google Chrome, and Safari. So basically, it can be used to automate functional tests and can be integrated with automation test tools such as Maven, Jenkins, and Docker to achieve continuous testing. It can be also integrated with tools such as TestNG and JUnit for managing test cases and generating reports. So now moving on, what are the advantages of Selenium? Why should we choose Selenium? Since Selenium is open source, there is no licensing cost involved, which is a major advantage over other testing tools. There are many other reasons behind Selenium's ever-growing popularity. The first one is that test scripts can be written in any of the programming languages, that is Java, Python, C#, PHP, Ruby, Perl, .NET, etc. Tests can also be carried out in any of the operating systems, that is Windows, Mac, or Linux. Tests can also be carried out using any browser, that is Mozilla Firefox, Internet Explorer, Google Chrome, Safari, Opera. We've all discussed this in the previous slide. And the last use is that it can be integrated with Maven, Jenkins, and Docker to achieve continuous testing. So in short, Selenium can be used for automated testing. Also, because it has cross-browsers compatibility, it is more preferred. And it also increases test coverage and reduces test execution time. Now moving on, let us understand an important concept in Selenium, that is the Selenium Grid. Selenium Grid was developed by Patrick Lightbody and initially called it Hosted QA. It was used in a combination with remote control to run tests on remote machines. In fact, with Grid, multiple test scripts can be executed at the same time on multiple machines. Parallel execution is achieved with the help of hub node architecture. One machine will assume the role of hub and the others will be the nodes. Hub controls the test scripts running on various browsers inside various operating systems. Test scripts being executed on different nodes can be written in different programming languages. Grid is still in use and works with both WebDriver and remote control. So we'll be learning about the WebDriver in the next slide. However, maintaining a grid with all required browsers and operating systems is a very huge challenge. For this, there are multiple online platforms that provide an online Selenium grid that lets you access to run your Selenium automation scripts. For example, you can use Lambda Test. It has more than 2000 browser environments over which you can run your tests and truly automate cross-browser testing. Now let's understand what is Selenium WebDriver. Selenium WebDriver is a web-based automation testing framework that can test web pages initiated on various web browsers and various operating systems. In fact, you also have the freedom to write test scripts in different programming languages like Java, Perl, Python, etc. It is important to remember that Mozilla Firefox is Selenium WebDriver's default browser. Now, some benefits of Selenium WebDriver are that they support 7 programming languages, they test on various browsers, and they work on different operating systems. Also, it overcomes limitations of Selenium version 1, like file upload, download, pop-ups, and dialogues barrier. Now, let's move on to the next most important tool, that is Jenkins. Continuous integration is the most important part of DevOps that is used to integrate various DevOps stages. Jenkins is the most popular continuous integration tool. It is an open source automation tool written in Java with plugins built for continuous integration purposes. Jenkins is basically used to build and test your software projects continuously, making it easier for developers to integrate changes to the project and making it easier for users to obtain a fresh build. It also allows you to continuously deliver your software by integrating with a large number of testing and deployment technologies. So basically with Jenkins, organizations can accelerate the software development process through automation. Jenkins integrates development lifecycle processes of all kinds, including build, document, test, package, stage, deploy, static analysis, and much more. So this tool also achieves continuous integration with the help of plugins. Plugins are extremely important. It allows the integration of various DevOps stages. If you want to integrate a particular tool, you need to install that particular plugin for that tool. For example, Git, Maven to Project, Amazon EC2, HTML Publisher, etc. There are many advantages of Jenkins, and I'd want to discuss each one of them in detail. So the first one is it is an open source tool with a great community support. The second one is it is extremely easy to install. The next one is it has more than 1000 plugins to ease your work. Now, if a plugin does not exist, you can simply code it and share it with the community. The fourth advantage is it is free of cost. The last one is it is built with Java. Now, if you have been coding for some time now, you must be knowing that Java is portable to all the major platforms. So this gives an added advantage to Jenkins. So what makes Jenkins different from the other continuous integration tools? There are two reasons. The first one is adoption, the second one is plugins. So Jenkins is widespread with more than 147,000 active installations and over 1 million users around the world. The adoption of Jenkins is extremely high. The second one is that Jenkins is interconnected with well over 1,000 plugins that allow it to integrate with most of the development, testing, and deployment tools. So these two features, that is adoption and plugins, make it one of the best continuous integration tools currently available in the market. Now let's move on to the next tool of DevOps tools, that is Puppet. Today, the most mature tool for configuration management is Puppet. But I know you must be wondering why Puppet is so popular and what makes it unique when compared to other configuration management tools. Puppet is a configuration management tool that is used for deploying, configuring, and managing servers. So now let's understand the functions of Puppet. So the first one is it helps in defining distinct configurations for each and every host. And it also continuously checks and confirms whether the required configuration is in place and is not altered on the host. The second function is dynamic scaling up and scaling down of machines. The last one is it provides control over all your configured machines. So a centralized change gets propagated to all automatically. Puppet basically uses a master-slave architecture in which the master and slave communicate through a secure encrypted channel with the help of SSL. Now let's see this architecture in detail. So as you can see the diagram on the screen, the Puppet agent sends the facts to the Puppet master. Facts are basically key value data pair that represents some aspect of the slave state, such as its IP address, uptime, operating system, or whether it's a virtual machine. Puppet master uses the facts to compile a catalog that defines how the slave should be configured. Catalog is a document that describes the desired state for each resource that Puppet master manages on a slave. Puppet slave reports back to the master indicating that the configuration is finally complete, which is visible in the Puppet dashboard. Now with this we come to the last tool of DevOps, NAG-IOS. NAG-IOS monitors your entire IT infrastructure to ensure systems, applications, servers, and business processes are functioning properly. It is an integral to the DevOps lifecycle. So it is basically used for continuously monitoring of systems, applications, servers, and business processes in a DevOps culture. So in the event of a failure, NAG-IOS can alert technical staff of the problem, allowing them to begin remediation processes before outages affect business processes, end users, or customers. With this tool, you don't really have to explain why an unseen infrastructure outage affects your organization's bottom line. NAG-IOS runs on a server, usually as a daemon or a service. It periodically runs plugins residing on the same server. They contact hosts or servers on your network or on the internet. One can view the status information using the web interface. You can also receive email or SMS notification if something happens. The NAG-IOS daemon behaves like a scheduler that runs certain scripts at certain moments. It stores the results of those scripts and will run other scripts if these result changes. NAG-IOS also use plugins. So these are compiled executables or scripts that can be run from a command line to check the status or a host or a service. NAG-IOS also uses the results from the plugins to determine the current status of the hosts and services on your network. NAG-IOS is built on a server or agents architecture. Usually on a network, a NAG-IOS server is running on a host, and plugins interact with local and all the remote hosts that need to be monitored. So these plugins will send information to the scheduler, which displays that in a graphical user interface. With this, we come to the end of DevOps tools. Let's move on to the next part of the session, that is DevOps automation. Automation is the crucial need for DevOps practices, and automating everything is the fundamental principle of DevOps. We discussed this initially in the session. Automation kickstarts from the code generation on the developer's machine until the code is pushed to the code, and after that to monitor the application and system in the production. Automating infrastructure setup and configurations, software deployment is the key highlight of DevOps practice. DevOps practice is dependent on automation to make deliveries over a few hours and make frequent deliveries across platforms. Automation in DevOps boosts speed, consistency, higher accuracy, reliability, and increases the number of deliveries. Automation in DevOps encapsulates everything right from the building, deploying, and monitoring. In large DevOps teams that maintain extensive, massive IT infrastructure, the tools can be classified into 6 categories. That is infrastructure automation, configuration management, deployment automation, performance management, log management, and monitoring. So for infrastructure automation, a great example is the Amazon Web Services. Being a cloud service, you don't really need to be physically present in the data center. They're easy to scale on demand, and there are no upfront hardware costs. It can also be configured to provide more servers based on traffic automatically. For the second one, Chef is a great example. Chef is a handy DevOps tool for achieving speed, scale, and consistency. It can be used to ease out complex tasks and perform configuration management. With the help of this tool, the DevOps team can avoid making changes across 10,000 servers. Rather, they need to make changes in one place, which is automatically reflected in other servers. For deployment automation, Jenkins is a great example. As we have already discussed before, it helps facilitate continuous integration and testing. It integrates project changes more efficiently by quickly finding issues as soon as builds are deployed. For the fourth one, that is performance management, Application Dynamic is a great example. It offers real-time performance monitoring The data that is collected by this tool helps developers to debug whenever an issue occurs. The fifth one, that is for log management, Splunk is a great example. This DevOps tool solves issues such as storing, aggregating, and analyzing all logs in one place. So for the last one, that is monitoring, Nag iOS is a great example. It notifies people when infrastructure and related services go down. It is a tool for this purpose which helps the DevOps team to find and correct problems immediately.
Let's start out with what's version control. So to understand what is version control system, we need to understand first why we need a version control system. So we'll see why do we exactly need a version control system. So for that, let's take a scenario where there are 3 developers working remotely on a web application or a mobile application. Now for simplicity's sake, let's just assume that it is a streaming application and one of them is working on a streaming page. Let's call them developer 1. Developer 2 is working on a user information page and developer 3 is creating the payment portal. Now all 3 of them are done with their respective pages at 10 o'clock, 11 o'clock and 12 o'clock respectively. Now the thing is, all 3 developers are working in isolation. There may be their own changes, there may be changes in somebody else's page. They're all kind of adding some new files or modifying older files, changing the source code or something like that throughout the course of this project. But how exactly are they going to collaborate considering that they are working remotely? The solution to this is a version control system. With this system, I'll tell you what happens. At 10 o'clock, developer 1 uploads all the files regarding the streaming page. With a version control system, this modification is recorded and updated to one central directory or folder. So every time you're modifying an older file or adding a new file, it creates a snapshot of the latest version or the latest update of the changes that you've made or all the files that you've uploaded. So the snapshot of your update at 10 o'clock is saved, and then when developer 2 adds their user info page, this modification is also saved as a snapshot. Now there are 2 snapshots saved, and finally the payment portal page is added, and this is the last modification done at 12 o'clock, and this is the most recent snapshot saved, along with other snapshots of other updates and modifications done throughout the course of this project. Every change in your project, a snapshot is created and your entire project is saved that way. And these snapshots are actually known as different versions, which are basically the state of your project at a particular time or at the current time. It means that it will contain the kind of files your project is storing at one particular time and what kind of changes you have made so far between the previous version and this particular version. And this is exactly how a version control system works. So version control system basically is a system that records changes to a file or a set of files over time so that you can record specific versions later. These versions are recorded in a repository and they can be recalled anytime from these repositories during the course of your project. So version control systems essentially are of 3 types. Now the local version control system is one of the simplest forms of VCS and has a database that keeps all the changes of the files under revision control. So all the files are saved by this one user and they manage all of the files. But it's actually really hard to maintain the changes of the file and you can accidentally replace one or the other file that you need. It also needs something known as RCS or revision control system, which keeps patch sets or the differences between updates in a special format on your disk. All of this, your local version control systems maintains all the track of all the files within your local system. As a user, you can track specific versions later, and it basically works as an independent standalone system for an application. So your applications like spreadsheets and word processors have this control mechanism. So that's one type. Apart from this, you also have your centralized version control system, which basically uses a central server to store all the files and enables team collaboration. So it's not one local system, but multiple systems which work on a single repository to which users can directly access as a central server. So the repository is a central server that could be local or remote, which is directly connected to each of the programmer's workstation. And the third kind of VCS is a distributed version control system. Now, these systems do not necessarily rely on a central server to store all the versions of a project file. In a distributed version control system, every contributor has a local copy or a clone of the main repository. So everyone maintains their own local repository, which contains all the files and the metadata present in the main repository. And they can push or commit or update the main repository if and when required. Now we are going to cover more on the latter two version control systems further in the session. So now let's try and understand in depth what's the difference between a centralized version control system and a distributed version control system. As I had mentioned before, in a centralized version control system, each programmer working on a branch on a project has absolute access to the central server. So the centralized version control system uses a central server to store all the files, and everybody on the team can directly access the central server as it is one single repository. So if you have 3 workstations, workstation 1, workstation 2, workstation 3, all of them can directly commit to the repository and get updates from the repository, which is your central server. The repository here indicates a server that could be local or remote, directly connected to each programmer's workstation. Every programmer can extract or update their workstations with the data present in the repository, or can make changes or updates or commit in the repository. And every operation is performed directly on this repository. Even though this seems pretty convenient when we are just talking about 3 people, to maintain a single repository like this has some major drawbacks. One of them is that it's not locally available, meaning every change that you have to make, you will have to be connected to a network to perform any action. Also, in any case, the central server getting crashed or corrupted will result in losing the entire data of the project. Also, another small thing which is revertible, but is if one person accidentally makes some unwanted updates. Instead of his or her local system, they will be making that changes directly in the central server. So recovering that part back will be again a time-consuming process. This is where distributed version control systems come to the rescue. Now, these systems do not necessarily rely on a central server to store all the versions of a project file. In the distributed version control system, each and every contributor has a local copy or a local workstation clone of the main repository. That is, everybody maintains a local repository of their own which contains all the files and metadata present in the main repository. You will understand it better if you take a look at the diagram. As you can see, every programmer maintains a local repository or a local copy on its own, which is actually the copy or clone of the central repository on their local hard drive. They can commit and update their local repository without any interference from one another. And then they can update their local repositories with new data from the central server by an operation called pull. Once they are done with their bit of the code, they can affect the changes of the main repository by an operation called push from their local repository. Now, this system or this act of cloning an entire repository to your workstation and making all the changes on a local repository gives you a couple of advantages over a centralized version control system. First of all the operations except push and pull are very fast because the tool only needs access to the hard drive and not a remote server. Hence, you do not always need to be connected via a network connection, or you always do not need an internet connection. Committing new change sets can be done locally without manipulating the data on the main repository. Once you have a group of change sets ready, you can push them all at once. So you complete your set of code on your local system and then you push all the files once and for all into the main repository. Third, since every contributor has a full copy of the project repository, they can share changes with one another on wanting to get some feedback before affecting the changes in the main repository. So this enhances the essence of collaboration amongst a development team. And finally, if the server gets crashed at any point in time, the lost data can be easily recovered from one of the contributors' local repository. And that is why distributed version control system has been picking up popularity over the past decade. So why version control is important? First of all, it helps collaboration. It allows remote development, shared workspace, and real-time updates. All versions of your code are preserved, hence it helps you manage versions of the same code. Easy rollback from current version. Suppose a part of your project has been headed to a wrong direction, you can easily roll back from the current version to the last version which was stable. Now, because you can reverse faulty updates, you can save time and hence it reduces downtime of your project development. And finally, it improves visibility. You can analyze and compare different versions, and that gives you like a 50-foot top view of your entire project, which just accelerates your product delivery. So now that you have a bare sense of what is version control and why do you need version control, let's understand one of the most popular version control systems that exists today, and that is Git. So Git is a distributed version control tool that supports distributed nonlinear workflows by providing data assurance from developing quality software. So basically what it does is that it lets you and your team of developers work together on the same project remotely from anywhere across the world. Your team members can work efficiently on files and easily merge their changes into one source without the fear of losing or deleting anything of importance due to the easy rollback feature. Git is primarily used to manage your project comprising of a set of code or text files that you may want to change from time to time. Now, Git is an integral part of DevOps. DevOps, as most of you might have the idea of, is the practice of bringing agility to the process of development and operations. A couple of years ago, it was this entirely revolutionary ideology which swept IT organizations worldwide, boosting project life cycles and in turn increasing profits. DevOps promoted communication between development engineers and operations participating together in the entire life cycle, from design through development process to production support. Now, in the entire life cycle of DevOps, starting from planning of the projects to its deployment and monitoring, Git plays a vital role. When it comes to managing the code that collaborators contribute to the shared repository, this code is extracted for performing continuous integration to create a build and test it on the test server and eventually deploy it to production. Tools like Git enable communication between the development and operations team. When you are developing a large project with a huge number of collaborators, it is extremely important to have communication between the collaborators, between the developers while making changes in the project. Commit messages in Git play a very important role in this particular collaboration or communication amongst the team. The bits and pieces that we deploy or update lies in this version control system, such as Git. To succeed in DevOps, you need to have all the communication in version control. Hence, Git plays an extremely vital role in succeeding at DevOps. And due to this very reason, Git has earned way more popularity compared to other version control tools available in the market, such as Apache Subversion, concurrent version systems, and Mercurial. If you compare the interest of Git by time with other version control systems, you shall realize that larger companies' products are generally developed by developers using Git all around the globe. And some famous names out of them are Facebook, Yahoo, Zynga, Quora, Twitter, eBay, Salesforce, Microsoft, and many, many more. Now, lately, all of Microsoft's new development work has been in Git features. Microsoft migrating .NET and many of its open source projects on GitHub, which are managed by Git. One of such projects is the LightGBM. It's a fast, distributed, high-performance gradient boosting framework based on the decision tree algorithms, which is used for ranking, classification, and many other machine learning tasks. Here, Git plays an important role in managing this distributed version of LightGBM by providing speed and accuracy. So basically, to enable version control, Git is your go-to solution. It's fast and suitable for handling massive code bases scattered across multiple developers, which makes it the most popular tool used today. Now that you know about Git, a terminology we'll be using a lot while talking about Git and GitHub is a repository. Now, repository, or a repo as it's most commonly known as, is a directory or a storage space where your projects can basically live. It can be local to a folder or your computer, or it can be a storage space in another online host such as your GitHub. And in this particular space, in this particular directory, you can keep your code files, text files, images, you name it, all of it inside a repository. Through the course of this, we shall also be talking about something known as GitHub, which is nothing but a central repository, the kind that we spoke about when we discussed centralized versus distributed version control systems. There's a central repository, and that is where all of your code will live. You have your local repository where you'll make the changes, and there you have the central repository to which you will push all of the changes. Yeah? And the central repository is something that all of the developers involved in this particular project, in a certain project, have access to. All right, moving on, let's discuss a few Git features which make it so popular amongst organizations as well as individuals. First of all, it's economical. It's free and open source. Git is released under GPL's General Public Licenses, open source license, so you don't need to purchase Git. It is absolutely free, and since it's open source, you can modify the source code as per your requirement. Second is its speed. Now, since you do not have to connect to any network for performing all of the operations, it completes all the tasks really fast. Performance tests done by Mozilla showed it was an order of magnitude faster than other version control systems. Fetching version history from locally stored repository can be 100 times faster than fetching it from the remote server. So the core part of Git is written in C, which avoids runtime overheads associated with other high-level languages, which makes it extremely fast compared to other version control systems. Next is that Git supports non-linear development. Git supports rapid branching and merging and includes specific tools for visualization and navigation of a non-linear development history. A core assumption in Git is that a change will be merged more often than it's written, as it is passed around various reviewers. Hence, branches in Git are very lightweight and is only a reference to a single commit. With its parental commits, the full branch structure can be constructed. Next, let's talk about the robustness. Nearly every single task in Git is undoable. Git gives each developer a local copy of the entire development history and the changes copied from one repository to another. These changes are imported as additional development branches and can be merged and deleted and recovered the same way as a locally developed branch. Next is the snapshots, which are recorded changes made to a file rather than the file itself. Followed by which you have integrity, which means no changes can be made without Git recording it. Since every contributor has their own local repository, on the events of a system crash, the lost data can be recovered from any of the local repositories. You will always have a backup of all of your files, and none of the changes made to the central repository will go unlogged by Git. Git uses the SHA-1 or the secure hash function to name and identify objects within its repository, and every file, every commit is checksummed and retrieved by its checksum at the time of the checkout. The Git history is stored in such a way that the ID of a particular version, a commit in Git's terms, depends upon the complete development history leading up to that commit. Once it's published, it's not possible to change the old versions without it being recorded. Then it's a distributed system, which means every user has their own copy of the repository, and the data is stored locally. Git gives each developer a local copy of the entire development history, and the changes are copied from one such repository to another. These changes are imported as additional development branches and can be merged in the same way as a locally developed branch. And finally, it's easy branching. Now, branch management with Git is very simple. It only takes a few seconds to create, delete, and merge branches. Feature branches provide an isolated environment for each change to your code base. So when a developer wants to start working on something, no matter how big or small, they can create a fresh new branch which is not interfering with the main branch, which ensures that the master branch or the main branch always contains production quality code. So any little experimentation that you want to do or little things that you want to try out can always be on a separate feature branch instead of the changes made to your master branch. Because ultimately, your master branch should contain your publishable product. So now that you know the basic features of Git, let's try and understand what the basic workflow of Git is, or how does Git work. So the basic overview of how Git works goes like this. You basically create a repository or a project with a Git hosting tool like Git or Bitbucket. You copy or clone the repository to your own local machine or your working directory. You add a file to your local repository and commit the changes, which basically means you save the changes. Then you push the changes to your master branch. Then you make changes to your file and commit. Then you pull the changes to your local machine. You create a branch or a version, make a change, commit the change, same process, open a pull request, and merge your branch to the master branch. Now, this is a little complicated listening to it like this, but once we get on to our demonstration, I think things will be way more clear. You can still take a good look at this diagram, but if you don't get it, don't worry. I will be explaining these operations one by one when we get to the demonstration part of this Git tutorial. Moving on, let's get to the good part, the hands-on section, starting with the installation and setup of Git. Now, there are two ways in which this goes. First of all, for Windows users, you need to install Git Bash for Windows. And for Linux users, you'll have to start by updating the package index and then install Git using the terminal. So first of all, for our learners using Windows, you'll have to log on to gitscm.com/downloads and then click on Downloads for Windows button and then run the executable file and follow through till you finally install Git Bash. I'm not going to install it completely as I already have Git Bash downloaded, but I'm still going to open the page to show you guys. All right. So the latest source release is Git 2.30.1 on the 8th of Feb, and you can just click on this button. The moment you click on this button, it's going to start downloading Git for you. And once you have the executable file, all you have to do is open it or run it in your own system, right? Next, for people using Linux, this is an example considering you are using Ubuntu. If you're using CentOS, a lot of the commands don't change, but instead of apt install, you will be using yum install for CentOS. So for that, now I'm going to open my terminal on a virtual machine. So here I have running an Ubuntu machine using the Oracle VirtualBox. So I'm going to start by running an update. All right, this is going to take a while. Kindly be patient. So here I have my Ubuntu running on a virtual machine. So to install Git on your Ubuntu machine, you have to start by updating. So this will take some time. If you're going to use sudo apt update, if you're using CentOS, you will be using yum instead of apt. Let's clear that out, and then we're going to install Git. and then you can look for the Git version. Yeah? Alright. Now that we have our Git installed, let's go ahead and look at the operations and commands that we are going to take a look at today. You have your repository setup, which include the commands init, clone, config, and alias. Then you have your save changes operations, which have your add, commit, diff, and stash. All of these commands we are going to go on and off and look at collectively mostly. Then we are going to look at the inspect operations, your inspect repository operations, of which the git status command is something we are also going to look at throughout this demonstration right from the beginning. So apart from that, you have your git log, git tag, and git blame commands. So you have your merge rebase command. So let's move on to our first set of git operations. First of all, you have your git init command, which basically creates a new empty git repository. Now this can be used to convert an existing unversioned project to a git repository or initiate an absolute fresh git repository. Now most other git commands are not available outside of the initialized repository. So this is usually the first command that you will run in a new project. That is, if you're using git bash. So when I run git init, it reinitializes an existing git repository, which I already have here. Now what this does is it reinitialized my existing git repository in this particular directory, in this .git directory. Yeah. What git init does is that it creates an empty git repository or reinitializes an existing one, like it did for me right now. It basically creates a .git directory with subdirectories and template files. And when you run the git init command in an existing repository, it will not overwrite the things that are already there. It will rather pick up the newly added templates. So that's the repository initialized. You can go ahead and create some files in the directory or repository, whatever you call it. Now that is about initialization. Now, what about if there was an existing repository on Git that you had to act upon, that you had to make updates to, that you had to add files to, things like that? That's where you use the git clone utility. Yeah. Now you have the git clone utility, which you use to target an existing repository and create a clone or copy of this particular repository on your local machine. Now this is one of the features provided to you by a distributed version control system, as we had discussed before. So this is a blank file called Edureka rep with just the readme text file. Let me just go ahead and copy this. And then I can just git clone and paste its HTTPS URL. And as you can see, it's cloning this into Edureka rep. And now if I change directory to Edureka rep, you can see the readme file is right there. Yeah. So we're basically going to work off of this particular repository today, Edureka rep. Yeah. So now that we created a clone, moving on, we have the git config command, which basically is a convenience function that is used to set up your git configuration values on your global or local project level. This command is basically used to modify your configuration text file. So if I typed git config global user.email, and here I type, so there I gave in my email ID as the global user email ID. So if I ask for what the global user email ID is, it will return my ID back to me. Yeah. Basically, these configuration levels, like your username and your user ID, correspond to your .git config text files. Now executing this basically will help you modify the configuration text file. Git uses this series of configuration files to determine non-default behavior that you may want. Yeah. So the first place Git looks for these values is in the system-wide configuration file, which contains settings that are applied to every user on this system. So basically, if you pass the option to your Git config, it will read and write from this file specifically. And the next place the Git looks is the config/git config file, which is specific to each user. Now you can make Git read or write to this file by passing your global option, which is what I did. And the final command in the setup operations that we are going to look at is an alias. Now, alias, as the name suggests, is basically used to create shorter commands that map to longer commands. They enable more efficient workflows when you obviously have to use lesser keystrokes to execute a command. There are these lengthy commands which obviously kill a lot of your time. So these aliases you can use to shorten those commands. And these are also something that you will create via the git config command. There isn't really a direct way or a direct command of creating aliases. Yeah, this is just something I wanted to add in here along with the git config command. Like a very common alias created is CO for checkout or anything else, CK for checkout. So yeah, this is something that you can do using the git config command, just creating aliases. Moving on, let's look at operations that you use to add changes and save changes to your Git repository. Now, the first two commands here that we're going to look at are git add and git commit. Now, this combination is basically used to create these snapshots that I was talking about initially in the session, right? So basically what you do is first, you use the git add command to add a change in your current directory or your working directory. And you add that to the staging area. It tells Git that you want to include a particular set of updates or changes in a particular file in the next commit. Then what you do is you move on to git commit after making the changes to your working tree. Then you use the git commit command, which captures a snapshot of your project's current state. So basically, you use add to update the index using the current content found in your working tree. And then you basically prepare the content in the staging area for the next commit. Then you run the commit command to take that snapshot of your project's current status. Now remember, this is very important and you have to do it each time. You must use the add command to add any new modified files to the index. You can't directly commit anything without adding it to the stage area first. Now what I did was I quickly went ahead and added 3 files to my repository Edureka rep. So if I go into this repository, you can see there are 3 files, Edureka file 1, file 2, file 3. Now let's see if these files are in my index or not using the command git status. Now git status basically displays the state of the working directory and the staging area. It will list all the modified files which are ready to be added to the local repository. It lets you see which changes have been staged and which haven't, which files are being tracked by Git and not. So if I typed git status, you can see on your main branch, you have 3 untracked files, which are the 3 files that I just added, Edureka file 1, 2, and 3. These are not added to the index yet. This means I cannot commit these changes unless I added them explicitly to the index. So now we are going to add these 3 files. This command will update the index using the current content, which is found in your working tree, as you can see in front of you. And then it'll prepare the content in the staging area for the next commit. So either I can just git add and put in the directory name, or I can just use git add with an extension of A, which means all, and this will add all of these files to the index which are in the directory but not updated in the index yet. Yeah, now I've done that. Let me go ahead and use git status again, and you can see all of these file names are written in green, and you can see changes to be committed written here, which means all of these changes are ready to be committed. They are added to the index. Now these files are added to the index. You are ready to commit them. Now, as I had mentioned before, we're going to commit them, and committing refers to recording the snapshots of the repository at any given time. So your committed snapshots will never change unless it's done explicitly. So I'm going to clear this, and we're going to commit this by typing git commit and then adding a tag or a message called committing 3 files. Let's try this out. As you can see, 3 files changed, 3 insertions. You can see our Edureka files 1 to 3 have been committed. The git commit command has committed the changes in the 3 files in your local repository. Now, if you want to commit a snapshot of all of the changes in your working directory at once, you can always go with commit-a. Now, let me add a couple more files to my directory just to show you the difference between your files added to the index versus the ones that are not. If I type ls again, you can see there are 2 more files over here. As you can see, I have 2 other files. I'm just going to add the Edureka file 4 and not the file 5. And then I'm just going to git commit committing files. And as you can see, only one file changed, only one insertion happened. And that only happened because Edureka file 5 is not added to the index. And even if I use the extension A, I cannot add Edureka file 5 because that has not been added to your index. Now, if I just go ahead and add Edureka file 5, voila, the change has occurred in our Git repository. Now, if I typed git status, there are no more files to add or commit. Our branch is ahead of the origin or main branch by 3 commits. And you can use git push to publish your local commits. Now, what is git push? This is something we will cover later in this session. Now, understand that before you affect the changes made to the central repository, you should always pull changes from the central repository to your local repository just to get the most updated version of your branch. You'll get all the work of your collaborators that have been contributing in the central repository. For that, you use the pull command. Now, as you can see, there's nothing to commit and your working tree is clean. There are other commands like the git status command, which you could use for similar purposes. For example, you have the git log command, which only operates on committed history. It basically will display to you the committed snapshots and will let you list the project history, filter it, and search for specific changes. So if you typed git log, it's going to show you all the commits that have happened since we started with this git file. Okay, here you can see at the bottom, your original main, there is your initial commit, right? Then our first commit where we committed 3 files, then we committed the 4th file, and finally when we committed file number 5, right? These are all the commits, including the initial commit, the first one. Yeah, along with the author and the date and time. Remember when I told you about everything is recorded when you're using Git? This is what I meant. You can always access who made commits at what time and what commits were made when you use a version control system such as Git. Now, at a point like this, I think it's crucial to mention one more command, which is the git tag, and it's used to basically capture a tag in history or a point in history that is used for a marked version release, right? So it's basically like a branch that doesn't change, and after being created, they have no further history of commits. Yeah, so that is one. And another one is git blame. Now the git blame function displays of the author's metadata attached to a specific committed line in a file. It's used to examine specific points in a file's history and get context as to who the last author was that modified that line. So if I went back and typed git blame Edureka file 5.txt, it's going to show who the person is that is to blame, who committed this particular file or made this particular change, right? It'll also, if you paid attention, give you the commit number. As you can see, this E9D63EFO commit number. This also has this E9D63EFO, which is the first few characters of this particular commit number. Yeah. So now that you know how to check the status of the changes and see who made the changes, it's time that you understand how you fetch changes from your remote repository to a local repository and how you push commits from your local repository to your remote repository. So here we're going to look at two commands called pull and push. Now, first of all, you have the git pull command, which fetches changes from your remote repository to a local repository. Basically, it merges upstream changes in your local repository, which is a common task in Git-based collaborations. But at first, you need to set your central repository as the origin using the command git remote add origin, and I'm going to add the link to my central repository, which is this. And as it says, the remote origin already exists. Now that your origin is set, and now we're going to pull our main branch. So I'm just going to type git pull origin main, and it says we are already up to date. Now, certain number of tutorials or documents that you might be following might even give you the command git pull origin master, in which case you're working on the master branch. Now, to know which branch you're at, you can just use the command git branch vv. Yeah, I'll tell you which branch are you working on. Yeah. So yeah, we are working on the main branch and we are already up to date with the branch since my local repository was already updated with files from the main branch. This is the message of an up-to-date branch. Now you can also use git pull origin and your whatever branch name. Here I'm using main. That's a mistake on my part. Maybe I was trying to clear the screen. All right. So here, even if I pull from the branch using git pull origin and the branch name to my local git repository, you can see it's already up to date. So now my local git repository is now all updated with the recent changes. So now it's time to make the changes to your central repository by using the push command. So we're going to use the push command. This command transfers commits from your local repository to your remote repository. And it is basically the opposite of your pull operations. Pulling will import commits to your local repositories, whereas pushing will export commits to your remote repositories. It's going to ask you for your username. And password before it lets you push into your main branch there. So I've put in the username and password for my GitHub account. And with that, this has pushed the changes from my local repository to the remote repository along with all the necessary commits and internal objects. Now this has created a local branch in your destination repository. The use of git push is to publish your local changes to a central repository. After you've accumulated several local commits and are ready to share them with the rest of the team, you can then push them to your central repository by using the git push command. Now the files which have already been committed previously in the commit section and they were all push ready, you will use git push origin master to reflect these files in the master branch of your repository. All right. So let's go ahead to our repository and see if changes have been made. And yes, you can see all of our files on our GitHub repository. You have Edureka file 1, 2, 3, 4, and 5. All the 5 files that we had created on our local repository. Yeah, you have all these 5 files and the README file here. Here also you have the README file and all the 5 files that we had created. Now at this point in this Git tutorial, I hope you have understood the basic commands of Git. You have pulling, pushing, adding, committing, things like that. Now let's take a step further and understand the 3 basic commands of parallel development. Here I'm going to be talking about branching, merging, and rebasing. So first of all, let's talk about merging. Now, merging is a way to combine the work of different branches together. This will basically allow you to branch off, develop a new feature, and then combine it back in. As you can see in the diagram, it shows you 2 basically different branches, new branch and master. Now, when we merge the work of the new branch into the master, it creates a new commit, which contains all the work of the master and new branch. Now, if we merge the 2 branches with the merge command, as I had mentioned before, Git allows you for easy branching, which means you have parallel branches with your master branch that help you carry on your individual work while not interrupting your main product, which is your master branch or your main branch. So branches in Git are nothing but pointers to specific commits. Yeah. So Git generally prefers to keep its branches as lightweight as possible. Now there are basically 2 kinds of branches via local and remote tracking branches. A local branch is just not the path of your working tree. On the other hand, the remote tracking branches have special purposes. Some of them are linking your work from your local repository to your central repository and automatically detecting which remote branches to get changes from when you do a git pull. So you can check what your local branch is by using git branch. So you know you are at your main branch. And the one thing you should understand, one thing is like a main mantra of people who use Git are branch early and branch often. Yes. So to create a new branch, you're going to use a command git branch and your branch name. And in this case, I'm just going to use a branch name Edureka images. All right. And here you can see this diagram shows the workflow of a new branch that is created. When we create a new branch, it originates from the master branch itself. So since there's no storage or memory overhead with making many branches, it's usually easier to logically divide your work up than having big chunky branches. Hence, the branch often part. Now let's see how to commit using branches. Now branching includes the work of a particular commit along with all parent commits, right? So as you see, the new branch has detached itself from the master or the main branch, and hence it'll create a different path. So we are going to check out the branch name, which in our case is Edureka images. And then we are going to git commit. So you have untracked files, Edureka images, and nothing added. So you made that branch. Now, merging is a way to combine the work of different branches together. So basically what this does is, now that we've branched off to something known as Edureka images, you can go ahead, add files to it, develop a new feature, and then combine it back into your main branch. Here you can see 2 different branches. You have your new branch and your main branch. And when we merge the work of a new branch into the main branch, it creates a new commit, which contains all the work of the main branch and the new branch. So now if we merge this branch, as you can see, it's already up to date. It's important to know that the branch name here should be the branch that you want to merge into the branch that you're currently checking out. So make sure that you are checked out of this destination branch. So let's just merge all the work of the branch Edureka images into your main branch. For that, I will first check out my main branch and then merge Edureka images with git merge Edureka images. And as you can see, all the data from the branch Edureka images has merged into the main branch. Now notice that merging in Git creates a special commit that has two unique parents. Now this is one way of merging into the main branch. There's also another way of combining the work between two branches, which is called rebasing. Now rebasing takes a set of commits, copies them, and stores them outside your repository. The advantage of rebasing is that it can also be used to make linear sequence commits. The commit log or the history of the repository stays clean if rebasing is done. Now our work from the new branch is placed right after master, and we have this nice linear sequence of commits. This command doesn't copy but moves all our work from the current branch to the master or the main branch. They look like they've been developed sequentially instead of having developed parallelly. So if I just did another branch called git branch Edureka images 2, and then maybe git checkout, okay, then we git commit this, and then I could just git rebase main, and your current branch will be up to date. This command basically moves all of your work from your current branch to your master branch, and it'll basically look like it has been developed sequentially instead of having developed parallelly. Now, apart from these, there are certain operations that you ought to know. Firstly, archiving your repository. You can use this command. It stores all of your files and data in a zip file rather than a .git directory. This creates only a single snapshot, omitting version control completely though. This comes in handy when you want to send these files to a client for review who doesn't have Git installed in their computers. Apart from this, you can also bundle your repository, which basically turns your entire repository into a single file. This pushes the master branch or the main branch to a remote branch, only contained in a file instead of a repository. You could alternately change the repository, clone the repo bundle, create a copy, and use git log. But that is like 5 commands instead of 1. Why not just use 1 command? And finally, stashing uncommitted changes. When you want to undo adding a feature or any kind of added data temporarily, we can always stash them temporarily. You can use git status, stash status, and then you want to reapply the changes you stashed using git stash apply. Having said that, let's move on to another very important topic in this Git tutorial. Let's go through a brief introduction to SSH. Now, what is SSH? What is an SSH key? Now, an SSH key is an access credential for Secure Shell Network Protocol. It's basically an authenticated and encrypted secure network protocol and is used for remote communications between machines on an unsecured open network, for remote file transfer, network management, and remote operating system access. So basically, it's typically used to log into a remote machine and execute commands in it. But this also supports tunneling, forwarding TCP ports, and X11 conditions. It can transfer files using associated SSH file transfer or secure copy protocols. It provides you several alternative options for strong authentication and protects the communication security and integrity with very strong encryption. It's a secure alternative to the non-protected login protocols and insecure file transfer methods such as FTP. So basically, how do you create SSH keys? You start by using the command ssh-keygen, and then you'll be prompted to enter a file in which to save the key. So home, Edureka. Then we're going to enter a passphrase. I'm just going to leave it empty again. And you can see our identification has been saved in the file that we specified. And we have something known as a key fingerprint. And finally, what we have to do is add the new SSH key to the SSH agent. And then you will see identity added. And that's it. You have created an SSH key.
The need for GitHub. It is extremely important for software developers to work on a web-based platform to share their projects and collaborate with other developers. This platform must be a version control system, that is, it must enable multiple people to simultaneously work on a single project. Each person edits his or her own copy of the files and chooses when to share those changes with the rest of the team. This application must also be capable of hosting millions of programmers and hobbyists that download and evaluate each other's work. GitHub is one such platform of choice for developers that can host multiple programmers and review their code. GitHub has several competitors. For instance, GitLab. GitLab is an open source web interface and source control platform based on Git, whereas Microsoft Team Foundation Server is an enterprise-grade server for teams to share code, track work, and ship software for any language, all in a single package. Bitbucket, on the other hand, stores all of your Git and Mercurial source code in one place, with unlimited private repositories. So what really makes GitHub so powerful and popular among developers? GitHub is an open source platform, and the community is really what fuels it. Moreover, GitHub is the platform of choice for developers from various large corporations too. Microsoft is the #1 contributor to the system, but there are also Google, SAP, Airbnb, IBM, PayPal, and many others. Exposure and insight that you can get on GitHub are simply unmatched by any other platform. Here you can discover code written by others, learn from it, and even use it for your own projects. Versions control on GitHub works very much like Microsoft Office or Google Drive. It simply tracks all the changes made to your code and who makes them. You can always review the detailed change log that neatly hosts all of the relevant information. Using GitHub eliminates the need for complex corporate security solution because everything is on cloud. The platform protects code branches, verifies commit signing, and controls access. Now that we know why we need GitHub, let us understand what is GitHub. GitHub is a Git repository hosting service that provides a web-based graphical interface with many features. A repository is usually used to organize a single project. Repositories can contain folders, files, images, videos, spreadsheets, anything your project needs. Let's say, for example, a team wants to work on a particular project. Here they can simultaneously write and update their code to a central repository which is present on GitHub. So GitHub is a highly used software that is typically used for version control. It is helpful when more than just say one person is working on a project. For example, a software development team wants to build a website and everyone has to update their codes simultaneously while working on this project. In this case, GitHub helps them to build a centralized repository where everyone can upload, edit, and manage the code files. Most software projects have a bug tracker of some kind. GitHub's tracker is called Issues and has its very own section in every repository. Issues basically are a great way to keep track of tasks, enhancements, and bugs for your project. Moving on, people often get confused between the terms Git and GitHub. Now let me clearly explain the difference between them. Git is simply a version control system that lets you manage and track changes within your project, whereas GitHub is a cloud-based service that lets you manage Git repositories. So basically, Git is the tool and GitHub is the service. Now that we know the difference between Git and GitHub, let us move on and understand how these two work hand in hand. We already know that Git is a version control tool that will allow you to perform all kinds of operations to fetch data from the central server or push data to it, whereas GitHub is a code hosting platform for version control collaboration. GitHub is basically a company that allows you to host a central repository in a remote server. Now, without any further ado, let's get started with the demonstration on how to use GitHub. So for this demonstration, we're working on the website version of GitHub. There's another version of GitHub that is the desktop version, which you can download it to your personal computer. So we're simply going to search for GitHub in our search engine. The first link will lead you to the official website of GitHub. So I'm going to click on that. So this will redirect me to the main homepage of GitHub. As you can see, there is a search GitHub option. There are also two buttons that says sign in and sign up. If you're new to GitHub, you can simply enter in your credentials, that is a username, email, password, and sign up for GitHub. But if you already have an account like I do, I'm simply going to click on the sign in button and it'll redirect me to a page where I have to enter the credentials, that is my email address and password. I'm going to do that now and I'm going to click on the sign in button. Now, this is the main page of my account. As you can see, I have no repositories. It's all new, it's all fresh. But if you're not new to GitHub, you can view all of your repositories on the left-hand corner. Now, before we move on, I'm going to explain you all the features that are present within GitHub. So you can see a search bar here. So the search bar will allow you to look for profiles, certain keywords, look for different kinds of projects that are available on GitHub. All of those can be done using this bar here. And you can see 4 options next to the bar that says pull requests, issues, marketplace, explore. Pull requests we'll learn later on in this session, but the issues and marketplace we won't be discussing in this video for now. The explore button, on the other hand, is an extremely important and interesting button. So once I click on that, it'll redirect me to a page with some activities that are going on around in GitHub. You can see here they're trending repositories, they're trending developers. Basically, this is a feed that will allow you to interact with developers and other people, collaborators from all around the world, basically. In Instagram too, you have an explore button, which will allow you to interact with different people from all around the world. So the same concept is implied in the GitHub explore button too. So you can explore topics, you can explore trending repositories, developers. Basically, it's an interaction with other people from different parts of the world. So I hope that's clear. Now, the most important part of the session are the 3 buttons that are available in the right-hand corner of the navigation bar. So you can see there's a bell icon, there's a plus icon, there's a pixelated icon on the right-hand corner. So the bell icon allows you to read notifications of your activities that occur in GitHub. So that's what it really is. You can see the inbox will allow you to view all of the notifications. You can also view the unread notifications by clicking on this unread button. As of now, I don't have any notifications, so there's nothing available. You can also group these notifications by the date or repository by clicking on this group by button here. You can also view your saved notifications by clicking on here. And the done button, on the other hand, will let you mark all of your notifications that you're done with, your previous notifications. So these are the 3 important buttons you'll have to know in this bell icon. And the filters are not necessary as of now, so I'm not going to discuss that. This button, on the other hand, will allow you to manage your notification settings and your subscriptions too. So that's all for this bell icon. The next important button is this plus icon. As you can see, there are 5 drop-down options that appear here. The first one being new repository, followed by import repository, new gist, new organization, new project. So new repository we've already discussed previously in this session. A repository is a place where you create your files for your project. It's basically a storage space, right? So your repository can directly interact with your Git, right? So the new repository option will allow you to make files, a repository to your GitHub account, right? The Git, on the other hand, the tool that which we use to make local repositories in our personal computer can be directly pushed on. The local repositories can directly be pushed onto your GitHub account. So that's what the new repository button allows you to do so. But the new project, on the other hand, is a place to track issues, features, and other tasks that are related to the code within the repository. You can also connect with the DevOps build and deploy process, assign people to tasks, and so on by using this button. That is the new project button. So the difference between the new repository button and the new project button is that projects in GitHub are only a part of GitHub, but not Git. But the new repository option is a part of GitHub and Git. So that's the main difference between new repository and new project. I hope that's clear. So the next button will drop me down some interactions that I can make with my profile. So if I click on this Your Profile option, it will redirect me to a page where I can edit my profile. I can really create my identity using this page. So here, if I click the Edit Profile, I can add a bio about myself. I can add the company in which I'm working in, the location at where I am, the website, Twitter username, etc. All of that I can add here, all of the information about myself. I can also view the repositories I'm working on currently, or the repositories I've worked in the past, projects that I'm working on, the packages, and the entire contributions I've been making on GitHub from the last year. So basically, it allows me to build an identity, or it'll help me build my profile on GitHub. So I hope that's clear. Now, if I click on this button and if I want to sign out from a profile, I can simply scroll down and click on the sign out button here, and this will sign me out of my account. So that's all for getting started with GitHub. These are the basics on what GitHub is and what each of the button and options really do. Now, if I want to move back to the main page of my GitHub profile, I can simply click on this Octocat. That's GitHub's logo. So I'm just going to click on this Octocat logo, and here I'm back to my main page. Now, before we move on and work on the different operations and options within GitHub and learn different things about GitHub, I'm going to give you a brief overview on how to download the desktop version of GitHub. So I'm simply going to search for GitHub Desktop on my search engine, and I'm going to click on the first link that's available on this page. Now I can simply click on this button that says download for Windows 64-bit. That's compatible to my current version of my personal computer. If you have a Mac, you can simply click on the Mac version and download it to your desktop. But as I've already mentioned previously that we're going to work on the website version, so I'm going to simply switch back to this. Now let's quickly move on to the next part of the session. Create a repository. So firstly, let us understand what a repository is. It is simply a storage space for the correct project that you're working on. GitHub is a very popular central repository that allows you to share your files, whereas Git allows you to create local repositories that are present on the system you are working on. So you can basically push your local repository into GitHub and share it with other collaborators via the central one. Now that we know what a repository is and how it works, let's go on to the demonstration part and create our first repository. So you can do this in two ways. Either you can click on your create repository button that is present on the left side, or you can, as I've already mentioned in the previous part of the session, you can click on to this plus icon and you can click on the new repository option. So this will redirect you to a page that says create a new repository. You can add your repository name. I'm going to name my repository as Edureka, and it's available. All of your repository names must be unique from one another to identify them easily. You can also add a description, which is optional. I'm just going to add the description. This is my first repository. And a description allows people or other collaborators to understand what your repository is all about. But as a good developer or a good programmer, you would definitely want to add a description and give an overview of what your repository is all about. There are two options now available that says private or public. Now you can choose your repository to either be public or private. So the private one lets you decide who can access your profile, whereas the public one lets anyone view and access your repository, but you can choose who can commit to it. That's the difference between public and private repository. I'm going to let my repository be public as of now. Now, if you scroll down, you can see that you can initialize your repository with three options. The first one being add a README file. The second one being add a git ignore file. You can always choose add a README text file to your project, which often contains information about the project and other necessary details the user must be aware of when he or she is accessing that particular project. Now, I want a README file for my repository, so I'm going to click on this button here. That's going to check it. The next option is add a .git ignore file. So this file will let you ignore a list of files when the user is pushing files to GitHub. That's what this option really does, but I'm going to let this be unchecked for now. For your repository to truly be open source, you will need to license it, so others are free to use, change, and distribute the software. You can simply click on choose a license option and pick the required license for your project. There are several licenses like MIT, GPL, Apache License 2.0, BSD, etc. But for this repository, we don't really need a license, so I'm going to untick this too. And now you can see there's a piece of information that says this will set master as the default branch, but I'm going to ignore this for now. I'm going to explain about branches later on in this session. So this is all you have to do to create your first new repository. You add a name, you choose a description, you add an optional description, you let your repository be either public or private, and you initialize your repository with either of these three options. And I'm simply going to click on my create repository option. Now this will redirect me to a page with all the information and the files that are currently present in my repository. You can see here my repository name is present here with the optional description that I gave, and the number of files. Currently we have only just one file, that's the readme text file, and that's present here. So this is all we have. Congratulations, you just created your first repository. Now you can see there are some options that says issues, pull requests, actions, projects, wiki, security, etc. We don't have to really talk about all of these right now. We will just learn about one option that says code here. So this is really important. If you click on this button, you can see that there's a link that is available here, an HTTPS link. So if you copy this link and paste it on your Git terminal that's present on your computer, you can download this entire project directly to your local system. So that's what the link is for. I hope that's clear. And the next option that says open with GitHub Desktop will allow you to open this entire repository in your GitHub Desktop version. And you can also, the last option that says download zip will allow you to download this entire repository in the form of zip files. So all of your project files will be within that zip file. So that's all you have to really know about your repository. And I'm going to click on the README text file that's available. It will take me to another page with some extra information about that file. You can see currently we have 2 lines and the memory space that is allocated to this file. So we currently have 2 lines, that is Edureka, and this is my first repository. And you can also see the number of contributors to this project. That is just one, that's just me for now. And you can view the history of the commits or the changes that have been performed in your file. So we'll come back to that part later on this session, but you can move back to your main page of this repository by clicking on the name button here. So Edureka is the name of my repository, so I'm going to click on that. So now I'm back to the main page of my repository. Before we learn how to create our first branch, let us understand what branches are. Branches allow you to work on other features that can be included and merged with the master branch if required. So what is the master branch? The master branch is the main branch where your project resides on. So all of the changes, all of the activities that you do with your main project lies or is on your default branch that is named as the master branch. So what really GitHub allows you to do is it allows you to create additional branches. So on these additional branches, you can work on the other features or you can experiment with your project. And if you're happy with this, you can simply merge these features to your main branch, that is your master branch. This is what branches are really for. So they simply allow you to work on other features. That's what branches are. So let's move on to the demonstration part and look at how we can create our own branches. So now if you look on the left corner, you can see a button that says master. So currently we're on the master branch, and there's only one branch, and the master branch, as I've already mentioned, is the default branch. So when you create a repository, you're automatically creating a master branch. So this is where your project will be residing on. And now if you want to create another branch, say let's name this branch 1 branch. So this is what I want to name my additional branch. I'm simply going to name it and I'm going to click on the enter button. So it will redirect me to a page. So this is the exact replica of your master branch, and you can work on this branch. You can work on any other feature, or you can add something, you can remove something, you can really experiment on this branch. And if you're happy with this, you can merge back this feature or the experimentation that you've been working on to your master branch, right? So you can see there's a README text file. It's exactly the same. There's the name of your repository, the description of the repository. You can click on the README text file and everything's the absolute same. You can quickly switch back to the main page. But the only difference is that you're currently on a branch named branch 1 branch. You're not on your master branch. Now, if you want to switch back to your master branch and work on it, you can click on this button and you'll find the master here. You can click on that and it will take you back to your master branch. Here you can work on your project. So they're currently 2 branches. You can see that, and everything's normal. Everything looks simple. That's all for branches. It's really easy. I hope it's clear. So you can look for branches here on this bar here that's present here. You can also create new ones in the same option. So that's all for branches. Let's move on to the next part of the session. Make a commit. Now, what are commits? Commits simply record changes to one or more files in your branches. So basically, they save the changes that you're making in your project. Git always assigns each commit a unique identification, which is called SHA or hash, that identifies the specific changes. So for any changes are made to your project files, you can simply go back and look at the version history or the history of each commit you've performed on your project files. So that's what really commits are all about. It's extremely easy. Let's go ahead and make our first commit. Now I'm going to switch to my branch 1 branch, and I'm going to make my first commit. I'm going to click on my readme text file. That's the only file currently in our repository. So we'll make the change in the readme text file. There are 3 really important icons that are present in the right corner, as you can see. The first one is a PC icon that says open this file in GitHub desktop. So if you click on this file, this entire file will open in your GitHub desktop version. The next one, that is the pencil icon, will allow me to edit this particular file. That is my readme text file. And the third icon is a bin icon, which will allow me to delete this file. Now, what we'll be working on is the pencil icon. That's the edit this file option. I'm going to click on this, and I can simply view a space or a file that will allow me to make changes to my readme text file. I'm going to add another line here that says this is my first commit. This is what I want to add to my readme text file. And if I want to preview the changes, I'm going to click on this preview changes button. You can see that this is my first repository. This is my first commit. This is my first commit is the additional piece of information that will be adding to my readme text file. And it's highlighted in blue, so we know that that's the additional information. I'm happy with this change. I'm going to switch back to my edit file. I'm going to scroll down. And if I want to add a description about the change that I'm performing to my file, I can do that. A good programmer would always add a description to the change that he's making to the project file. So other collaborators, when they view the commit or they view the change, they can read the extended description and understand what the change is about. So that's a good habit that you must follow. But as of now, we're not going to do that. So I'm going to leave this blank. As you can see, there are 2 radio buttons that are currently available. The first one says commit directly to the branch 1 branch. This will allow me to make the change or save or make the commit directly to my branch 1 branch only. So the change that I'm making currently is only implemented to my branch 1 branch. The second option allows me to create a new branch for this particular commit and start a pull request. We're not going to talk much about this option right now, but the first option is extremely important. So we'll let this be stuck on to the option that says commit directly to the branch 1 branch. And I'm going to click on the commit changes options. And this will simply implement the entire change to the file. You can see that the change is implemented. The additional piece of line that says this is my first commit is added to my readme text file. Now, the interesting part is if I switch to my master branch, the change is not implemented in my master branch. So the change is only currently present in my branch 1 branch. And now if I want to view the history of the changes that I've made, I've already mentioned in the previous part of the session that the history button will allow me to do so. So I'm going to click on this history button, and you can see that I made my first commit 23 minutes ago, and I made my new commit 41 seconds ago. And there is also a hash number, unique hash identification number that allows me to distinguish between both of these changes. So all of my commits that I'll be making on this branch will be available here. So that's the main point of a version control system, isn't it? Understanding and keeping a record of all the changes that we're performing in our files and our projects. So this gives full justice to the word version control. So that is what GitHub is all about. Now that we learned how to make our first commit, let's move on to the next part of the session. Open and merge pull requests. So what are pull requests? Pull requests let you tell other developers about changes you've pushed to branch in a repository on GitHub. So once a pull request is open, You can acknowledge and review the changes with collaborators and add follow-up commits, after which your changes are merged into the base branch. So there are two ways to create a pull request. The first one being pull request from a forked repository, and the second one being pull request from a branch within a repository. Currently in this demo, we will work on the second one, that is pull request from a branch within a repository. Now I'm simply going to switch to my demo part. Okay, now currently I'm on my master branch. I'm going to click on this pull request option that's here. Now it says branch 1 has had recent pushes 3 minutes ago, compare and pull request. I'm not going to click on that. I'm going to simply click on the new pull request option here. So this will allow me to compare the changes. There's a base branch and a compare branch. The base branch is the master branch, and the compare branch, I will compare my master branch to my branch 1 branch. So this notification says that the merge between the branch 1 branch and master branch is definitely possible. So it's a green signal. So if I scroll down, I can view the difference between both the branches. So the left hand side indicates the information that is present on the master branch, and the right hand indicates the information that is present in my branch 1 branch. Plus sign indicates the additional information that is present in my branch 1 branch. I'm happy with this. So I'm simply going to scroll up and create the pull request. I'm going to click on that. I can also leave a comment and I can preview the change. That's not necessary for now. So I'm going to go ahead and create the pull request. Now this will redirect me to a page. So this page says that the pull request has been opened. And now I can choose to merge this pull request. That is, I can merge the branch 1 branch to my master branch. So it says this branch has no conflicts with the base branch. Merging can be performed automatically. And that's good news, right? So I'm going to click on merge pull request, and I'm going to confirm my merge, update my readme text file. I'm happy with that. So I'm just going to confirm it. Now it says pull request successfully merged and closed. You're all set. The branch 1 branch can be safely deleted. I'm not going to delete the branch. I'm going to compare both of the branches and see if my master branch is exactly the same as my branch 1 branch. So I'm going to click on this Edureka. I'm going to go to my main page of my repository. So my master branch has the additional piece of information that says this is my first commit. Now if I switch to my branch 1 branch, it has the exact piece of information. So the information that was present in my branch 1 branch has been successfully implemented to my master branch. So that's all for the pull request part 2. We've reached the end of the demonstration part. Now let's quickly look at the case study of how Microsoft implemented GitHub. I'm pretty sure most of you have heard of Microsoft. Microsoft Corporation is an American multinational technology company. It develops, manufactures, licenses, supports, and sells different computer software, consumer electronics, personal computers, and other related services. So initially, Microsoft was against the use of the open source because they held very tightly to the internet protocol. They were completely hesitant to adapt to this new concept of sharing code to the entire world. But in 2010, they rethought this entire scenario, and now Microsoft is one of the biggest contributors to open source. Today, about 2,000 to 25,000 Microsoft engineers maintain TypeScript, .NET, Windows Terminal, DARP, Helm, and more than 1,000 other open source projects. So first what they did was they released new processes in measured containment. But later on, they released only licensed software. So here, developers can learn from the company's source code, but they couldn't really build on it. Eventually, the stigma died, and now even closed code like .NET is open source under an MIT license. Teams realize that they need to accept contributions to get feedback and learn from other developers. To organize and understand this approach, Microsoft created their Open Source Programs Office, which enables distribution and centralization of knowledge. So the OSPO provides the resources and maintainers to manage thousands of repositories and contributors effectively on GitHub. Even though Microsoft invests in its tools, they expect other individuals and organizations to lead the way. Microsoft believes that GitHub's value isn't in any one feature, but its entire community. GitHub is the place to collaborate, it's where everyone is, and where most of the entire world's open source is already happening. It's not just a feature, but the whole thing.
Let
us execute this process with the help of the pipeline. First stage in any continuous integration flow is version control. Now, what is version controlling? And then building, then unit testing, deploying. So let me directly show you the demonstration rather than talking about it. Let us take some code given to us by the developer friend. So there are version control tools where developers can write the code and push the code. I have a GitHub repository where I have some code which is given to me by a developer. Right? This is a Java based code. For this particular code, okay, for this code, we have the source code, we have the test cases written, given by the developer. I am going to, and as soon as the developer writes the code in his local machine, let's say here he has written some piece of code, he'll push all of his code into this server. This is an external server where anyone can push the code. Okay, so this on this repository, on this particular repository, the developers are maintaining all the versions of their. Okay, so version controlling is the process to maintain, manage the changes that a developer or a user is doing to the files, common files accessed among by the team members. This repository is accessible by every team member. That is version controlling. I'm going to use a tool called as GitHub for version control. GitHub is an open source tool where 90-95% of the code is available for everyone to use. After version controlling, the next step will be to build the code, friends. To build the code. So build the code, we are going to make use of Jenkins server, friends. Now to tell you that what is Jenkins? Jenkins is an open source tool, friends. It is available for free, right? And it is provided by an application by an organization called as CloudBees. Jenkins is like a robo. Whatever you tell to Jenkins, it will do it for you. You ask Jenkins to do a task, it will create a job, it will create it. You ask Jenkins to create a file, it will create. Delete a file, it will delete. You just need to instruct Jenkins to do a task. You just need to instruct Jenkins to do a task. It will perform the task for you, friends. It will perform the task for you. Okay, automatically at the scheduled time or at the scheduled interval, or whenever you have this, whenever you have set the trigger, automatically Jenkins will perform the task for you. Jenkins also provides you whatever task is executed by Jenkins, it provides a very good console output which will help us to troubleshoot the issues. It also maintains the history of the jobs that have been run and when it was run. It also provides a one-click philosophy to automate your entire CI/CD pipeline. Jenkins can do a continuous integration and continuous deployment flow for you, friend. So let us use Jenkins as a tool for performing the build steps. Now, build is a process which involves compiling the code, unit testing the code, and packaging the code, friends. Packaging the code into an artifact, friends. The code that I have picked up, if I show you the details of the code, the developer has already told this code when built, when this code is built, it is going to be built into a WAR file. So a package which will be generated will be of type WAR file. So I'm going to now to do the build process, friends. We have a tool called as Maven and its commands are available that will help us to build the code. But executing the Maven commands is done manually. DevOps says whatever is your manual process, please automate it. So using Jenkins, we are going to automate the process of compiling the code. So let me quickly log into this server. So I've already installed Jenkins and I'm going to log in with my credentials. Okay. Jenkins provides you. So if you are opening Jenkins for the very first time, if you're opening Jenkins for the first time, you may not have any particular job. right? So here, if you go to the new item, Jenkins will allow you to create a job fetch. Job is nothing but a task that you want Jenkins to do. So here, my first task that I want Jenkins to do is compile the source code that is given by the developer. Now, where is the source code? The source code is available in this SRC folder, main folder. There are some files available here. These Java files can be used to, these are the source code available that I want to compile. It is my first step in build process. So let us write down one dot. So let's say I'll write 04 dot. Compile is the first job that I want to build. Jenkins provide you different templates to build your code. Whenever you want to do the process of building the code, you can use a template called as a freestyle project. It is one of the easiest way of creating your project in Jenkins. But if you prefer to go with the CI/CD pipeline, you can go with the pipeline code also, friends. So let me take the pipeline code and show you how to create the pipeline. It's very easy to work with the pipeline code also. Here you will be writing the scripted pipeline code. Writing scripted pipeline code in Jenkins is very easy, as it is the format is quite readable, easy to understand, and it does not require any coding skills for you to write the code, friend. Also, Jenkins provide a pipeline syntax, that is a snippet generator, which will automatically generate the pipeline code for. So let us use the snippet generator to generate the code that will create our CI/CD pipeline. Okay. So what I'm going to do, I'm going to go back and I'm going to recreate the job with a new name. I'm going to delete this job. I'm going to delete this job and I'm going to create a new job, and I'm going to call this job as CI/CD pipeline. Okay, and I'm going to take the template as a pipeline template. Whenever you have multiple jobs to be executed one after the other, it is always better that you take the pipeline as a template. Let us press OK. Now what I'm planning to build today, let me quickly explain you that also. So I'm going to build a following pipeline. Okay, just a moment, please. I'm looking for a PPT for a slide. Okay, so I'm going to build the following pipeline for you, as we were just seeing in the slide also, but this is more descriptive. First, we have the source code in Git, and I'm going to create a stage called as compile. Now, in this pipeline, first we are going to take the code from Git and we are going to compile the code. Okay, all right. So here we go. We are going to write the code here. Every pipeline code starts with pipeline. Okay. And here we are then going to start building the code on a particular, where do we want to run the code? So we want to run the code on an agent. Okay. Agent N. And we also have an option called as tools. Which two tools I want to use to build my code from? The tools that I want to use is JDK, that is Java, because my code is Java based code. I want to use JDK, and this is the name of the tool, my Java. MVN is another tool that I want to, Maven is another tool that I want to use because we are going to build the code. For building the build automation tool that I am using is MVN Fridge. Okay, so here you go. The name of the tool that I have set up in Jenkins is my Maven. So this is the first phase in my pipeline where I'm creating set of tools. Okay, these are the two tools that I'm going to use to execute my task. Okay, then we are going to create something called as stages. Stages is here represent the steps that you want to perform. Okay, the task that you want Jenkins to perform. My first stage is going to be clone the repository, clone the code, whatever is the code written by the developer, I want to clone. In this stage, you will write down the steps. What are the steps involved in it? So the steps involved is we have to just run a command. You have to tell Git, hey Git, clone the repository. By cloning the repository means whenever you create a Jenkins job, in its workspace, we want to get the code given to us by the developer. So this is the code given by the developer. Let us go and take the path of the repository here. This is the path of the repository available. I am going to use the snippet generator. In the snippet generator, if you see, there is a step section. I'm going to use a step called as get. In this step, it is asking us, give the repository URL which you want to clone. And then, just a second, friends. Let me quickly connect again. Let me give the name of the tool as Git and let me provide the GitHub repository. Give the name of the branch. Now this is a snippet generating pipeline syntax generator that will automatically generate the code for us for the particular stage. Git is a plugin that is available by default in Jenkins that can clone the repository. By cloning, we mean we are fetching the code from GitHub. Since we are building the CI/CD pipeline, I am assuming that you have an idea on what Git is, what GitHub is, and the Git commands like git clone, friends. After this is my first stage. This is my first stage, and if I execute this stage, let me save this stage. Now let me call this stage as a version control stage. Let me save it. So you will save the pipeline and you will build it first. So as I build a part of that particular, because there is only one stage, it is just going to clone that repository into Jenkins. Observe here, it has failed miserably. Let us see what is the issue. My Java, it says the no such property my Java. Okay, let me go and check it. Let us go to manage Jenkins. We have to actually go to global tool configurations and set up the Java path. So there is my Java here. It is available. Okay. Let me check the job again. Go to the configure section. Okay, the reason why it has failed is we have to provide the name of the tool in single quotes. Now if I will run the job again, let's build it again. So please see here on this particular in the middle section of the job, it shows stage view. So whatever stage has been executed, it shows whether it is successful or failure, right? So I think the second build is successful here. Go here and check it. It has created every job that you create through Jenkins creates a workspace. Workspace is like an output directory where your code can be available. So if you go scroll down further, see cloning the GitHub repository. Now Jenkins has got hold of your code. You make any changes to your code, Git can use this pipeline to fetch the code. So that's continuous version controlling, friends. Now let me go ahead and create the next stage. The next stage is, so as part of my slide, I've completed this step of fetching the source code. Next step is to compile the code. So let me go ahead and create one more stage. And I'm going to call that stage as compile stage. Okay. Now in the compile stage, I'm going to use steps and I'm going to use Maven to compile the code, friends. Maven is a build automation tool which provides us plugins which when run can compile your code. Compilation is a process where your source code, which is available in your workspace, is picked up and is converted into a machine understandable code. That is the class files or binaries or zeros and ones. So the command is mvn compile. This is the Maven command to compile the source code. Okay, and you are going to use shell. My server is an EC2 Linux based machine, a Red Hat Linux machine. So I'm using shell command to execute the Maven compile command. Okay, that's all. So let me save it and let me build it. I will show you the compiled files after this stage. So my third build, observe here, I'm slowly building my pipeline, version controlling and compiling the code. Okay, compiling the code. Now if you go to your build here, no, let me go and show you in the workspace. If you see the workspace here, you can see at the following location in the target folder, my compiled files are available. That is the files that we have just converted just now. We have converted these files, compiled the Java files into class files. That's my first step in build process, friend. Now let me continue further writing my code. The next stage is going to be the stage called as unit test stage. You can also add a stage, a small security stage if you want to implement a security in your DevOps. That's called as a static analysis stage, wherein you are going to use a tool called as PMD. So the PMD is a plugin provided by Maven that will check your code for programming mistakes, static mistakes. Okay, so I will actually call it as yeah, that's fine. So the command is steps sh. Using the shell, you are going to run the command mvn pmd pm. PMD here stands for Programming Mistake Detect. PMD is a command that is used to run the PMD plugin of Maven, which runs your source code to check for programming mistakes like unnecessary parentheses, out of memory error, connections have been created but not closed, using of certain you're recalling the loop again and again. Loop is going into infinite flow, or you have defined a condition but you have never called the condition. So such programming analysis are done by a Maven plugin called as PM. Okay, so I'm then going to build this stage. Let me build one more stage. After this, after we have completed static analysis, I'm going to add one more stage, which is my unit testing stage. This is the stage where my developer has given me some set of test cases. I want Jenkins to use Maven so as to pick up these test cases. There are some JUnit test cases given to us. So we want to pick up these JUnit test cases and execute them. Now, as you know, how you may be having a doubt that Sonar, from where are you getting the test cases? See, the first stage, we have already cloned the entire repository. So Jenkins is already holding the source code as well as the test cases. So you just need to tell Jenkins, hey, Jenkins, execute the following steps. What are the steps? Use the shell to execute the Maven command mvn test. So Maven has a plugin called a Surefire plugin. Using the Surefire plugin, which can be triggered using a command called as mvn test, you are going to execute the test cases which are available in the test folder and give the output as how many tests have passed or failed. So let me save this one and build the job. So if you see, we have cloned the repository. We are now compiling the files again. We are doing the static analysis. any issues are there on the code, programming mistakes, we're going to find that out and then do the test cases also. Each of these stages will generate a report with you how many unit test cases have passed or failed. It's going to generate the report telling the programming mistakes done by the developer. Let me show you the reports. You can go to the build and you can scroll down, go to workspaces. In the workspace, if you go and check the target folder, you will have Surefire report, which is your target test report. Here the report tells how many test cases have been executed, how many have passed, how many have failed. It gives the complete information and the time taken to execute the test case. There are 3 reports generated by the Surefire reporting plugin. They're all generated in XML. You can use the JUnit plugin of Jenkins to convert it into a trend report. If you will join the DevOps training, we will show you how to convert these XML files into the trend reports also. And here is a PMD XML file generated where you can see the programming mistakes done by developer. Like in line number 18, there is an empty catch block. Line number 62, there is useless parenthesis. There is a unnecessary modifier in line number 24. So this report is automatically generated by the Maven plugin. Jenkins is just triggering it. Maven is actually executing those commands on the source code. Let me build my pipeline, the last stage of the continuous integration in my pipeline I'm going to build. The pipeline that I've built so far, that is version controlling the code, compiling the code, analyzing the code, testing the code, and finally packaging it. This pipeline is called as continuous integration pipeline. Package stage. In this stage, I'm going to write the steps. Now I'm going to use a shell to execute the Maven command mvn package. Mvn package. So package is a command which will take the source code and convert it into an artifact fetch. Convert it into an artifact. What is an artifact? Artifact is an executable. Artifact is an executable which when executed or which when deployed on a server will allow the users to access the application. Okay, so when if suppose to understand executable, suppose you go to your browser and I ask you to download Skype. So when you download Skype, there is an exe file which gets downloaded in your laptop. That exe file is called as an executable, which when double clicked and pressed next, install the software on your server. Same thing I'm going to do, take the test case, take the entire code and package it into an executable so that I can deploy it on my servers. So let me save this and build the pipeline now again. So you will see the last stage here, packaging. So here we go, friends. Our first continuous integration pipeline is automated. But you may be thinking that I am executing the code again and again manually. How is it called as a one-click philosophy here? Jenkins supports a one-click philosophy. That means when you just give one click, all the stages should get executed one after the other. Even if you want to automate this click, you can do that by using the triggers here. There is an option called as build periodically. Let's say every 15 minutes I want to run this pipeline. So I can give a schedule here by using a cron tab format. This is the cron tab format that you have to use. Like how many minutes, what for every 15 minutes, or what time do you want to run? Which hour of the day do you want to run it? Which day of the month do you want to run it? Which day of the week do you want to run this particular code frame, right? So this gives you, you can even set a schedule. Let's say I want to run it star means every minute at, let's say at 9 p.m. So we have already crossed 9 p.m. So let's say I want to run it at 22. Okay, at 10 p.m. is when I want to run my pipeline again. and I set a schedule here. Star here represents every day, every month, every day of the week. That's a schedule given. Suppose some more examples are given to you by Jenkins here, that let's say you want to run your job every 15 minutes. So let us take this cron tab. This tab here represents, so this is the Linux cron tab. Same thing. Every 10 minutes of the first half an hour. Once every 2 hours. Once every 2 hours slot between 8 a.m. to 4 p.m. You can give this schedule like this. So let me give a 15-minute tab here so that we can see. Okay, so as per the schedule, the job will run in the next 15 minutes. Suppose you don't want the scheduled one. There is also an option called as poll SCM. Poll SCM is a process in Jenkins where Jenkins is going to check with Git. Has the developer done any changes on the repository? Let us say the developer created a file here and did changes to it. As you commit the changes, as a developer commits the changes here, immediately the pipeline will run. So let's do this. So let us do this. So I'm going to set again here. You have to give a schedule to Jenkins. Jenkins, at what time should it check with GitHub for changes? So let's say every minute. So I'll give start space star space star space star. Every minute I want Jenkins to check with GitHub if developer has done a commit. So always in continuous integration, that's the flow. Hold on, I think there was an error. Okay, there's no error. So do you really mean that every minute you want to run it? Yes. Okay, but observe the pipeline will not run. Observe the pipeline will not run until and unless the change happens on GitHub. The continuous flow says, if we are here, let me see if there is. The continuous flow says, so we have completed till here only, till here. The continuous flow says, as you version control your code or as the developer pushes the code in GitHub, your build pipeline, that is compiling the code, unit testing the code, package the code, should trigger automatically. So the setup is done in the following way. Now let's assume I am a developer of this repository. I will make small change in one of the files. Let me make a small change to a file. So let's say checkout on get. Okay. On the repository, if there is a commit, I'm doing a particular commit. On the repository, if there is a commit, immediately the pipeline should trigger. So give it a second. If you see here, there is a polling log created by Jenkins. So when every minute it is going to poll GitHub. If there is a change, it's going to trigger the job. Right now, note, it did not poll yet. 343, it is going to poll. Since we did a change in the GitHub repository, it should trigger the job. Just give it a second. Yeah. See here, changes have been found. Since some changes have been found, automatically the pipeline has been triggered. If you observe, all your steps will be triggered again, friends. All the pipeline is getting executed again. Who is triggering the pipeline? Jenkins is triggering. Who is executing the stages? Maven is executing it. Where is the code available? In GitHub. So we have integrated 3 DevOps tools: Git, Maven, Jenkins, right? Okay. Now, after this, we want to deploy the code on a particular server, friends. So next step is deployment. Deploying your code on the next server, on any other server. Now, deployment of the code can be done using a deployment tool. Now, there are 2 ways to deploy your code. Either you deploy the code in the legacy way, that is installing the Tomcat server or Apache server, placing the code on the directory and then restarting the server. You can do that flow, or you can do it with the help of containers, friends. I'll show you both the ways. Let me show you with containers, friends. Let me show you with containers. Containerization is the new latest way of deploying your application, friends. Okay, what are containers? What are containers? Let us also talk about it before I build the pipeline. Friends, for deploying your code, for let's say, for deploying your code, we have the package available. Address book dot war file. A package is available, a war file is available with. I need to deploy it on the next server in a QA environment or the staging environment in the form of container. Now, container is nothing but a package. It's an environment. You can assume it to be like an environment which has its own network, which has its own state, which has its own memory, and your application that is running. So I want to place this address book war file. So I want a container which has Tomcat on it. Upon that, I want to place this address book war file. I want to place this address book war. Upon this, I want to also execute a command to restart Tomcat, right? And I want to expose this container. I want to access this container from the browser of my machine. So I'm exposing it to the port 88. So a container is nothing but it contains each and everything that is needed for your application to run. Right? Now, how do we create a container? That's again that's an important thing that you need to learn. So if you join the DevOps training course, we are covering Docker as a tool which provides containers. But to create container, no, you never create container. You launch a container. Okay, you never directly create a container. Never. So basically, there are three items that are needed for you to create a container. You always create a file, or you take for that matter any containerization tool like Docker, Rocket, Cryo, Containerd, Linux containers. Any containerization tool, Docker being the market leader. So we all always think container means it is Docker. No, it is not that. Okay, so there are many other tools and all of them mostly follow the same process. What they do is they create a file, manifest file, or a file which is called, as in case of Docker, called as a Docker file. In the Docker file, any administrator who has to deploy the code will write the instructions, okay, needed to deploy the application. Needed to deploy the application. Okay, and then friends, after that you are this Docker file. So here in the Docker file, you provide a simple instructions as to what you need to deploy your application, to run your application. You provide this Docker file, and this Docker file is built into an image file. Docker file or a manifest file is always built into an image. Image is nothing but, if I have to define, a static file which is a set of libraries and binaries for your application. It's a static file. It just holds the binaries that are needed for your application. Now this image, when you run an image, is when a container is created automatically. You never create a container. You always create a Docker file, build the Docker file. You build the Docker file and then run the image, build the Docker file into an image, run the image. That's when the container is available for you. It is available and is in running condition. As a user, from your browser, you access this container. From the browser, as a user, you will access this container and your application will be available to you. The running instance of an application is called as a container. The static instance of your application is called an image. What should be an image is on your Docker file. So let us quickly write a Docker file with help of Jenkins French. So let me show you. Okay. So what are we going to do is now, let us go to Jenkins and create a job. So let me continue the same pipeline. You can very well create another job also if you want, but let me write down here itself, deploy. So after this stage, now I'm going to write the next stage, which is going to be my deployment stage. Now for deployment, my steps are following. Okay, and before deployment, I need to connect to my server and install Docker on my system. We need to create containers, right? So let me quickly connect to my AWS machine and install Docker on. Let it connect. You also need to start Docker. Docker is a service that needs to be started. That is one thing. The next thing that you have to do is you have to go to a file called as vim etc sudo ers file, where you need to provide Jenkins. Okay, already there is permission. You need to provide Jenkins user full permissions to execute any command. Okay, any Docker command or any command on this server. Right, I've already provided Jenkins as a full user permissions. Okay, now let's go back here and start creating the steps for deployment. So your deployment could be on a QA server, deployment could be on a staging environment, deployment could be on production. Same steps can be followed. Okay, so I'm going to write a shell script here and I'm going to say label, comma, script. Okay, so let's start writing the script here. My script is going to be, I'm going to start creating a directory, mkdir. Okay, so on my Jenkins server, wherever this stage is created, I want to create a directory called as my deployment, okay, or my app, anything. After that, I want to go into the directory, and after that, I want to copy the file. Now we want to copy the address book war file, the war file which is generated into this directory first. So let me save it and go to the stage, package stage, where you can see the war file. So please go here, go to the workspace. In the not to the workspace, go to the console output which was last run. At the end of it, you will get the location where your war file is present. So this is the location where my war file is. Go to your pipeline and mention here, copy at this location, this war file in the current directory. After this, I'm going to create something called as Dockerfile. Dockerfile, and I'm going to ask Linux to run this Dockerfile until it meets end of text. Read Dockerfile. Read Dockerfile until you meet end of text. Now let's write down the Dockerfile. Dockerfile is nothing but a set of instructions that you want, instructions about the application and the softwares that you want on your container. So from is the base of your container. Like I want Tomcat on my container. After that, I want to add whatever is this address book war file. I want to add it. I'm taking Tomcat version 9. I want to add it to the Tomcat's root directory, which is user share Tomcat web apps. Okay, in this directory. After that, I also want to expose my container to the port 8080. Every container will be exposed to one particular port French. It will be so that you can access the container from the browser of your machine. So it's mandatory that your container, if it is of web application, it should be exposed to a port 8080. Okay, and I'm going to run a command to start Tomcat. The command is, now you don't have to write all this, friends. You can very well go to hub.docker.com and search for the Tomcat image. Over there, it is everything is available. So this is the Tomcat image. If you want to deploy an application on a Tomcat server, so if you scroll down, you can get complete information here. To start the Tomcat server, here is the command. To deploy on Tomcat, here are the to create a Tomcat container, to remove a Tomcat container. They have not given anything, but however, here is the home directory of Tomcat, and this is the command to start Tomcat server. Same thing I am mentioning here, start Tomcat server. Okay. Once I start the Tomcat server, I stop my Docker file here. That's all. So this is a set of instructions that I'm passing to Docker to take this Docker file and build it into an image. Now, so the Docker command to build the Docker file into an image is sudo docker build, okay, -t. Build the Docker file into an image. So let's give an image name, my app version 1. I'm giving the name dot. Okay, sudo docker. Run this image now. Run the image in a detached mode. That means keep creating my container. Let it run in the background and do a port mapping. Now, if you join the Docker session, that's when we can explain you the topics of port mapping, what is detached mode, right? Port mapping, to tell you, is when the container is created, there should be a port number using which you can access it. So that port number you will get from this option called as port mapping. Give the image a name, my app colon version 1. Okay, that's all, friends. Let me close the script. Right, so I've started a script here and it went on to create this. So these are the steps that I've executed. Closing the stage. Stage is closed. Stages are closed. Why there is an error? Steps are closed. 1, 2, 3, 4. Let me save it. Yeah, there is no more error. Okay. So these are the steps to deploy your code as a container. So let me save it and let me run it. So my Jenkins and Docker are on the same server RP. If they are in different servers, then you have to use SSH to connect Jenkins to Docker. Currently on my same server, I have Jenkins and I have Docker. So it does not need to connect to any other machine. But in real time, of course, you will have another server where you would want to deploy it. So you need to create an agent on Jenkins. You need to create an agent on Jenkins that will that the master will connect to it and deploy it as a Docker container on the third server. Okay, so I think it has created the container for us. Let us first go and see if it has created an image. So in the DevOps training, we do execute those pipelines using Ansible playbooks also. You can deploy your code using Ansible playbooks and Docker containers. Okay, so let me see. Systemctl start Docker. Docker images. Your image should be available. See my image. No, my image did not get created, friends. I think it in progress. Please see here. So here my Docker file has been built. No, it did not. It did not build it. There's a warning here. Let me finish this. So I have the Docker file with me. Let me just quickly finish it. And any how to use CI/CD for QA testing. So after the package, after you have deployed Mohammed, so after the deployment is done in the QA environment, the container of your application will be available. Then push your Selenium test cases into GitHub. Those test cases which are written by the testing team. Now create a next job here called as system testing, or create a job like integration testing, and ask Selenium, clone the Selenium test cases repository and use Jenkins to run it, Selenium test cases. And you can also create a job in Jenkins to run the JMeter test cases for performance testing. Yes, Ansible playbook is not an alternative to Docker. Ansible playbook will trigger the execution of Docker containers. Now, however, my deployment has failed. Let us go and check it. Cannot create the directory, file already exists. So directory is already available. That is why it is failing. Let us go and quickly make changes to it. That is okay. So basically Ansible is again a similar automation server where you write a playbook to install Docker, to start Docker, to create Dockerfile, to build a Dockerfile into an image and run it into a container. So Ansible can trigger everything for you on hundreds of servers. So here it is now creating the image. Can we integrate test cases report to the some test case management tool as well as with Jenkins job? You can. So test case reports like your HTML reports, your TestNG reports, your JMeter reports, your extent reports, you can. Okay. And see here, one image has been created and one container also got created. See, your image has been created and your container also got created. You can go and check it here. Docker ps-a. So here one container is just up and running on the port 49153. So if I take the public IP address of my server and go to 49153 slash address book. So here we have successfully deployed the application. Oops. Okay. Let me just see. Okay. All right, friends. And now I know the reason why it is not deployed. We need to make a quick change. I'm going to build now again quickly on those 100 servers. Now I think we should be through with the. So I have a container 49154. So here you go, friends. We have successfully deployed our address book application. I have started from the scratch, build the code, that is compile the code, unit tested the code, package the code, and deployed it into a container.
What is Jenkins and how does Jenkins fit in this particular picture? Now, Jenkins is an open source automation server which helps us to automate the process of development relating to testing, deployment packaging, and others. It is a server-based systems that run on software, Apache Tomcat. Now, it supports VCS store like Git, Bitbucket, etc. It also supports build automation tools like Apache, Maven, and it helps to make and facilitate our continuous integration and continuous delivery process. Now, Jenkins was first released in the year 2011 and it's completely open source software as a part of the MIT license. Jenkins is a plugin based profile. In Jenkins, you have got plugin, which basically used to interact with different tools and components. In Jenkins, plugins are primarily released in language other than Java. Plugins are available to integrate Jenkins with most version control system tools and most databases. Using these plugins, we set up purposes, for example, unit testing. Now you can do compiling, you can do packaging. Now you can create some reports. Now you can do some logging. Now all these things are possible using plugins and Jenkins. Another important component that we've talked about in Jenkins, apart from plugins, is Jenkins notification, which we call it as Mailer. Using Mailer, guys, we can configure email notification. For instance, you can configure scenario. For example, you want mail notification when build is successful. Now, all these things can be done using Mailer as the Jenkins component. Another important component in Jenkins is the SSH agent. Jenkins also follow a typical master-slave topology. Now, why do we need a master-slave topology and a CI tools like Jenkins? Now, when you work in the organization, we have got multiple teams which you want to build and deploy their own pipeline or deploy their own software project codes. Now, teams don't want the piece of code to be run on a server which is owned by some other teams. So what we can do is we can set up a master-slave topology where Jenkins may run on a server X. But you can connect multiple other servers which will act as a slave. So when you are deploying a code executing a pipeline, you can run those codes on those XYZ servers. Now, this is the beauty of using Jenkins master-slave topology. Now, another good thing about Jenkins is Jenkins can be deployed on any operating system. In Jenkins, you can use in a Windows mode, a Linux mode, a Mac mode. Now, all these Jenkins jobs can be deployed on any operating system. It is not at all dependent. Now, both master and slave needs to be of the same operating system. Another important core component of Jenkins call is JavaDoc. This is our plugin in Jenkins, which basically is a part of Jenkins core that helps us to publish results like build action, build directory, what is the expected build output. All those things that we see in Jenkins, they all are happening using JavaDoc. Now let's talk about security injection. Apart from that, Jenkins have other sorts of authorization like project-based strategy, metric-based authorization, which help us to make Jenkins more secure. We'll talk more about this when we talk about the Jenkins overall. So as you can see on the diagram, Jenkins is pulling code from the source code control system like Git, Bitbucket, etc. To start deploying it in Jenkins, we have got a notification management system using Mailer, where if the build is successful, we get a WAR file or a zip file. We can define how we want the build to be created, and if it is a failure, it will send the notification management to a developer that something happened wrongly with the specific code lines and you need to rectify your codes. Now that is the beauty of using Jenkins. So Jenkins is still the bread and butter in the industry. There are some Jenkins competitors also in the market like GitLab Jenkins and some others. But by default, Jenkins is the to-go tool for the CI industry. So far we've talked about Jenkins. Now let's talk about what is pipelining in Jenkins. Now let's say I want to deploy a code. The code may have certain steps like first step, I'm building the code. Second step, I'm compiling, then code reviewing, then packaging, then deploying. So how do I automate a combine of all these steps which can be executed in one go? Now to deploy all this scenario, we've created a delivery pipeline. Now pipeline is nothing but it's a combination of different steps or different tasks that we need to perform in order to deploy our code. Now using a pipeline instead of doing this task or code deployment manually, we combine them and deploy them as a sort of one common approach of a delivery pipeline. Now there are multiple ways on how you can create a pipeline. The two most common ways or common approaches of using a pipeline, as you can see from scenario, a declarative approach. And the second one that is used in the industry is a scripted approach. This particular is an example of a Jenkins pipeline script. Here you are saying we are first doing a stage called build stage, where we will be combining multiple tasks. Like first we are using Java, then we are printing something called echo hello pipeline. Then we are using Maven as the build automation tool and try to deploy a package. And then we are doing a shell script output of what all things are present in that particular directory structure. This is a typical example of syntax of how to create a pipeline in Jenkins. Now let's talk about the two predominant pipelines that are used in the IT industry, scripted and declarative. Now let's talk about what is scripted and declarative and how they are different from each other. A scripted pipeline is a traditional Jenkins pipeline approach, and a declarative pipeline is a modern day pipeline approach that is used in the industry. In a scripted pipeline, the syntax was first strict, while in declarative pipeline we use something called as groovy syntax. When you use a declarative pipeline, you can get a code from any version system tool like Git. You can create something called as Jenkins file. And you can download Jenkins file from a virtual constant tool, and that can be used to run your Jenkins code. When you use a scripted pipeline, you define a code something called as a node block. But one declarative pipeline will define a code in a pipeline block, as we can see in the previous example. Now let's talk about what is Jenkins file and how it can be used. Now Jenkins file are like a text file where you define your entire structure and syntax of your Jenkins. You know only how to download the file, and in particular, you can just give the part of your Git repo. If it is true, then get the credential. the private repo, and it can pull all the contents from there and just execute your code. It is a modern deployment mechanism that we use when we work with a Jenkins pipeline. Using Jenkins pipeline, we use certain things which help us. Let's talk about this. First is code review. Now you do a Jenkins pipeline, you can easily review your code. Your code can be reviewed by multiple developers before being executed. Now how that works is in Jenkins file, they are stored generally in a version control tool like Git. You can put something called as a pull request for a code review. Now different members of your team can review the code before you actually pull the Jenkins file and deploy it. Now you can do an audit trail or refer to as a long audit. You can log each and every step's output that is being executed as part of the Jenkins file and can see what is happening when the Jenkins file is getting executed. It's sort of like a verbose log. Then you can find a single place to store all your data or all your outputs. You don't need to have developers scattered here and there and writing their own codes for executing a Jenkins pipeline. Whole organization can approach a Jenkins file methodology where code can be stored in a VCS tools, and from there the code can be downloaded and can work as a single source for your entire pipeline. Now let's talk about the Jenkins workflow in particular. How does Jenkins workflow work? Jenkins workflow always start with a version control system, or you can say a source code repository. Multiple developers collaborate and they put their code in a source code system like Git, from where Jenkins try to pull the data from that source control system. For your system, there is no mandatory or the source code needs to be Git. It can be Bitbucket, SVN, whatever your organization uses with Jenkins server. Now we execute tasks like build, deploy, compiling, packaging, code reviewing. Now all these things happen using Jenkins server, where your Jenkins actually installed was running. Now Jenkins server can be any operating system. It can be a Windows machine, Ubuntu machine, Linux machine, or a Mac as well. It can be any operating system of today's modern world availability. Using this Jenkins server will execute our different tasks and scenarios. In Jenkins server, we use the mail functionality for the feedback mechanism. We notify developers the commit or the code deployment successfully or it is a failure. It also has some challenges. Now what can be done using the feedback mechanism? Possibly using the Jenkins server. So using Jenkins server, we always first deploy the code on a lower lifecycle environment. That is recommended standard practice. So what we do is we first deploy a QA server on a testing server, and once the code deployment is successful on the lower life cycle, then we go ahead and deploy the code on a production server. That is how the entire Jenkins workflow mainly particular interact first. Now guys, let's talk about the Jenkins installation and how to install Jenkins in a machine. As you all know, Jenkins by default run on 8080. So please make sure that if you're using any VMs in your organization, the port 8080 firewall settings are open and configured so that it can be accessible. I will get into some of the prerequisites required for installing Jenkins first, which will go ahead and install Jenkins on a Windows box. Now there are a few first configuration that needs to be done, and I'll be covering those as well. So once I have Jenkins installed and configured properly, I will get into the user administrative part, then create few users, and I will get into some of the plugins for setting up various kinds of access permissions for these users, and I also put in some of the freestyle jobs. Freestyle job is basically nothing but a very simple job, and I will also show you the powerfulness of Jenkins by scheduling this particular job to run based upon time schedule. Then I will also connect Jenkins with GitHub. Now GitHub is a source code repository where I've got some repositories put up there. So using Jenkins, I will connect to GitHub, pull up a repository that is existing on GitHub onto the Jenkins box, and then run a few commands to build this particular repository that is pulled from the Jenkins sending out emails. Now it's a very important configuration of Jenkins or any other continuous integration server for that particular matter. Now, whenever there is any notification that has been sent as a part of either build going bad or by being good or building propagate to some environment and all these scenarios, now you will need the continuous integration servers to be sending out notification. So I will get into the bit of details of how to configure the Jenkins for sending out emails. Now, I will also get into the scenario where I will have a web application such as a Maven-based Java web application, which will be pulled from the GitHub repository, and I will deploy it into the Tomcat server. Now the Tomcat server will be locally running on my system. Eventually I will get into the other very important topic, which is the master slave configuration. It's a very important and pretty interesting topics where distributed builds is achieved using a master-slave configuration. Now, all this can be very easily based up using a plugin. So this is what I'm going to be covering as a part of this tutorial. Now, Jenkins is a web application that is written in Java, and there are various ways in which you can use and install Jenkins. Now, I've listed the popular three mechanisms in which Jenkins is usually installed in any system. Now, the topmost one is a window or a Linux-based services. So if at all you have a window like the way I have, and I'm going to use this mechanism for this demo, so I will download the MSI installer. So whenever you start as a service, it goes out and nicely install all that is required for my Jenkins, and I have a service that can be started or stopped based upon my needs. Any flavors of Linux is one of many other ways of running Jenkins in downloading this generic WAR file, and as long as you have a JDK installed. You can launch this WAR file by the command opening up a command box prompt or shell prompt defer to later on Linux box specifying jar and the name of this WAR file, typically bringing up your web application, and you can continue with your installation. Now, the only thing being, if at all you want to stop using Jenkins, you just go ahead and close this prompt, even into a control C, and then bringing down this prompt and in Jenkins server. And then you also have the other older versions of Jenkins where run popularly using this way, in which you already have a Java based web server running up and running. So you kind of drop in this WAR file into the root folders or the HTTP root folder of your web server. So Jenkins will explore and kind of bring up your application. All user credentials or user administration is all taken care by the Apache or the Tomcat server or the web server on which the Jenkins is running. This was a very old way of running, but still some people use it because if they don't want to maintain two servers, now if they already have a Java web service which is being nicely maintained and backup, now Jenkins can't run a test to it, alright? So either ways, it doesn't matter however you're going to bring up your Jenkins instance. The way we're going to operate Jenkins is all going to be very same or similar, but the subtle change in terms of user administration. Now, if at all you're launching it through any other web server, which will take care of the user administration, otherwise all the command or all the configuration or the way in which I'm going to run this demo is going to be same across any of these installation. Alright, as I mentioned earlier, Jenkins is nothing but a simple web application that is run in Java. So all that is needed is Java, preferably JDK 11 or 17 with a 2 GB RAM, which is a meant RAM for running the Jenkins. And also, like any other open source toolsets, when you install JDK, ensure that you set in the environment variables. Now, Java Home to point in the right directory. Now, this is something very specific to JDK. Now, but for any other open source tools that I've installed, there is always a preferred environment variable that we got to set, in which is specific to that particular tools that if you're going to use. This is a generic thing that there is for you to know. Now, for any other open source project, because the open source project discover themselves by using the environment variables. So as a general practice or a good practice, always set these environment variables according. So I already have a JDK 17 installed on my system, but in case you do not, what I will recommend is just navigate to the browser, to the Oracle homepage, just type in your search for install JDK page, then you'll have the accept the license agreement. Now what I will recommend is just navigate on your browser to the Oracle homepage and just type in your search install JDK. Now you're gonna navigate to the down here and install the 64 installer, that is the .exe. Now let me show you once I have installed what I've done with regards to the path. So if you get into this environment variable, so I have just set in the Java home variable. Now you can go back to your this PC, go to C programs, go to Java, and then copy this part, then click in the environment variables. I'll select the first one, that is the edit the system environment variable, and we click on the environment variables and we'll set a path here. As you can see here, Java home, and we'll go down here on the path. So this is the path for your Java home screen. So simply click on edit and click on new, and we will just paste the path which we have just copied from the install.exe Java. So I've already installed it, as you can see there, C program files. I simply click on OK. So the only difference between the system variables and the user variables for daemon is this is control the whole system of the JDK. the system variables. So we want to edit in the system variables. So the path I've been changing here is in the system variables. All right. Now the home variable is where I have the SQLs and program friend of the JDK17. You see this is my Java home. All right. Now one thing to do is ensure that in case you run Java or Java C, for a command, you ensure that you also add the path into this path variable, right? So if you see somewhere, I will say there you got the colon program files. Now you click on that and I'll show you the bin as well, which I've copied and pasted here as well. Okay. So simply just go back. So that's how you get the bin. Copy this path and paste it here, which I've already done it. So I'll just simply click on OK, OK, and OK. Now let me minimize the screen as well. So the next thing we need to do now is go to CMD to check if your Java has been installed on your system. So you simply type on Java space / version, and you can see I already have Java version 17.0.5 installed in my system and is up and running. So as you can see the runtime environments, and this is a 64-bit server. This is a VM virtual machine. Okay, so as you can see, Java is installed in my system and is up and ready. So the next thing we need to do now is install Jenkins. I'm just canceling that out and open a new browser again, new tab, and type in jenkins.io. Now as you can see, this is the homepage of Jenkins. All right, so you can even read the documentation, or you can simply click on download. Will take you to this page. Now here you can see the hardware and software requirements, then what packaging is required for downloading the installing Jenkins. So this is the part for, on the left hand side we have the LTS, and on the other side we have the, which is a more stable, and on the right hand side we have the regular weekly releases. So we'll definitely go for the stable LTS download, which is a long-term support, which is released every 12 weeks, whereas the regular releases changes weekly. So I'll be going ahead and scroll down and click on window. So as you can see, there are different parameters where you can have on Dockers, then you have Ubuntu, then you have the CentOS, Fedora, or the Windows, like I'm going to install in this case in this demo. Then but we have different aspects as well, like the FreeBSD, the CentOS, Mac OS, etc. So as you can see on the first stop, we have the .var. We can even install that and unzip that. But in this case, in this demo part, we'll simply click on Windows. So go on ahead and click Window, guys. Now you can see the download has started. So we just wait a few seconds until it's done installing the MSI. And as you can see, it's done. So this is my download in Jenkins instance. So what I'll be doing now is simply click on next. Now, as you can see, guys, on top here, it's written the Jenkins run on localhost 8080. So keeping that in mind, click on next. As you can see, this is where our Jenkins is installed. That is in C and program files and by the name Jenkins. So you can always change this location where the Jenkins has been installed. But in this case, I'll rather keep it on the C drive itself. So the next thing you need to do now is we'll run server as a local system so that we don't have to put any administrator or the password. And so the next step now is we test the port. So as you can see, you got a green tick mark. So next, now you can see here that it has failed because there is no compatible Java version 11 or 17. But as you can remember, guys, we have already installed Java 17 and we have already verified that we're using the command prompt where it has shown us the version Java 17. So what you need to do is simply click on change and select the Java 17 from Java 8. So simply click on Java 17, JDK 17, as you can see, click on next and click on the install part. Done and dusted. So I've already told you that Jenkins run on the localhost 8080, right? So we're gonna go localhost / 8080 and hit on enter. Now, as you can see, please wait while Jenkins is getting ready for work, right? So this will take a few minutes and then you'll be having to provide the credential of the administrator. All right. So just give it a few minutes while it's starting up. All right. Now you have to provide the administrator password, right? So you can go ahead and go down out here. You can see the password is in the C and goes to the program data, then Jenkins. Then we have a .jenkins, then a secret, then you'll find the initial admin password. So we need to head out there. So what we need to do is we'll go down there.
So I'm just going to minimize the screen now. Minimize it once again. And as you remember, we go to the C. So you can see right where it is. I'll just show you minimize the screen here so you can see and do it along with me. So you can see this in PC. Then scroll down to C disk. Okay, this thing popped up. Sorry. It's in this. So you have a program data, right? As you can see here down, there is no program data, right? So what you need to do is it's in the hidden file. So what you need to do now is click on the three buttons and view, click on show and click on the hidden items. Now let's see if it's there. Scroll down, program data, you can see at the last. Yeah, simply click on that, double click on it. As you can see, then we have to go to the folder name as Jenkins. Yeah, you can see on the top, Jenkins and .jenkins. Then we need to search for secrets. There it is, folder. And as you can see, there's an initial admin password. Now you simply click on that. We'll try with the notepad so we can copy. So simply copy that and paste it in the administrator password and click on continue. So in this case, I will not save it in my computer or system. So there are two installation plugins available, which is custom by Jenkins. One is they have suggested plugins, and the other one is you can select the plugins which you want to be installed. So in this scenario, I'll simply click on the install suggested by the Jenkins. So what happened is the plugins are all related to each other. So it's like the typical RPM kind of a problem where you try to install some plugins and got a dependency which is not installed and you get all those issues. In order to get rid of that, what Jenkins recommends is that there are a bunch of plugins that is already recommended and they are good to go, right? So just go ahead and blindly click on that recommended by the plugins, which is a suggested or custom by the Jenkins. And as you can see, these getting started process is going ahead. So it'll take a few minutes depending on your internet speed or on your system. Now you can see all these plugins are installing it for you. So it will take a few minutes time. So let's just wait till we get all the plugins installed in a system properly. So this is a good combination to kind of begin with, and keeping that in mind, Jenkins need a lot of bandwidth, right? Now in terms of network, so in case you know your network is not so good, it'll make for a few of these plugins will kind of fail, and these plugins are all are available on openly or mirrored site, and sometimes some of them may be down. So do not worry, in case some of these plugin kind of fail to install, you get an options to kind of retry installing them, but just ensure that you at least at the most 90 to 95% of all of these plugins are installed without any problem. As you can see, we are almost there. It's around 60% to 70%. Now once all these plugins are installed, now my plugin in the installation is all good. There's no failure in any of the plugin. So after that, we've got to create this first username, that is the first admin user. So you need to give in the username and the password. Then you have to confirm your password, give it your full name and your email address, right? So we'll start it by giving the username. I'll keep it plain and simple. Now you got to remember these password and the confirm password, because if you kind of lose or you don't remember the password of the Jenkins, it'll be really hard to get back your account. So try to keep it as simple as possible, and keeping in mind that you have to remember the password, because getting back this account will be really difficult. All right, so I'll be putting the password as well. Give it my full name. Okay, my A is small, and go to the email address damandla.namare@edureka.co. All right, so once it's all done, so just simply click on save and continue. So click on never, don't want to save the password. And as you remember, I've told you by default Jenkins run on localhost 8080, right? So you can simply click this, or you can copy this, or just write save and finish. You can even copy this link, save and finish. Now start using Jenkins. All right, now that's kind of complete my Jenkins installation. As you can see, it was not that tough at all. Now the Jenkins is installed correctly. Now let me quickly walk you through some of the very minimal configuration that is required. Now these are kind of the first time configuration that is required. So, and also let me warn you, the UI is a little hard for many people to wrap their head around, especially the window guys. But if you're all a Java guys, you know how painful it is to write UI in Java. You kind of appreciate how the effort that has gone into the UI bottom line. It was a little hard to know wrap your head around. It becomes like start using it, possibly you start liking it all right? So I will get into some of these important ones, something called as configuration system, or the configuration a system. This is something kind of put in your configuration to complete your Jenkins instance. Now, few things to kind of look out for. This is the home. Now, configure system is where you kind of put in the configuration for your complete Jenkins instance. Now, a few things to keep a lookout is the home directory. All right. Now, this is a Java home where all the configuration, all the workspace, anything and everything regarding Jenkins is stored out here in the system message. Now, in the system message, you can put in some of the message on the system. You can just type anything you want, probably show up somewhere here on the menu. Now, the number of executors is a very important configuration. This just lets Jenkins know at any point in time how many jobs or how many threads can be run. So you can kind of visualize like a thread that can be run on this particular instance. As a thumb rule, if at all you're on a single core system, the number of executor you should be good enough in case at any point if there is any multiple jobs that kind of get triggered at the same time. Now, in case the number of executor are less compared to the number of jobs that are out there to open up the new, so you don't need to panic because they will get queued up and eventually Jenkins will be get up and running. So just keep that in mind that whenever a new job kind of gets triggered in the CPU usage and the memory usage, in terms of the disk, it's like a very high of the Jenkins instance. So that's something you got to keep in mind. All right. The number of executors for my system is kind of a good label. For my Jenkins, I don't want any of these usage. So how do you want to use your Jenkins? This is good for me because I only have a primary server that is running. So I want to use this as low as possible. All right. As you can see, it's 2. Now this is usage. So I can leave everything to default. So what I want is I want this SMTP server configuration. Now Jenkins will be sending out some emails. What I've done here is I've configured the SMTP details of my personal email details. In case you are, in your organization, you want some sort of an email that is like an email ID that is set up for a Jenkins server. So you can specify the SMTP server details of your company so that you can authorize Jenkins to kind of like send out emails. But in case you want to try it out like I have configured my personal email ID, which is of the Gmail for sending out notification for the same TP server, will be the SMTP Gmail. So it's right as username as so we have used SMTP authentication and then we give the password. Now you can just send out an email to see if at all this configuration works again. Now Gmail will not allow you to allow anybody to send out notification on your behalf. So you just have to lower the security level of your Gmail ID so that you can allow programmatically somebody to send out email notification on your behalf. So I've already done that. So let's see if this works. Let's test it again since I've entered the wrong password. Let's see if this works or not. And it has given me a password has not accepted. So now as you can see, since my Gmail has not been set up, so what you have to do is you have to lower your security level of your Gmail ID so that you can be allowed to test your email configuration. All right. So simply click on save. So now we're heading back to the dashboard. Now we should go to the global tool configuration. Now look at the scenario where Jenkins is a continuous integration server. Now it does not know what kind of a code base it's going to pull and what kind of tool says is required or what is the code that is going to pull in and how it is going to build. So you'll have to put in all the tools that is required for building the appropriate kind of code that you're going to pull in from like a source code repository. So for example, in case your source code is a Java code
and assuming that you have, because this demo, this is my laptop and I put all the configuration, JDK, everything on my laptop. Of course, I am a developer and I'm working on the laptop, but my country's integration servers will be known as a separate server without anything being installed on it. So in case I want Jenkins to, like run on a Java code, and I need to specify the JDK location of this out there. So, okay. Since I've already have the JDK installed and have already put in the Java home directly, or rather and the environmental environment correctly, so I don't need to do it. So now if at all you want the Jenkins server to use Git, now as you know that Git is a command bash or the command prompt for running Git and connecting to any other Git server. So you will need Git to be installed on that particular system. Now Gradle and Maven, if at all you have some Maven as you want to do this in any other tools that you're going to install on your system, which is your continuous integration server. So you'll have to come in here and try to configure it. And in case you have not configured it, then Jenkins will not be able to find these tools for building your task. So since I don't want to install anything, we'll go back to manage system. Now you can see the global, configure global security. Now you can see this an SSH server. Now what does this mean if you ask me? Jenkins own user database. So this is nothing but the security access control which is set to Jenkins own user database. So what this mean is, Jenkins by default, it uses files system where it stores all the usernames, which hashes up like these username that kind of stores them as of it. So as of now, Jenkins is configured to use in your own database, assuming that you're running an organization. So you will probably want to, have some sort of LDAP server, which will in turn have a control of your access to your Jenkins repository. So you will specify your LDAP server details, the root TN password or the managed TN. So the LDAP, as you can see, or the LDAP, which the Jenkins itself will tune in for your specific servers. Now you have the manager DN, the manager password. Now all these should be filled, all these details should be filled in case you want to connect your Jenkins instance with your LDAP server or any of the authentication server that you have in your organization. But for now, since I don't have any of these things, I'm going to use its own database. That's good enough, right? So I'll simply the Jenkins own user database. So I will set up some authorization methods. So for now, let me not get into any of these details of this. And just be aware that Jenkins can be connected for authorization to an LDAP server, or you can have Jenkins managing its own server, which is happening as of now. Let me put in a very, very simple job. All right, so let's create a new job in this video. So simply click on new item. Now simply you can add any item name here. So the most important here are the freestyle and pipeline. Now for the first demo, we'll click on the freestyle job and click on OK. So in the description, you can write anything in your description. This is an optional thing. So you can say this is my first job demo for. So in this demo, I don't want it to connect it to any source code for now. So I'm just going to leave it to none. Now we don't need to write any build environment as well. Now in this build step, we simply click on execute Windows on. So since I'm on the window box, I will say execute window bash command. All right. So what do you want to do? So let me just echo something. Echo hello world. This is hello. Welcome to my first demo job in Edureka. Then we'll specify the date and time as well. So put in date, colon as time as well. So you can see it's a very, very simple command. You just have to put an echo and we have something along with the date and time. So we'll keep everything as simple as possible. So we'll save this job. So once it is shipped, so you can see there's a build history. So once you have saved this job, the job name comes up here. As you can see, project first job. By mistakenly, I've written double T in my first job. Now, as you'll see here, there's some builds history. So there is nothing as of now because I've put in a job. I have not yet run it. All right. So let me try and build it now. Now you can see there's a number, my first job. So you will see a date and you will see the time since I've clicked twice. So if I've come 1 and 2. Now, if you click on this, now you can see the console output. Now, if you click on this, now you can see this. And this is the output that is run. Hello, welcome to my first demo job in Edureka, along with the date and along with the time. Now, if you see this, now if we navigate this, we go back to here. Now, as you can see, there's a folder created as jobs, right? So this is the directory what I was mentioning earlier regarding Jenkins home.
If you can just open it up wider, you can see this folder jobs. So this as mentioned earlier regarding Jenkins Home. So all the job related stuff, it's specific to this particular Jenkins installation is all here. Now all the plugins that I install, the details in each of those plugins can be found here, right? So the workspace is where the jobs that I've created, whichever I'm running will, there'll be an individual folder specific to the jobs that has been put up there. All right. So one job, one quick run. That is how it looks like. So the workspace is where all the jobs that I've created, whichever I'm running, which there'll be an individual folder specific to that jobs that has been made up. All right. So as you can see, there's the first job that we have just created just now. So one job, one quick run that we have done. That is how it's look like. It's pretty simple. Now let's go back. So let us put on a second job. So we can go back to dashboard, click on new items and say second job. Let's get the spelling correct this time. Second, I wrote second first again. Second job, and I can put a semicolon here, underscore. Second job. We click on freestyle again. Click on OK, and you can say this is my second. So I just want to demonstrate the powerfulness of the automation server and how simple it is to automate a job that is put on the Jenkins, which will be triggered automatically. Now remember what I've said earlier about Jenkins, because at the core of Jenkins is a very, very powerful automation server. All right, this is my second job. This is my second job, which will be triggered automatically. Okay, so in the build step, we'll put bash tabs, then we'll write here echo again. So we'll say here something as second job is going on here. The tools, with the tools of an automation tool. And then I'll give some date as well. Date, put on the time. But this time I'm going to demonstrate the powerfulness of the automation server that is there. So if you see here, there is a build trigger. So build can be triggered using various triggers that is there. So you'll get into the GitHub trigger or a hook or a webhook, which is kind of triggering. So we'll see that later on. But for now, what I want to do is I want to ensure that this job that I'm going to put in will be automatically triggered. Let's say every minute I'm on this job to be run on its own. So we'll put as build periodically and we will set the time. Now, if you can see here, there's a bunch of help. If you want to go through it, you can go through it. Let's just put out very, very simple regular expression for scheduling this job every minute. All right. So 5,000 is all I'm going to put in. 1, 2, 3, 4, 5. Now let me save this. Let's go back. So when you build periodically, now you can see here. Now we just copy that. And now how do we check if it gets triggered every 15 minutes? So I just don't do anything but wait for 15 minutes. And if everything goes well, Jenkins will automatically trigger my second job in 15 minutes. Now you can see here, it's still processing. So we have to wait for 15 minutes. Now we can go through all this command of the scheduling time. So you can see how many stars required for each minute or for each hour. Now as you can see, it's done. You can just go and go here and go to console output. Now you can see the finish is success and you have this. Now we can go back and copy this and see if they're on your it's already there. You can go to workspace. You can see your second job has also been created automatically by Jenkins. Now that I have my Jenkins up and running, a few jobs that have been put up here on my Jenkins instance, I will need a way of controlling access to my Jenkins server. This is where I will use a plugin called a role-based access plugin and create a few rules. The rules are something like a global rule and a project rules for a specific role. I can have different rules and I can have users who have signed up, or the users from my create kind of assign to these roles so that each of these users fall into some category. This is my way of kind of controlling access to my Jenkins instance and ensuring that people don't do something unwanted. All right. So first thing first, let me go ahead and install a plugin for doing that. So we get into manage Jenkins, then we go to manage plugins. We will plugins, install plugins. We have advanced settings. So these are the available plugins, and then if you go to install, now these are the installed plugins. Now let's go and search for a role-based. Now you can see here, base authorization strategy. So this will happen is it enables user authorization using a role-based strategy. Now roles can be defined globally or for particular jobs or nodes selected by a regular expression. This is the plugins, everyone. So you will install it without restart. So it's success. It looks good. Looks good. Now waiting for this. Yeah, success. Done now. So go back to the top page. Now one thing to remember, guys, is Jenkins is running on a Java using a Java instance. So typically many things will work the same way unless inherently you want it to restart. So, but a good practice is whenever you do some sort of a big installation or a big patches on your Jenkins instance, just ensure that you can restart it. Otherwise, there will be a difference in terms of what is installed in the system and what is there on the file system. So you'll need to flush out few of those settings later on. But for now, these are very small plugins. So this will run without any problem. But otherwise, if at all there are some plugins which they will need to restart, you can kindly go ahead and restart your Jenkins instance. But for now, I don't need that. So it looks good. I have installed the plugins. So where do I see my plugins and install the plugins? It is specific to the user control to the access control. Now let's go to the configure global security. Now we can go ahead and check the authorization. You can see here authorization, role-based strategy popping out here, right? As you can see, the role-based strategy has been installed and it's been shown here. This is because of my installation of my role-based plugin. So this is what I would want to enable because I already have my own database set up, and for the authorization part in that sense that you can do what I'm going to install. I mean, I've already installed a role-based strategy, right? Now I'm going to enable that strategy. So we'll simply click on role-based strategy, okay? And click on save. So now I'm going to enable that strategy. All right, now I will say, okay, now I've installed the role-based access plugin. Now I will need to just set it up and check, I will go ahead and create some roles, and it shows that I've assigned users as per these roles. So let me go to manage the configuration, manage Jenkins, and let's see how we can create our roles. Not here as well. So we can do manage and assign roles for creating a roles, okay? Now you'll only be able to see this once and only when you have installed those plugins. Now I've enabled the plugins. Now I've enabled the role-based access control as well. Now we'll go ahead and create some rules for this particular Jenkins instance. So first I will manage roles. So this is at a very high level, which is a global role. Now there are some role to add which you can add by yourself, some item roles for some projects or something. So let me create a role that's kind of visualized like a group. So we'll create our own called the developer. Typically the Jenkins instance or the CA instance are kind of owned up or controlled by a QA, guys. So that's why I'm creating a role called developer, and I'm adding this role at a global role. So I will add this here, and then I can click read as well. So we've given this administrator, right? So we add this. So as you can see here, you will see this develop a rule that there is each one of these options that you can hover here and sort of see what kind of permission you have given it to this developer role that you have just created. So you can read and write, then you can create some changes. We have given a permission as credential, which you can create. Then you can delete, then manage the domains. So this kind of help or the permission that they're giving it. So these are some kind of sort of a help for a permission specific. So you want to see it's like how it sounds a little different, but I would want to give you a very, very little permission for the developer. So from an administrative perspective, I just want him to have a read and write kind of a role credentials. Okay, let's say read and write, and I can allow him to view as well. I don't want him to create agents or give him some delete. No, I don't want him to configure, build, provision, or connect or disconnect anything. So I'll just give him a read and a view. And I don't even want him to have access to my workspace as well. So I'll just give him now for run. So I won't even give him the access to that. Now we can give view as well. I don't want him to delete. And what am I doing here is just creating a global rules for the developers. And I've given him a very, very limited roles in the sense that I don't want this developer to be able to run any agents, nor create jobs or build jobs or cancel jobs or configure jobs at the maximum. Right? So I just want him to read that is already put up there. Okay, so I would save now and create a rule. That is done. Now that I've created a rule. Now I still don't have any users that is in there. the system. So let me go ahead and create some users on the system. So we'll go back to Manage Jenkins and go to Manage Users. Now let me create another user, okay, by clicking on plus users, and we'll say this one as a developer. Give him some password and name him as develop123. And email, can just simply give my email here and click on create users. Okay, 12. So we have created. Now this developer 12 is a user that I've configured, but still yet I have not set any rules for this particular user. So I will go to the manage and gain and will give him the manage and assign roles. So now we'll go manage and assign roles and we'll assign role. So what you're gonna see, what I'm gonna do now is I'm gonna assign a role that is specific to that particular developer. So I'll find that particular user and assign him, or means the developer role that I've already configured the rules. Okay, so this is the role that we have created. So we will search the user that we have just created, developer 12. Now if I assign this, so go ahead and save the changes. Now let's go ahead and check the permission of this particular user by logging on to my main account and logging back as the developer one. Now let's log out from here. Log out and say developer 1. Now, if you remember, this role was created with very less privilege. So there you go. I have Jenkins, but I don't see a new item. I can't trigger a new jobs. I can't do anything. I see these jobs. However, I don't think I'll be able to start this job. Now, I don't have the permission to set forth at the maximum. So what I can do is look at this job, see. So this is a limited role that was created, and I've added this Damanang Lamare to that particular role, which was a developer role, so that the developers don't get to configure any of the jobs because the Jenkins instance is owned by a QA person. He doesn't want to give developer any ethnicity or right. So the rights that you set out by creating a developer roles, or any user who's tagged as a part of this developer role, will get the same kind of permission. And these permission can be, fine grained. It can be a project specific permission as well. But for now, I just demonstrate the high level permission that I've set. So let me quickly log out of this user and get back to my admin account. So because I need to continue my demo with the developer roles that was created. Now, one of the reasons for Jenkins being so popular, as I mentioned earlier, is the bunch of plugins, but it's got plugin for connecting anything and everything. Now you can find the Jenkins plugins, then you will see the index over here. There are so many plugins that are there. All of these are wonderful plugins. Whatever connectors that you will need if you want to connect Jenkins to the AWS instance, or you want to connect Jenkins to a Docker instance, or any of those containers, you will have a plugin. You can go and search up if you want to connect Jenkins to Bitbucket. So simply click on Big. So as you can see, these are available. So bottom line, Jenkins without plugin is nothing. So plugins is the heart of Jenkins for you to connect, or in order to connect Jenkins with any of the containers or any of the other sets of tools, you will need the plugins. Now, if you want to connect or you want to build a repository which has got Java and Melvin, you will need to install Maven and GTK on an instance. Now, if at all you're looking for a Microsoft build, you will need to have MS Build installed on your Jenkins instance, and the plugins that will be triggered MS Build. If at all you want to listen to some server-side webhooks from GitHub, you will need a GitHub specific plugins. You want to connect to Jenkins, to AWS, you need those plugins. Now, if you want to connect Docker instance that is running anywhere in the world, as long as you have the URL, which is publicly reachable, you just have a Docker plugin that is installed on your Jenkins instance. So if you want to connect to a Docker instance that is running anywhere in the world, as long as you have the URL which is publicly reachable, you just have a plugin that is installed on your Jenkins instance. Now, SonarQube is one of popular statistic code analysis, so you can connect a Jenkins build. You can build a jobs on Jenkins and push it to a SonarQube and get SonarQube to run analysis on that and get back the result in Jenkins. Now, all of these works very well because of the plugins. Now with that, let me connect our Jenkins instance to a GitHub. So now let us connect our Jenkins instance to a GitHub. Now I already have a very simple Java repository up on my GitHub instance. So let me connect Jenkins to this particular GitHub instance and pull out a job that is put up there. Right. So this is a very, very simple and repository is called Hello Java. And this is what is there in the repository. There's a simple class file. It's just got some one line of system .out. So this is already present on github.com at this place. and this will be the URL for this repository. So I will pick it up. So what I'll do is I will connect my Jenkins instance to go to my GitHub and provide my credential and pull out this repository, which is on the cloud hosted in the github.com, and get it to my Jenkins instance and then build this particular Java file. Now I'm keeping the source code very, very simple. It is just a Java file. Now, how do I build my Java file? How do I compile my Java file? I just say Java C and name. Now, the name of my class file is hello Java, and how do I run my Java file? I will say Java and hello. Okay, so remember, I don't need to install any plugins now because what it all needs is a Git plugin. So Git plugin, which is already installed on this system. So let us go back, create a new items. We'll create a first job here. Let's say this is a Git first project. Now let it be a freestyle. Okay. Now we'll go to the source code management. Remember, right? We always have been keeping it on none. So in this part, we'll put it as Git. Now, as you remember earlier in examples, we do not use any source code because we were just putting up some echo kind of jobs that did not need any integration with any of the source code system. So now let us connect this. So I'm going to put up my source code and it will show up because the plugin is already there. Now I've already copied the HTTP address from the GitHub and simply paste it here. Now what is the credential? So I'll simply add that. If we add credential this time, so I'll just click and cancel. So if it just add Jenkins, so we'll add a username here. Now if there are any errors in terms of not able to Jenkins to be able to find their Git or the git.exe, or if the credentials are wrong somewhere down here, so you'll see a red message, okay, like something is not right. So for now it's okay. Now I'm gonna build trigger. Now what will be there as a part of my build step, because this repository just have the Java file correct, hello Java. So in order for me to build this, I will say execute window bash command, and I'll say Java, hello Java, Java. Now let's save this. Okay, so let me try to run this. Okay, build now, click on this, console output. Great. Now as you can see here, there's a lot of executed Git on the behalf. It goes on there to provide my credentials, and so it pull all my repository and my default. Now we'll pull up the master branch. This is there on the post string, and it kind of builds this whole thing on Java C hello world. Finish, and it's given me a success. So it's kind of build this whole thing Java C hello to Java, and it runs this Java hello world. And there, as you can see, this is the output. It's there, and here you can see, if you want to look at the content that was created on the repository. Now if you can go there into my workspace like I've showed earlier, you can just simply click here, and you can already see here it's been created Git first project and it's saying hello. Now as you can see, it's already there. Now if you can go back, as you can see, and simply close that. Now what it did was Jenkins on your behalf went over all the way to GitHub, pulled this repository from there, and then it brought it down to your local system on my Jenkins instance. Now it's compiled it and it ran this particular application. Now that I've integrated Jenkins successfully with Git, simply within the Java application,
what is testing and what is the difference between a continuous testing and automation testing. That is what we have to discuss. I think the word test means simple. Testing, test. Test means to test something, whether it is working fine or not. You have developed something and you want to see if it is working fine or not. That simple thing is called as testing. Okay. Now, testing can be of two types. It can be automated testing, automated testing. You call it as automation, or it can be continuous testing. Now, what is the difference between continuous testing and what is the difference between the automation testing? Okay, like for example, I've deployed an application. Okay, I have an application running on the server. I go onto this application, I open the web page, and I'm putting the data, and I'm seeing whether the response is correct or not. I'm doing all these things manually. All the things manually by my hand. Like developer has developed the application. After the development is done, I just open the application, enter required fields, enter required data. After that, I simply see that it is working or not. I get the desired output or not. That is what is a manual testing. But normally, nowadays in the IT industry, manual testing has a limited scope. Manual testing only comes into the picture when you cannot automate it. Okay, but normally now, all the things can be automated in the IT world. How? Using some automation tools. Okay, we have some smart tools that can automate writing the test cases. What is a test case? What is a test? What is a test case? A test case is basically a procedure that describes like what should be the input and what should be the desired output. It's a procedure how to test something. That is called as a test case. So earlier, if I talk about long back, what people used to do, these test cases were written manually. Okay. After that, the team sits out, they distribute test cases and they execute each and every test cases manually one by one. That was a time when we do manual testing. Okay. Then later on, with the enhancements in the technology and to save the time, to deliver the product on time, people started thinking manual testing is tedious. First of all, a person can make a mistake. Okay, somebody can make a mistake during testing. And it's a person, let's suppose if he's on leave, then who is testing? The testing cycles, the time to test anything will be increased. So that's why people started switching to automation testing. Means here, you use some tools to code. Okay, you write the code basically using some tools like Selenium, JUnit. There are many tools available in the market. TestNG, there are many tools available in the market. Using those tools, what do? You write the code to test the application. You're writing a code to test it. Okay. So the complete procedure is coded. Then you simply execute that code. That code will go and test the application. On your behalf, that code will go and put the data and see whether the output is getting desired or not. If not, then it will show you the error that it has failed. Now, anyone in your team who knows how to run it can run it. Even if, let's suppose I am the person who's running the test cases automation, I am on leave. If some other person is also know how to run it, he can run it on my behalf. So there's no blockage. And automation is really fast. You execute it, it will give you the output in like within few minutes, like whether all the test cases are passed or not. So this is what automation brings into speed and less chances of error. Because when a human being is doing it, there are chances that there may be errors coming in even after your testing. Okay. So that's why people switch to automation. Okay. Now, automation is done by using some tools like you can use JUnit, or you may be using Selenium, any test cases you may be using, any test tool you may be using. So what is basically a continuous testing? We have seen manual, automation. Automation is done by a tool. What is continuous? Continuous simply means it's automation test, which is done continuously. What does the term continuously means over there? That is what the question is. So for example, let's suppose a developer developed something. Okay. That code is placed. Now that code will be built. You will start creating a package from that code. Okay. After the build, testing will be done. Automatically, test cases will be called and testing will be done. Now, let's suppose any of the test cases fails. Okay, any of the test cases fail. Automation testing is happening. Some Selenium or JUnit test cases are running. Let's suppose the testing fails. At that time, to the developer, a bug will be reported. Hey developer, there is a bug in the code. The test case is not passed. It has failed. What developer will do? Developer will create another version of the code. He will change the code. He will modify the code to fix the bug. He has to modify the code. So he's going to put another version of the code. Let's suppose this was V1. The code version is V2. Okay. Now from this version 2, you created a build earlier, build version V1. Now you will create a build version 2. And then use this build version 2 will again be tested. Let's suppose again something fails. A bug will be reported to developer. Developer will go and create a new version of the code after making the changes. In the V2, he will make changes. So version V3 will be prepared. From the V3, a build will be generated, which will be V3. And this V3 will again be tested. And this loop goes on and on and on and on until all the test cases pass. Until all the test cases are not passed, this loop goes on and on and on and on and on. And this is what is called as continuous testing. Any single bug fix, any feature update, a single line of code is also updated, then also it will be tested. Using some automation only it is tested, like Selenium JUnit, some automation tool will be used. But the testing is happening continuously. Whenever the bug is reported, some code will be changed. That code will be, from that code, a new package will be generated and that package will be tested. So this is what the continuous testing is all about. Automation means automating the task. You're writing some code to automate the task. Okay, so that is what testing is all about. And that is what the difference between automation and continuous testing is. This is the loop: planning, coding, building, testing. Basically, this is your CI loop and this is your CD loop. So testing comes in the CI loop, in the integration loop, where you build and test. You write the code, you build it, and then you test it. Once testing is passed, then you will go and release it, deploy it, operate it, and monitor it. This is your continuous deployment loop. DevOps is all about CI/CD, creating these CI/CD pipelines. You have to create this CI pipeline and the CD pipeline. Okay, starting from writing the code to the deployment of the final application. This is DevOps. This includes many things. Writing code, so maintaining code. Writing code is not part of DevOps. Code will be written by developer. But once the code is written, you have to maintain it. You have to maintain different versions of the code. Okay, you have to build it. You have to test it. Then you have to go and deploy it. After that, you have to operate it. And then you have to monitor it. These are the stages of your software development life cycles, which are handled by DevOps. DevOps is basically a methodology that automates all these tasks, all these stages. Okay. So now, what are different tools used for testing? Okay, tools. We'll talk about these tools. Like we have Selenium and TestNG. Maven is also a tool. Maven is basically a build tool. So we'll talk about these tools in a short while, but let's first talk about what are different types of testings that we perform. What are different types of testing? So we have heard many of the names: functional, unit testing, load testing, stress testing, integration testing, regression testing. What are these? So if I talk about them, functional testing means, by the name it is clear, functionally application is working or not. Like I give an input and I get the desired output or not. That is what functional testing is. Okay. To check whether the required functionality that is mentioned in the requirement of the customer. Customer gave you some requirement. So in functional testing, we see that whatever was the requirement is actually working or not, is functionally working or not. That is what functional testing is all about. Second is your unit testing. Unit testing means, let's suppose in an application, you have different components. You have a front end, you have a back end, you have a middleware, you have a caching, you have a queuing server. Like one application has many components. So testing each and every component independently is called as unit testing. Okay, unit testing means testing smaller components of your application, small components. Okay, front end, backend, middleware, then you have any caching or any other layers, any other components that you have. Testing each of them individually and checking whether they are working together or not. They are working independently or not. Their functionality wise, they're working or not. That is what we check in unit testing. Okay. And integration testing, if I talk about this integration testing is all about when you combine all these units together. First of all, we test each and every individual unit. After that, we combine all these units together. Okay. After combining all these units together, we see that whether our final application is working or not. That comes under integration testing. So integration testing is all about integrating the components combined together and to see if all the components when combined together are giving the desired output or not. That is what is your integration testing. Okay. Then after this, we have load testing and stress testing, almost similar with a small difference. Load testing means you give enormous amount of load on the application. Okay, let's suppose you are creating an application that is going to back up something. You're creating a backup application. Now, how much data that application can back up? So you will start with 10 GB. Okay, that's fine. You will go more 20 GB, 30 GB, 300 GB, 400 GB, 500 GB, 1 terabyte, 2 terabytes. So you will increase the load capacity to check how much load can the application can handle. Okay, so load testing is basically process of testing the performance of your application during heavy load. Like at 10 TB, when you're trying to back up 10 TB, the application is working very fine, very smooth. 100 GB, also good. When you are trying to back up 300 GB or 1 terabyte, the performance, the backup is taking much amount of time. The performance is not good. So definitely you have to work on that part. The developer has to work on that part. That the application is failing the loads, load testing, it's not good. The performance for when you're backing up big amount of volume, big amount of data, the performance is not good. So that will be tested under load testing. And stress testing, again, stress testing is a type of testing to get a break-even point. Like at what point, what load you give to the application and your application will fail. That is called as stress testing. Simple thing to test the maximum load that your application can bear. That comes up under the stress testing. Almost similar, okay, with a small tweak. Okay. And then finally, you have the regression. Now, what the regression is all about? Regression is like, for example, as I discussed that, you make a small one-line change in the code. One-line change. So there, even if you're making that one line of change, you have to run all the test cases right from this beginning till the end. Because that one line change can cause other functionalities. It can hamper other features, other functionalities. Okay, so this is what a standard practice is. Like whenever a developer makes any code changes, complete test cycles have to be executed. Okay, it is not like that you have made a one line of change, you will test that only. No, it can happen that that one line of change can even a one word of change can break other functionalities, can break other components. Okay, so that to test all the features, regression means continuously testing. Even a small component is modified, you will be completely testing the end-to-end entire application. So such kind of testing is called as a regression testing. Okay, so these are different types of testing that are performed in the real world for our applications. Okay, now coming on to the tools, like what tools we use over here. Okay, so let's see the tools. Role of the container. So we talked about the tools here, Maven, Selenium, TestNG, Jenkins. Let's talk about these tools a bit in detail. Okay, so Maven, first of all, what a Maven is. Maven is basically a tool that can help you in automating the task, that can help you in building anything. Okay, that decides on the dependencies. For example, I'm writing some Selenium test cases, and that Selenium has some requirement. Okay. So Maven is a tool that will help you in managing the builds, managing the dependencies of the test cases. Like for example, I want to execute Selenium and Selenium requires a Java class. There's a special Java class that is required by Selenium. So who will fulfill that? That is required. That will be done by Maven. Maven is the tool. Maven is the build tool that not only builds the application, but it also goes and resolves the dependencies for testing. So that is done by Maven. Maven is given by Apache. Mainly, Maven is used with Java projects. For Python, we have something different. So we have many tools like Ant, Gradle, Maven. Maven is one of the build tool. Okay, so we have many build tools. Here, we'll talk about Maven because Maven is one of the most popular build tool that is used for mainly for Java projects. Any Java projects means application, a project that is built in Java. Okay. So that is what Maven is. If I talk about Selenium, what Selenium is, Selenium and TestNG and Selenium. So Selenium is a tool that is going to automate, that helps you in automating the test cases. Selenium is mainly used for testing web applications, web pages, any web application that you're developing. Okay. For to test that web page, web application, we will be using Selenium. Okay. And it can easily integrate with tools like Maven, TestNG, Jenkins, easily integrate. So Selenium is basically the tool in which you will be writing the code. You will be writing the code and that code is basically going to test your application. So Selenium will allow you writing that code. Okay, Selenium is the test tool. Maven is the build tool that resolves dependencies, that builds your application. Like for example, I want to build my application that requires some Java class. So that Java class will be pulled by Maven. Okay, Selenium will go and perform testing and then test NG. So basically Selenium has few drawbacks. Like Selenium can automate your testing. Okay, that's fine. But Selenium is very bad when it comes to writing test cases. Like you want to write test case, Selenium will not be able to do it. You want to generate any report, Selenium will not be able to do it. Okay, so Selenium is really bad in doing such stuff. So to maintain those stuff, what we use is we used TestNG. TestNG is another tool that is mainly used for your managing test cases, writing test cases, and for creating test reports. Like, okay, Selenium, all the test cases that were run through Selenium are passed. Who will give the report? TestNG will give the report. Okay, so TestNG is basically a reporting tool and mainly used for performing, managing your test cases, which Selenium won't be doing it. Okay, and last but not the least, we have Jenkins. We have Jenkins. So all these test cases, normally nowadays, testing team writes it. DevOps engineer can also write these test cases, or developer can also write the test cases. Nowadays, there's a trend that, okay, that what happens here is, whenever a developer develops the application, along with that only, developer writes the test cases as well. Okay, instead of DevOps guy writing the test cases or the testing team writing the test cases, the developer only says, okay, we have to test all these things. They write their test cases. Now they can use Selenium, they can use JUnit, anything. Those are tools for executing test cases, for writing it up, for Selenium test cases or JUnit test cases. But yes, they do it up. Okay, and we just have to integrate those. We just have to call those test cases. Okay, we just have to call those test cases and execute those. That's it. And how we do that? We do that using a tool, is Jenkins. So Jenkins, there are many tools available in the market similar to Jenkins. Like you have Bamboo, TeamCity, Hudson. There are a lot many tools which are competitors of Jenkins. But yes, Jenkins is one of the tools that is very widely used for integrating the things. It's an integration tool. Integration tool means, let's suppose you have the code. Okay. Now using that code, you will first build the code. Building the code means what you have to do is you have to create a package. You have to build it because raw code cannot be tested. Nobody can test raw code. It's raw Java code. It's raw Python code. We cannot test it. You have to build it. After building, then you will run the test cases. Now, any testing, unit testing, JUnit testing, functional testing, load testing, stress testing, regression, whatever you want to execute, it's up to your wish. You have to test it. And then if all test cases are passed, you have to go and deploy it. That's it. Simple thing. So how you can integrate all these stages together, like starting from pulling the code, building the code, testing the code, after testing, deploying the product. Okay, because you have the code, you build the product, you tested the product, and then you have to deploy the product, and then you have to monitor it up as well. So how this can be done, how all these stages can be integrated. So for doing that, we use a tool called as Jenkins. Jenkins is an integration tool. A tool mainly used for automating the things, for integrating multiple stages. Okay, it can schedule your builds, deploy the code to production or staging server, any environment. You want to deploy, you want to build, you want to test, it will do it. And this is one of the tools that is very widely used. Okay, reason of its popularity is open source. It's the first tool, integration tool in the market. Along with that, the simplicity, the ease. I will show you Jenkins in short while. Okay, the simplicity or the ease that it provides for managing the things is very useful. It's very easy. Okay, so that's why people prefer Jenkins a lot. Okay, so let's see how this Jenkins will help me in achieving test cases, in managing test cases. Let's see over here. Okay, let's go and check it out. Okay, so what I've did here is to just show you a small demo over here. We'll see a small hands-on first. Okay, so to show you a small demo, I am on my GCP. You can see that this is my GCP over here. Okay, so to show you the demo, what I've did is I've created a machine. You can see this machine is there, instance number 1 that is running. Okay, and onto this particular instance, okay, the IP address of this instance of this machine is this. You can see the IP address. It also has a public IP, and on this machine, I've installed Jenkins. I've already installed Jenkins. You can see that over there. This is the machine. Okay, you can check the IP. Okay, the IP for the machine is 10.128.0.3, and that is what you can verify from here. Okay, this is the internal IP. This is the external IP. Okay, so now what I can do here is just see systemctl status Jenkins. It's installed. To install Jenkins, you can simply go on Google and just type here on Google. Just go here and type install Jenkins. I'm using CentOS. If you're using Ubuntu, you can use Ubuntu. So you can just go here, how to install Jenkins, and you can follow these steps. Like I'm using Red Hat CentOS. So you can follow these steps over there to install Jenkins on a server. Okay. Once Jenkins is installed, we can see that it's running over here. Yeah. Now what next I have to do is I have to just access this Jenkins UI. So let's go and access the Jenkins UI. I go here. Okay, I can reopen this if you want. Just a minute. Yeah, I can reopen this. So what is the IP of my machine? Let's see the IP address of my machine. This is the IP internal. External is this. Copy. Okay. And let me open this here. Followed by Jenkins runs on port number 8080. I hit enter. It says welcome to Jenkins. Guys, this is a public URL. You can also open this. I can put the URL on the chat box. Right now, I'm not sharing the ID and the password with you, but you can open this web page. Okay, let me put my admin password, admin and the password. Okay, so you can see I'm logged in. Okay, I'm logged in onto this. This server is created just before I started. Okay, like you can see the uptime. It will be around 30, 40, or maybe 1 hour, not more than that. Yeah, 1 hour and 14 minutes. This is the uptime. So before the start of the webinar, I created this machine. And at the end of the webinar, I will go and delete this machine. Okay. So Jenkins is running. I'm able to log in. Okay. Now, what I have to create a pipeline. What I need to do is I need to perform the code checkout. I need to perform code building. Then I need to test it, and then I need to package it. All those things I have to do. So for doing that, I have a sample Java code with me over here. You can see that Java code is here. You can see that JSHD07 DevOps class codes. Okay. This is a Java code, guys. This is a Java code for building an address book. Like I'm going to build a page like this. Okay. So I will show you the artifact will be built. Okay. But deployment part will not go into, CD part will not go into. We'll mainly focusing on the testing part. So only CI part will focus, not the CD part. So if you want to see CD, then I have to install Docker, or maybe I have to install a Kubernetes server. And then on that, I have to deploy this as a container. I have to create a container, or maybe I can use a virtual machine as well. On that virtual machine, I can install Tomcat, and on that Tomcat, I can go and deploy it. But I will not do that as of now, because our main agenda is testing, not to understand deployment, CI/CD. So we are not into that. So let's see how we do it. Okay. So you can see that right now, this is the code SRC. If you see the folder SRC over there, this is the application code over there. So it's written over there. Can you see these files, Java files? See this Java file. You can see the Java code. Okay. This is the Java code for my application. Okay. You go into the main, or you go into this SRC. You go into the main, and you go into the PMD or whatever. Can you see these all XML files? Okay. All Java files over here. Okay, you can see this tutorial address book, and you will be able to see all the UI Java. You want to see the UI file. Okay, so this is a Java file again. You can see this UI file. Okay, all this is a code a developer has written it. As a DevOps engineer, it's not my job to write it. Okay, we don't have any separate DevOps engineer is not going to write it. Only a developer will go and write it. Okay, so if you don't understand the code, that's fine. No need to worry. We are going to see how we execute this. Okay, how we build it. Okay, this is the raw code. And along with this raw code, test cases are also written. You can see that. Can you see these are test cases? If you go into this Java com Edureka demo utilities, these all things like exception thrower.java. See, you're testing something. Int I equal to 10 log info plus I. Throw new input output exception. Then you're automating, you're writing test cases. See, these are the test cases that are written. So when you will go and deploy, you will be using MVN to test, Maven for building, Maven for packaging. All these things you're going to use. Okay. So let's see how we do it. Yeah. So this is the code. In the code, this is my source folder. In the SRC, this is the application code, and this is the test cases that I need to execute. Okay, so how to automate this? Simple. Let's go on to Jenkins. Let's create a job. Let's create a Jenkins job, a project, a build job. I click on new item. Okay, you can name anything like my Java project. Okay, I can name it anything. I'm going to use a pipeline. I need to show you everything in the pipeline. Code checkout, code building, code testing, then code packaging. Okay. So I will be, if I show you the pipeline over here, this is a pipeline look like over here. You can see that. Okay. Just a minute. Let me open it up. So this is the pipeline that you can see. So what I'm doing here in this is, let me put it on a notepad. Okay, so this is the pipeline. I can put this pipeline for you guys if you want on the chat. I'm not sure if it will come on the chat or not, or maybe I will upload the file. Just a minute. Yeah, I think it's coming up. So you can copy it from there as well. You can copy that pipeline as well. Okay, so that is what my Jenkins is going to deploy. My Jenkins is going to run. So see what I'm doing over there. See, first stage is a checkout stage where I'm just doing a git checkout. I'm copying my code. Okay. Now, after I do a copy of the code, I do a git checkout. After that, I do a compiling. So for compiling, what tool in Jenkins I'm using? I'm using Maven, MVN as a build tool. MVN compile. Compile my code, because once compiling is done, then only you can test it. Raw code cannot be tested A compiled code are only tested. Nobody can test a raw code. Okay, once compiling is done, compiling means once you get the compiled code, okay, which is in the form of which your computer system can understand, that code you will go and test. So for testing, I'm running a command maven test, mvn test. That's it. So mvn is basically maven. Maven is installed on Jenkins. If you want to check, I can show you that as well. Like I go onto my browser and I show you here which maven. See, maven, or maybe I can do here mvn minus version. I think it is not copied there. So you can see, yeah, it's there, maven. Can you see the version of maven that I'm using? Sorry, it's in opt maven. It's not in this. So mvn minus version, see, maven is there on my system. Okay. And I'm going to use this maven as a build tool for deploying, for building my application, for testing my application. So as a next step, I'm just going to do an mvn compile. After the mvn compile, I'm doing an mvn test. Now, once all the test cases are passed, then it will go and create a package. The file that is ready to be deployed. This is, guys, my CI. This is what my CI pipeline is. Okay, CD comes after this. Now, where you need to deploy on a VM, on a container. So I will extend this pipeline. I will extend the more stages, but we are not going to do the CD part as of now. We'll just keep it ourselves restricted to CI. For CD, basically, we cover all these things in our training program, in our DevOps training program, CI, CD, Terraform, Ansible, all those things we cover. Okay, but yes, let's see how we do it up. So let's create this pipeline. Okay, so let's open this. Right now, what I'm going to do is copy this over here. From here to here, I copy this completely. Control C. And I go back to my Jenkins. And I create my Java project, which is a pipeline project. I click OK. Once you click OK, a project is created. See, it takes me to the next page. Now in this, I don't need to do anything over here. I just need to put my script. It's a Groovy script. So I just have to put it up here. That's it. Okay. I have to give my pipeline. Okay. And I'm just giving all the stages. Git checkout, mvn compile, okay, mvn testing, and then mvn packaging. All these things I'm giving. Okay. Finally, apply this and save this. Okay. So right now, my job is ready. You can see my job on the backend. CD, if I do var lib Jenkins, this is the data path for Jenkins. PWD, I'm in var lib Jenkins. CD to workspaces. Okay. ls minus al. Okay, right now, nothing is created inside this workspace. When I will go and execute, right now, see, nothing is there, ls minus al. And what's my PWD? So right now, nothing is there. Let's go and execute a job. Let's go and execute my build job. Let's do that. Okay, so how to do that is just you have to run this. You have to execute this. So click on build now. So once you're building it, you will see different stages coming up. The first job started, Git checkout is happening over there. Now it is doing a compile. Okay, compiling. Now it is testing the thing. Okay, test cases are getting run up here. Okay, now testing is happening. After test cases, it will go and package it up. It will building it up. It's building, it's creating the package, the final package. And it's successful. See, this is green. This is green. Okay, so this is what DevOps is all about. Automating the thing. It's taking the code, compiling the code, testing the code, and then building. On the back end, you see here, earlier this was empty. Okay, now you see ls minus al. Can you see this my Java project created? Because you ran the first job. You created the job, that's why it created the folder here. cd to my Java project, ls minus al. Can you see the complete source code over there? See, all these files are present on GitHub as well. See this GitHub. See, src, Dockerfile I'm not using. I'm not using Docker over here. Docker is mainly used for deploying it. Okay. README, address book, build.properties, build.xml, pom.xml. So 1, 2, 3, 4, 5, 6, 7, 8. 8 files are present. See these 8 files. Yes, 1, 2, 3, 4, 5, 6, 7, 8, 9. I think one more is created right now. Yeah, this one, this address book.yaml. Let me see that. Is it was there? 1, 2, 3, 4, 5, 6. Oh, 9 are there. 1, 2, 3, 4, 5, 6, 7, 8, 9 files. 9 direct there. And you can see exactly same over there. So my code is checked in. It has been checked out over there. Apart from that, can you see a target folder as well? From where does this target folder comes up? Whenever you compile Java, okay, Java code, you compile Java code, it created the target folder. CD to target. Maven created this because Maven did the compilation. ls minus al. Can you see this final output? Can you see this classes? You go to CD classes, ls minus al. Can you see this CD to com? Basically, let's go to com, ls minus al. No, I think it's CD to Edureka demo. Where's the class file? No, I think it's not here. I think, let me just go back, ls minus al, CD to address book, ls minus al. Where I think it should be, the classes file should be inside this only. Yeah, let's see that classes file, cd to classes. Sorry, cd to classes, com Edureka demo, and let's go into the helper. Yeah, can you see these class files actually? See this ls minus a. Can you see these class files? What these class files are? So whenever you have the code, you have the Java code with you. Okay, whenever you compile the Java code, after compilation, you will be getting a class file in the backend for that code. See the class file. This file was not present in my code. You want to see the code, actual code? Let me show you that on the GitHub. Okay, let's go back on the GitHub. I go on the CSRC, I go on the main. Okay, I go here, I go into the helper. See, it was a Java file, .java. It was a .java file. Source code was .java. When you compiled, in the end, the compiled output is .class. So now compilation is done. After the compilation, you will do all the test cases. Once the test case is passed, you are going to package it. And this is what your final package is, the one in the red, address book.wall. Now you can deploy this on Tomcat. You can create a server, you can create a CD pipeline. On that, you can deploy a server. On that server, you install Tomcat. On Tomcat, you go and copy this and execute this. That's it. That will be a part of CD. My job is not to go with CD as of now. I'm going to show you CI, and this is CI. Can you see this file, this WAR file? WAR stands for Web Archive. Web Archive. That is what it is. Okay, Web Archive. That is what your WAR file is. So this is your final output. This is the final deployable artifact. You want to check the logs? Let's see the logs as well. Okay. I will give you the logs. Okay. Okay. Let's see the logs over there. Let's go to my Jenkins and click on this number 1 job. Okay. You want to see the console output? See the console output. Okay. So on the console output, it first running the job in varlib Jenkins workspace my Java project. Okay, that's fine. Okay, now you see it did a git config, git all these things it did. Now after that, Maven compile, it's compiling the things. So when it started compiling, it called the Maven. Okay, to compile it, it created inside the target, it created the classes folder. See this folder. Okay, inside this folder, it created address book UI. .java will be compiled to Java, will be compiled to .class files. It will start creating all the class files for the tools. Okay, once the build was success, then it tested all the class files. It's doing the testing right now. See this testing, test cases, running the test loggers and all these things. Okay, so after testing, once the build is success, then it go to the packaging. And in the end, you will get your final package. See, if you scroll down over here, build success building WAR file in this. See this. var lib Jenkins workspace my Java project target address book.war. See this. Can you see the file on the back end? Yes. See what's my PWD. Sorry, let me go back over there. CD var lib Jenkins workspaces my Java project target my Java project and then target ls-al. See my PWD. Inside this, you have this file. Var lib Jenkins workspace my Java project target. And that is what my log says. Var lib Jenkins workspace my Java project target. Inside that, you have the final file. This file you have to go and deploy now using a CD pipeline. So CI pipeline we have seen, but this is how we test. This is how we integrate this.
So since Docker is a containerization platform, it's important to understand what came before containerization, or what is the history of containerization. So before Docker came into the picture, before containerization came into the picture, there was this concept of virtualization, or basically using virtual machines. So virtualization was this technique of importing a guest OS on top of an operating system. And this technique was a revelation at the beginning because it allowed developers to run multiple operating systems in different virtual machines, all running on the same host operating system, which nothing but eliminated the need for extra hardware resources. Now, the advantages of virtual machines or of virtualization are many. Multiple OSs could be run on the same machine. The maintenance and recovery was easy in case of failure conditions. And the third point here being the total cost of ownership was also less due to the reduced need for infrastructure. So as you can see here on your screen right now, you can see that there is a host operating system on which there are multiple guest OSs running, which is nothing but a virtual machine. So as most concepts have their shortcomings, virtualization also had a few. So running multiple virtual machines on the same host OS, each to the performance of degradation. This is because the guest OS running on top of the host OS will have its own kernel, own set of libraries, and own dependencies. And these take up a large chunk of the system resources, that is the hard disk, processor, RAM, and other resources. Another problem with a virtual machine, which used virtualization, that it takes a lot of time to boot up. So the problem is very critical in case of real-time applications, so these drawbacks were always there. Apart from that, you also have the age-old battle between development and production teams, that the code works at development and does not work in productions, because the developer has a system with their own set of libraries, their own kernel, and the apps running on there, whereas the production team has these resources of their own. So this is a problem that you can blame upon the difference in the computing environment. A code that runs on the developer's system might not run on someone else's computer. So this led to a new technique called containerization. Basically, a container brings virtualization to the OS level. While virtualization brings abstraction to the hardware, containerization brings abstraction to the OS. So what you might notice here is containerization is basically virtualization, but it's more efficient because there is no guest OS here. It utilizes a host's operating system, shares relevant public libraries and resources when needed, and unlike virtual machines, the application-specific libraries and binaries of containers run on the host kernel. So each app has its own set of libraries and binaries in its own little container, which makes processing and execution extremely fast. Even if you have to boost a process, it takes only a fraction of a second, because in case of containerization, all the containers share only the host operating system, but hold all their application-related binaries and libraries in themselves. They are lightweight and faster than virtual machines. So here, as you can see, there is your host OS or your host kernel, which is shared by all the different containers. So the containers themselves only contain the application-specific libraries which are separate for each container. This is what makes them faster, and they do not waste any resource. All these containers are handled by a containerization layer which is not native to the host OS. Hence, a software is needed which can enable you to run containers on your host OS. And this is also how containerization solves the difference in computing environment problem. Now, a developer works on containers instead of virtual machines. The app and its required libraries and binaries all are in one container. So when it is passed on to the testing team or the production team, it does not matter whether their host systems have the same libraries. All the dependencies are already present in the container containing the app. So now that you know what is virtualization and what is containerization, and why do we need containerization, let's move ahead and talk about Docker. Why do we need Docker? So a challenge I briefly spoke about earlier is what I would like to elaborate on in this section. Now, when you have a project code in a development lifecycle, there are different environments. You have your virtual server, you have your staging environment, you have your production environment, you have your QA environment. Now, most of the code that we deploy today is done using VMs or virtual machines. Now, how this works is that a developer or certain developers will write the code, and all of it is placed in a version control system such as Git. Now, this could also be placed in a staging server depending on your organization's infrastructure, but most organizations these days use a version control system. So more often than not, the code is placed in that version control system. Now, this code is never directly deployed in the production server. It's usually first deployed in a lower lifecycle server like your QA server or your staging server. Now, once it is successful in that, then only it is deployed on your production server. Now, this is where the chances of conflicts increase. So the same piece of code that might be running on your staging server might not run on your production server. And the reason is very simple, is the difference in the computational environment. This is also known as infrastructure incompatibility. Now, in most cases, your QA servers or your QA environment, staging environment are always updated. In most organizations, that's the case. It usually has the latest libraries, latest binaries, latest jars, all that jazz. But the same cannot be said for the production environment. So in order to face all these challenges that is faced, difference in environment and lack of optimization of resources, we use Docker. So this is where Docker comes into picture. Docker does virtualization in the software level, and we call it containerization, as I had mentioned before. So here, as you can see, containers are bundled with their own set of libraries and binaries, but they can communicate with each other with a fixed set of protocols. The thing about containers, however, is that they do not have their own operating systems, which is a great thing, because this is what makes them lightweight and function on very little resources, which makes them really fast as well. So what exactly is Docker? As you can see on your screens, there are two machines. The first one has 3 software applications. One is Angular based, one is React based, and one is Django based. Now, all of them are using common resources from the systems, libraries, RAM, processor, etc. And the frameworks are allocated a location in the memory. Now, how is it different from your machine with Docker? Since you have a Dockerized machine, you have a Dockerized system, all of your frameworks and binaries and libraries required by your Angular app, your React app, and your Django app can be put into their each isolated containers, which are going to run independently from each other without interfering with another app. And the space in which you had your framework stored has opened up. So now you can add another software application there with its own frameworks and libraries, binaries, etc. And that is what Docker is meant to do. It's a tool designed to make it easier for you to create, deploy, and run applications by the usage of containers. Docker is a containerization solution. Docker containers do not use the guest operating system. They use the host operating system, and on top of that host operating system, there is the Docker engine. And with the help of this Docker engine, Docker containers are formed, and these containers have applications running in them. The requirements for those applications, such as all the binaries, libraries, frameworks, jars, etc., are also packaged in the same container. There can be multiple containers running simultaneously. As you can see, there are 2 containers here in our example, and those containers have applications running in them. And you don't really have to pre-allocate any RAM to those containers. These containers allow a developer to package an application with all its parts, all its needs, and then you can deploy it as one whole package. They are basically lightweight alternatives to virtual machines that use the host operating system. This is basically a general workflow of Docker. So you can see one way of using Docker over here. What is happening is that your developer writes a code and defines an application requirements or the dependencies in an easy to write Docker file. And then this Docker file produces Docker images, so whatever dependencies are required for a particular application is present inside the image. Now, as we have specified many times before, what are Docker containers? Now, the Docker containers we spoke so much about are basically the runtime instances of these Docker images. This particular image is then uploaded onto Docker Hub, from where anyone can pull the image and build a container. Now, Docker Hub is nothing but the GitHub of Docker. It's like a repository for Docker images. It contains public as well as private repositories. So from the public repositories, you can pull your images and you can upload your own images as well to Docker Hub. And then, as I mentioned, from Docker Hub, various teams such as your QA team or production team can pull the images and prepare their own containers, as you can see in the diagram. So this shows a great advantage of Docker is that whatever dependencies that are there that are required for your application to run are present throughout the software delivery lifecycle. If you can recall, the initial problem that was there with VMs was basically that the application worked fine in a development environment, but when it reached the production environment, it was not working properly. So that particular problem is easily resolved with the help of this particular workflow, because you have the same environment throughout the software delivery lifecycle, be it a developer, testing, QA, or production. Now, before moving on to the next section, let's look at a case study about containerizing the NASA Land Information System framework using Docker. Now, developed by the Hydrological Sciences Laboratory at NASA's Goddard Space Flight Center, or GSFC, the Land Information System, or the LIS, is a high-performance software framework for terrestrial hydrology modeling and data assimilation. Basically, the LIS enables integrating satellite and ground-based observational products and advanced modeling algorithms to extract land surface states and fluxes. Now, this framework was very difficult for non-experts to install due to many dependencies on specific versions of the software and compilers. This situation then created a significant barrier to entry for domain scientists interested in using the software for their own computing systems or in the cloud. In addition, the requirement to support multiple runtime environments across the LIS community had created a significant burden on the NASA team. Now, to overcome these challenges, NASA had deployed LIS using Docker containers, which allowed installing an entire software package along with dependencies within a working runtime environment. They also used Docker Swarm, which we shall learn about later, to orchestrate the deployment of the cluster of containers. This installation, that used to take weeks or months, was now completed by NASA officials in minutes, either in the cloud or on premises. Now, moving on, let's look at Docker's workflow and architecture. What you see in front of you is the Docker workflow. Now, the Docker engine uses a client-server architecture, where the Docker engine is simply a Docker application that is installed on your local machine. The client-server architecture communicates using a REST API, and the Docker daemon checks the requests to manage the containers. So the Docker architecture includes a Docker client, which is used to trigger Docker commands, a Docker host which runs the Docker daemons, and a Docker registry which stores the Docker images. The Docker daemon running with the Docker host is responsible for images and containers. We'll understand the concept of images a little later in this very section as a part of Docker components. So to build a Docker image, you can use the CLI or the client to issue a bill to command the Docker daemon which runs on the Docker host. Now the Docker daemon will then build an image based on your inputs and save it in the registry, which can either be the Docker hub or a local repository. So if we do not want to create an image, then we can just pull an image from the Docker Hub, which would have been built by different users. And finally, if we have to create a running instance of any Docker image, we can issue a run command from the CLI or the client, which will create our Docker container. So this is basically the overall architecture or the overall functioning of the Docker architecture. As we move forward in this section, things will be more clear to you. So as you can see, the heart of the Docker architecture is basically the Docker engine. The Docker engine is simply the Docker application that is installed on the host operating system of your host machine. It works like a client-server application which uses a server, which is a type of long-running program called the daemon process. The second point here is the command line interface or the client. The next component here is the REST API, which is used for communication between the CLI client and the Docker daemon. So now if there is a Linux-based OS and there is one Docker client which can be accessed from the terminal and a Docker host which runs the Docker daemon, we build our Docker images and run our Docker containers by passing the commands from the CLI client to the Docker image. So this was all about Docker engine and its workflow. Now let's talk about the Docker components which you will be most acquainted to hearing. You have your Dockerfile, which builds into a Docker image, which you run, you get a Docker container, and then you store it in a Docker registry. Let's go ahead and look at all of these components in a little depth, shall we? First of all, you have your Dockerfile, which is nothing but a text document which contains all of your commands that you as a developer call on the command line to assemble an image. So basically, to create an image, you'll have to write a Dockerfile and then build it. So Dockerfile basically has your set of instructions which creates the Docker image. Next, you have the Docker image, which can be compared to a template used to create a Docker container. So Docker images are basically the building blocks of a Docker container. These Docker images are created using the build command, and these are read-only templates. You can then store them, as I had mentioned before, in your Docker Hub or your local registry. Next, after building your Docker image, what you get is a Docker container, and these are read-only templates. You can then go ahead and store them in Docker Hub or your local registry, as I had mentioned before. Docker lets you create and share software through Docker images, and you also don't have to worry about whether your computer can run a software in a Docker image because a Docker container is always there to run it. So in case of Docker images, you can use a ready-made Docker image from the Docker Hub or create a new image as per your own requirements to run in a container. With that, let's move on to the next component, which is a Docker container. So the Docker containers are the ready applications created from Docker images. It's the running instance of a Docker image, and this Docker container holds the entire package needed to run this Docker application. So a Docker container happens to be the ultimate utility of Docker, and hence this is the part of Docker which is most popular and most widely used. So if you talk about the applications, every application is run inside a container. So it is an isolated application platform that contains all you need to run an application built from one or more images. So finally, let's move on to Docker registry, which is a storage component for the Docker images. Now this is where the Docker images are stored, which could either be a user's local repository or a public repository like the Docker Hub, which allows multiple users to collaborate building an application even with multiple teams within the same organization who exchange or share containers by uploading them to the Docker Hub. It helps you control where your images are being stored and integrates your image storage with your in-house development workflow as well. Now, Docker Hub, as I've mentioned before, is Docker's very own cloud repository, which is similar to GitHub, which is kind of like GitHub but for Docker images. Hope you guys are with me so far. With this, we have seen the architecture and components of Docker. So now we are going to talk about two other components of Docker, Docker Compose and Docker Swarm. So first of all, let's start with Docker Compose. Now, Docker Compose is a tool for defining and running multi-container Docker applications, which basically means you can run different or multiple containers as a single service. The containers are still isolated, but they can interact with each other using a YAML file, which is used to configure your application's services. And then with a single command, Docker Compose up, you can create and start all the services from your configuration. A great example of this would be a microservice such as a shopping app. So for example, you can take any online retail store's app. It could be Amazon, it could be Flipkart, it could be Azure. And the idea behind an app like this is that it's a microservice app, which basically means it has multiple services in one big application. So all of these services individually are easier to build and maintain, and when one service is failing, the entire app is not down. So a retail app like Amazon or Myntra or Flipkart or any app of your choice, it'll have multiple services, like it'll have a login account, it'll have your product catalog service, it'll have a shopping cart service and a checkout service, and this is just the bare minimum. And each of these services could be scaled up or down in their own container, tested and built and fixed in their own isolated containers without interfering with any other service in that entire application. So using something like Docker Compose, you can connect all of these isolated containers as a single service. All right? And the next thing I want to talk about is Docker Swarm. Now, Docker Swarm is a service which allows you to create and manage a group of either physical or virtual machines or nodes and schedule containers. Each of the nodes is a daemon which interacts with others using the Docker API. Docker Swarm is basically a technique to create and maintain a cluster of different Docker engines. Services deployed in any node can be accessed on other nodes in the same cluster. It allows for high availability of services, auto-load balancing, decentralization of access, easy upscaling and downscaling of deployments, and rolling updates. So basically how it works is that your manager nodes know the status of all the working nodes in a cluster. Your worker nodes then accept tasks sent from the manager node. There is an agent assigned to every single node to give its task updates to the manager. And finally, the workers communicate with the manager using an API over the HTTP protocol. And that is how a Docker Swarm works. Basically, Docker Swarm is an orchestration management tool that runs on Docker applications. It helps you end users in creating and deploying a cluster of Docker nodes. Each node of a Docker Swarm is a Docker daemon, and all the Docker daemons interact using the Docker API. And each container within the swarm can be deployed and accessed by other nodes of the same cluster. So if you consider an environment having Docker containers, if one of the container fails, we can use the swarm to correct that failure. Docker Swarm can reschedule containers on node failures, and the swarm node also has a backup folder which we can use to restore the data onto a new swarm. So with that, we have come to an end to the workflow and architecture of Docker. So now I'm sure all of you might be eager for actually doing something on Docker. So let's go ahead and install Docker. So here are the steps to install Docker on Ubuntu, on your Linux systems, on your Ubuntu systems. You will be using the command sudo apt install docker.io on your Ubuntu systems to install Docker on your system. So let's go ahead and start up with the installation. Today I am using the Ubuntu distribution running on my Oracle VM VirtualBox. So we're going to start out by updating. So sudo apt update. And this might take a little bit time, so kindly be patient. This is a good practice before making any installations, any setups on your machine. All right. As you can see, all my packages are upgraded, and now we can go ahead and install Docker. So to install Docker, we are going to use the command sudo apt install docker.io and then click on Y. And this is also something which takes up quite a considerable amount of time, depending on the speed of your machine, as well as the speed of your internet, so on and so forth. Now understand this is just one way of doing this, and this is the method I am most comfortable with, and that's why this is the method I will be demonstrating here. There are 2-3 other methods through which you can download Docker on your machine. And not just in Linux, you can also install Docker Desktop on Windows, just in case you do not want to use a virtual machine. And you can also use a cloud platform such as an EC2 instance to run all of these Docker commands that I shall be showing you later in this session. So now we are going to start and enable Docker using sudo systemctl. Okay, with that we have started and enabled our Docker machines. And now we are going to go ahead and check out our Docker version that's running. And as you can see, this is the Docker version and this is the Docker build that we are running. All right, so moving on, we are going to get to our hands-on section. In this section, we will learn how to create a Django project setup using Docker and deploy it on our local host. For that, remember, you need to have a GitHub account and Docker installed on your machine, just the way I showed you right now. We're going to build a backend REST API with Python and Django. We're going to create a new GitHub project that we are going to use to store the source code for our recipe app API. Now, this is a wonderful way to show the versatility of Docker. Now, I found this project while browsing through GitHub, and I came to a conclusion that this was a wonderful way to show how eclectic, how versatile is Docker as a tool. So the first step would include initializing a new project on GitHub and coming back to your Linux machine and navigating to where you wish to store your API. There, we are going to create our Dockerfile using an editor. You can obviously use the VI editor or Nano editor if you please. There, using the editor in our working directory, we are going to be creating our Dockerfile, our requirements file, and our Docker Compose file, which is our YAML file. And then we are going to run our app on the terminal. So this is a basic breakdown of how we are going to create our Django project setup using Docker. So let's go on straight to our demo machine and put all of this into action. So we are going to navigate to GitHub and we are going to create a new public project or repository on GitHub. So let's create a new repository and let's call it Docker Demo API app. And in the description, we're just going to write demo app setup. We're going to keep this public and we're going to initialize this with a README file. All right, so let's go ahead and create our repository. So as you can see, this is a blank repository, Docker Demo API app, just the README file there. So here on our repository page, I'm going to click on this green button, code button, and copy the URL from here, from your clone or download option. We're going to copy this to our clipboard so that we can clone this particular repository using our terminal. I'm going to move on to the terminal and I'm going to load my terminal and navigate to the directory where I want to store my app. So maybe I'll just save it here. I'm just going to clone this repository to my local machine. All right, and that's done. Now you can go ahead and change your directory to the repository. So now I'm going to use the command ls to see if my repository has been cloned. Yes, it has been cloned. You can see the Docker demo API app is cloned right here on my local machine. So I'm going to change my directory to this repository I just created by typing the command cd docker demo API app. Now what I'm going to do is I'm going to open up this project in the editor. Like I had mentioned, you can use any other editor. You can use the VI editor, the Nano editor, any editor that you're comfortable with. So now I'm going to clear all of this. And I'm going to use the Nano editor to create the Dockerfile first. So just Nano and Dockerfile. There's no spaces between Docker and file. And I am going to put in this code over here. All right. So this is my Dockerfile. So the first line of the Dockerfile is the image that you're going to inherit your Dockerfile from. With Docker, you can basically build images on top of other images. The benefit of this is that you can find an image that has pretty much everything that you need for your project. So you can just add customized bits that you need just for your specifications. So we are going to create our Dockerfile from Python 3.7 Alpine image. Now you can find this if you head over to the Docker Hub. You can find a list of available images that you can use to base your project off of. If you search for Python, it'll take you to a list of items where you can choose this one. So we're going to use the 3.7 Alpine image. So what it is that it's basically a lightweight version of Docker. And that's what Alpine means. And it runs Python 3.7. And the next line is optional. It's usually a maintainer line, but it's useful just to know who is maintaining the project. So I'm going to leave that one out, but you can go ahead and put in your maintainer line. You can put your name or your company's name, whatever name you basically use to keep track to show that who is maintaining this Docker image. Next, we are going to set the Python unbuffered environment variable the way you set unbuffered environment variable. Now, the way you set an environment variable in a Docker build file is that you type env and then the environment variable that you want to set. We're going to set one called Python, and it's got to be in all capitals, unbuffered, and then we're going to set it to 1. So what this does is that it tells Python to run in the unbuffered mode, which is the recommended mode when running Python within Docker containers. The reason for this is that it doesn't allow Python to buffer the outputs. It just prints them directly and then avoids some complications and things like that. So when you're running your Python application, we are going to install our dependencies. We are going to store our dependencies in a requirements.txt list or file, which we are going to create in a moment. So that what we need to do here is we need to copy our requirements.txt file. And what this does is it says copy from the directory adjacent to the Dockerfile copy. So we're going to copy the requirements.txt file. Further, we're going to copy it on the Docker image, which is what this /requirement.txt file means. Next, we're going to run pip install our /requirements.txt. So what this does is that it takes the requirements that we have just copied and installs it using pip into your Docker image. Next, we're going to make a directory within our Docker image that we can use to store our application source code. So you have your run mkdir /app all in lowercase. And below that, we are going to type workdir/app. And below that, we are going to type copy./app /app. What this does is it creates an empty folder in our Docker image called /app at this location. And then it switches to that as the default directory. So any application we've run using our Docker container will run starting from this particular location, unless we specify otherwise, of course. Next, what it does is that it copies from our local machine the app folder to the app folder that we have just created on our image. This allows us to take the code that we created in our project here and copy it to our Docker image. So here we have run add user -D and user. And finally, we are going to switch to that user by typing user. Now this might be a little confusing because I've added the username user for our user, but what this command means is that it says add user which creates a user. User -D says create a user that is going to be used for running applications only. So not for basically having a home directory that someone will log in. It's going to be used simply to run our processes from our particular project. Finally, this user switches Docker to the user that we've just created. The reason we do this is for security purposes. If you don't do this, then the image will run our application using the root account, which is not recommended, because that means if someone compromises our application, they can have the root access to the whole image and they can go ahead and do other malicious things. Whereas if you create a separate user just for the application, then that kind of limits the scope that the attacker would have within our Docker container. All right, so we can go ahead and we can save this file and move ahead to creating our requirements file. So this is what your requirements.txt file will look like. It's just 2 lines. In the first line here, we are installing Django. We are using version 2.2.4, which is the latest stable version that I could find. And that's the version that we are going to use for the project. And then type Django > 2.2.4. So basically what it says is that install Django that is equal to or higher than this particular version. And we do this to take the minor version, which is the last number, and make sure that we install the latest available version, because typically it's the version that has the security features and security fixes and things like that. But it typically doesn't have breaking changes, so we can be confident that our application, when we rebuild our Docker image, will have the latest security patches, even if it does not have the latest version. Okay, in the next line, we're going to install the Django REST framework. So we're using 3.9.0. And in the same way which we did with Django, we're going to make the install one less than 3.10.0 to get the latest version of 3.9, which is whatever is the latest minor version at the time we build our project. So now we're going to go ahead and save this file as well. Now what we're going to do is we're going to go ahead and create an empty directory called app here for our Dockerfile to call, because when our Dockerfile will run and it's going to ask for an app folder, we're not going to have one, then we're going to face issues. So now if I do an ls here, you see we have a Dockerfile, we have our requirements file, and we have our app folder. Now understand why this is required for our Dockerfile for us to build it now. So now if you try to copy it without the app folder actually existing, it will give you an error. So now we can go ahead and build our Docker image. So we are already at our terminal. If you're not on your terminal, you can load up your terminal. And if you're on Windows, it'll be your command prompt. Let's make sure that you navigate to your project folder, which I am already at. and then I'm going to type docker build dot. Now what that's going to do is that it's going to build whichever Docker file is in the root of our project that we are currently in. The reason we call it Dockerfile in the first place is because it's the standard convention that Docker uses to identify the Docker file within our project. So we're going to wait for it to complete, and it should be fairly quick because we are using an Alpine image. It's a very lightweight, minimal image that runs Python. That's how we create a Docker file for our project. And go ahead and create our Docker Compose configuration for our project. So we're going to use Docker Compose as a tool to allow us run our Docker image easily from our project location. So it allows us to easily manage the different services that make up for our project. So for example, one service might be the Python application that we run. Another service might be a database, for example. So let's go ahead and create the Docker Compose file for our project. So nano docker compose dot YAML or YML. So this is a YAML file that contains the configuration for all services that make up our project. The first line of the Docker Compose configuration file is the version of Docker Compose that we are going to be writing our file for. So version and 3. Next, we define the services that make up our application. Right now, we only need one service for our Python Django application. So services, and in the line below, you're going to type app. This is the name of our service. So we are going to call it out. And then we are going to type build. And then context code on context. So what this says is that we are going to have a service called app, and the build section of the configuration we are going to set the context to dot, which is our current directory that we are running Docker Compose from. Next, we're going to type the port configuration. So we're going to type them in open speech marks. 8080 is our host to port 8080 on our image. So we're going to type that. And then we're going to add a volume. The volume allows us to get the updates that we make to our project into our Docker image in real time. So it basically maps a volume from our local machine here into our Docker container while we'll be running our application. Now this means whenever you change a file or you change something in the project, you will automatically update it in the container. Now the good part is you don't have to restart Docker to get the changes into effect. So then you have a /app /app. So what this does is it maps the app directory, which we have here in our project. And this it maps to the app directory in our Docker image. Then you have the command to run your application in your Docker container. So just make sure that the indentation is one indent from where your command starts, and then you type the command. So we're going to use to run our application be sh-c. This means we are going to run the command using the shell, the Python manage py run server. Then we're going to run the server on our local host at port 8080. So this will run the Django development server available on all IP addresses that run on the Docker container. And it's going to run on port 8080, which is going to be mapped through the POS configuration on our local machine so we can run our application. So again, we're going to move on to our terminal and build the Docker Compose file. And what this does is it will build our image using the Docker Compose configuration, and this should not take too much time. So if we're going to build our Docker file, so now we're going to add sudo Docker Compose build. And as you can see, it's successfully built. Clear it out. So now we're going to use Docker Compose to create the project files for our application. And for that, you can either log in as super user or just type sudo. So Django admin.py, we're going to start project. Now, after running the command, you will realize that if you go into your empty app folder, which was the folder that you created initially, and list out, it's not empty anymore. It has another app folder in it, which contains all of our app setup. I will show you. There you go. You have these files, 1, 2, 3, 4, 5 Python files, which is basically your Django app's entire setup, and all of this Docker created and set it up for you. So a teensy little detail, let's just open up our settings.py file, and we're going to go down to allowed hosts, and just in case it's empty between the close brackets, you can go ahead and add your local host or put in the asterisk, which allows all hosts. All right, so I'm just going to do that, and then I'm going to go back. And now all we have to do is deploy the application through your terminal. So we're going to go sudo docker compose up. So now, as you can see, your Django application is up and running. And all of this was possible because of Docker.
With the ever-changing requirements of modern software development, it is known that Kubernetes is one such system that will fulfill these needs. If you are someone who wants to get started with Kubernetes, you're definitely in the right place. Let us start off by understanding what it really is with the help of a simple example. Imagine you're building a web application. So within this web application, the structure might be monolithic. It might comprise several modules, components, or even layers. But externally, it is a single web application, or you could also say it is a single service. Despite having different modules, the application is built and deployed as one service for all platforms, that is desktop, personal computer, mobile, etc., within a single container that is a virtual machine. Let us assume the web application grows over time and becomes large. It is now extremely challenging to make changes over the code accurately. Also, the size of the application can slow down the startup time. Moving on, what if you want to add new updates to this web application? You must redeploy the entire application as one, and during this process, in case you stop and try to restart the service, the customers on your website will not be able to access anything for that period of time, which could eventually lead to a potential loss of money. Also, bugs in any one of the components can bring down the entire process. And since all the components of the application are identical, bugs can definitely impact the availability of the application. Now, what if you have a sudden spike in traffic and have to serve 20 times the number of your usual customers? In such a situation, you have to very quickly deploy new servers, which takes a lot of effort. Later, when traffic dies down to a normal level, you now have 20 times the number of your usual servers. It can also be challenging to scale when different modules have conflicting updates or resource requirements. So instead of creating a monolithic application, we can define each component as a separate, loosely coupled service. And then we could virtualize each of these services using a Docker container. Not only can the application start easily, but the services can also be deployed independently. With Docker containers, we can easily scale any number of instances up and down according to the application's requirements. But this is definitely easy to manage when we're dealing with just 3 or 4 containers. Now, let's say we had to deal with 1,000 such containers. How do we really keep track of the containers that are healthy and the ones that are not? Orchestrating and managing these containers at the same time can be an extremely tedious task. And this led to the need for container orchestration tools. So this is where Kubernetes comes into the picture. Kubernetes was originally designed by Google and is now maintained by the Cloud Native Computing Foundation. With Kubernetes, you package your website files as containers or pods, which you can run on any instance in your Kubernetes cluster. As you can see, pods are running on nodes, which are physical systems having hardware components that are a part of the Kubernetes cluster. This implies that every service that you create runs on separate containers, and this will allow you to work and manage services independently. Pods can be running on any available node in the cluster, which has enough resources for a pod to work. In simple words, Kubernetes is an open source system for automating deployment, rolling updates, scaling services, and managing containerized applications. Kubernetes works with Amazon EC2, Rackspace, GCP, IBM Cloud, etc. Also, hypergrowth companies like GitHub, Weaveworks, CloudBoost, Walmart are becoming acclimated to building, shipping, and managing containers via Kubernetes. On average, anyone with Kubernetes knowledge can expect to earn between 5 to 6 lakhs per annum in India, whereas they can expect an average salary of $140,000 per annum in USA. As the Fortune 500 are using Kubernetes, the demand for expertise in this field is rapidly increasing, which in turn requires IT professionals who can work on this tool. So what are you waiting for? Begin your journey with Edureka's interactive Kubernetes certification training that is curated to help you learn how to set up your own Kubernetes cluster, configure networking between pods, and secure the cluster against unauthorized access.
Need for Kubernetes. What is Kubernetes? But before I start with Kubernetes, I want to talk about two things. Like Kubernetes is a container orchestrator. It's a container orchestrator. So I need to talk about two things here. What exactly a container is and what exactly a orchestrator is. I just want to talk about these two things first. First, let me start explaining these two things to you. Then we'll talk about Kubernetes. Okay, Kubernetes is a container orchestrator. Now, let's suppose I want to deploy an application. Now, it can be any application. It can be a web application. It can be a database application. Okay, I want to deploy some application. So how do we deploy that application? How do we do it? To do that, what do? We first create up a server. We require a server. Yes. Okay, this is my server. A physical virtual does not matter. We require a server, a computing machine. We require a machine. Okay. Now on this machine, I simply go and install the operating system, OS. Yes. And on top of that, we go and install our application. Yes, this is what we do. The very basic example is on the screen only. For example, this Notepad++. This is an application. It's a text editor. Okay. Now to run this application, what I have did, first of all, I had a laptop with me. I purchased a Dell laptop. I require a machine. Okay. And on top of that Dell machine, Dell laptop, I've installed Windows operating system. Okay. Now, once the operating system is installed, I have deployed the application Notepad++. Not only Notepad, but I've deployed multiple applications like Chrome, Edge, Zoom, okay, Putty, WinSCP. This is empty Putty. This is WinSCP. Okay, so I've deployed multiple applications. But yes, to run those applications, we require a complete OS. We require the operating system. Okay. Now, running an application on top of an operating system is actually it consumes high amount of cost. It's very costly to run the application directly on top of an operating system. Now, the question is why it is costly. Okay, let's talk about that. For example, okay, you have the machine over here. Okay, you have this machine over here. This is your OS. Let's suppose you want to deploy an application. Now, first of all, to deploy this application, now let's suppose you are deploying a database. Okay, now we'll talk about the server side. Okay, this is just my desktop applications. Desktop applications, multiple applications
can work on a single desktop, it's fine. But when you talk about the production world, when you talk about servers, when you talk about the real applications, the production applications, for them, you need to give a dedicated server. Okay. Like on this dedicated server, you will be installing a OS. And on top of this OS, you will be installing any database like MySQL or Oracle, whatever database you want. Whatever database you want, that you will be installing on top of this. Yes. Apart from Oracle, no other application will be running. Like let's suppose you want to run a HTTPD or you want to run an Apache. For that, you will be running another server. Okay. You will be creating one more server and you will install Apache on this. Okay. This is a web server and this is a database server. We do this in production. Okay. Now, the challenges with this architecture is, that for running one application, you require one complete machine with a OS installed. Okay. So running this machines for single applications is very costly. It is taking good amount of price from your customer. Okay. It is going to take some good amount of money basically. Why? Because you have to create one machine for one application. Apart from that, this operating system, you have to run a full copy of the operating system. Okay. So there must be a dedicated team that is managing all these operating systems. A sysadmin team is there. Yes. So you have to again pay the money to them. Okay. There's again a cost involved to manage a sysadmin team. Okay. Apart from that, okay, first of all, to run this application, it is necessary to install the OS first, and installing OS is a time-consuming process. Running an OS is a heavyweight process. This OS itself will take some amount of resources. Like for example, to this machine, you have given around 10 CPUs and you have given around 32 GB of RAM. But out of this 10 CPUs, 2 CPU, and out of 32 GB, maybe around 8 GB is taken itself by the operating system. So the resources that you're giving for your application, in that some is consumed by the OS itself. And these resources are nothing but again money. So running an application on a single server is costly. First of all, you need to maintain a full copy of the OS. Okay. And apart from that, this OS, you need to also have a sysadmin team, because sysadmin team will be patching the operating system. Okay. They will be maintaining any bug fixes on the operating, or they will be basically scanning the vulnerabilities on the operating system. All the OS related tasks will be done by the admin team, not by the application team. Application team is only managing this. Okay. But for the client to run Oracle on a single machine or to run MySQL, it is costly because he has to maintain a complete machine. So now the question is, can we not put multiple applications on a single OS over here? Like on this, on my desktop, okay, you can see that I'm running multiple applications here on a single operating system. This is Windows 11. I have Windows 11. On Windows 11, I'm running multiple applications. Can we not run multiple applications on a single server? Okay, and all the applications isolated from each other. All of them are isolated. Okay, so can we not do that? Answer is yes, we can do it. Okay, first of all, to do that, okay, we first need to have a machine. On that machine, we have an operating system installed. OS is installed. Now, let's suppose you are running one application. Okay, it's fine. Application number one. You are running another application. I can run two applications, but there can be conflict among these two applications as well, as they are directly running on this OS. Now, it can be any conflict. Like for example, I want to deploy Apache, okay, and I also want to deploy HTTPD on the same server, Apache, or let's suppose I want to deploy NGINX, which is a front-end application. I want to deploy similar kind of applications on OS. Now, let's suppose when I'm running Apache, this application is running fine and is running on port number 80. Now I'm trying to deploy NGINX. Now NGINX also requires port 80. NGINX also requires port 80. My problem is that I want to run multiple applications on single server to reduce my cost. Okay, that is what my thing is. I want to run multiple applications on single server. But the problem that it arises that there can be conflicts, there can be network conflicts, there can be some file, like for example, there is a single file and that file is accessed by both the applications simultaneously. Again, there's a conflict. Okay, so there can be conflict at any point, network conflict, file conflict, process conflict. There can be conflicts. So I want a solution where I want to run these applications on the same server to reduce cost. Apart from that, these applications should not conflict each other. There should not be any conflict between them. Okay, like here, Nginx and Apache both are using port 80. So I cannot run two applications which are utilizing same port number. It's a network conflict. Okay, so to overcome this problem, to give me a solution that I want to run multiple applications on single server in their isolated environment, for doing that, we require some kind of isolations. And that isolation is given by your container runtime tools, container runtime engines. Okay, CRE basically. Okay, there are a lot many container runtime engines basically. Okay, you have like Docker, you have Cryo, okay, you have LXC, you have your Podman, okay, you have Container D. There are a lot many container runtime environments. Now, what they exactly do? Okay, so basically on this machine, okay, where you had your operating system installed, on top of that, first of all, you will install Docker, any container runtime basically. You can, Docker is one of the more very popular container runtime engines. So that's why I'm naming it Docker over here. But yes, you can use any of them. It's not only necessarily Docker. Okay. Now let's suppose you have installed Docker. Okay. And what this Docker is going to do, Docker will help you in creating some isolated environment. Okay. On this server, onto this particular server, you can create some isolated environments. Now, this isolated environment will have its own IP address. Okay, it will have its own name. Okay, it will have its own set of processes. It will have its own set of files or mounts. Basically, it will have everything different. Same for this. Same for this. Okay, and now in this isolated environment, you can run your application and you can run your another application over here. Like I can run Apache over here. Apache utilizes port 80. I can run Nginx over here, which utilizes again port 80. But they both are isolated. Why? Because they have their different IPs. Like this will have IP1, this has IP2. The IPs are different. Ports can be same. The distinguish is done at the IP layer, the networking layer. TCP layer can be same. Ports can be same if IPs are different. Okay, so this Docker or these container runtime tools allow us to create these isolated environments. And these isolated environments are nothing but your containers. These are your containers. Okay, and these tools allow us to create these. And why do we put our application? Why do we need to put our application in the container? To reduce cost. Okay, because on a single OS, now you can run multiple applications. I can run multiple containers, and in each container, I can have a different application. Like here, I can run MySQL, here I can run a Kafka, or here I can run a Hadoop, or whatever you want to run, you can run it. Yes. So on a single piece of hardware, on a single machine, I'm running multiple applications in their own isolated environment. And that isolated environment is nothing but a container. So this is what a container is all about. Okay. Now, my life is good. Like I'm able to run multiple applications on a single server. Okay. Like I have this OS installed. I have a container runtime engine. Okay. And on top of that, I've deployed multiple containers where I'm running some applications. I'm running some applications over here. Okay, that's fine. That's good enough. But this architecture also has a drawback. It also has a serious drawback. And the drawback with the container or with this architecture is, what if this machine fails? What will happen if this machine fails? If the operating system goes corrupt, then what is going to happen over here? That is what the problem is. Okay, if the OS goes corrupt, if the OS goes offline, or the machine goes offline, what will happen to these application containers? They are running on the Docker on this machine. They are running on this machine. Okay, so in that case, these containers will also fail. If the machine fails, it's a single point of failure. It's a SPOF, single point of failure. If the machine fails, container fails. Now, there is no high availability. There is no fault tolerance for your application containers, for your apps. There's no high availability. There's no fault tolerance. Okay, like if the container has failed, it should be recreated, but there's nothing because the complete machine has failed. So how we can overcome this? That is now the question. How to overcome this problem? Okay, containers has made my life easier. Okay, but container has reduced the cost. But the thing is, containers are not giving me a scalable, fault tolerant, highly available architecture for my application. Okay, so in this case, we require a orchestrator, a container orchestrator we require, okay, to give us all these features. Okay, so what does an orchestrator basically do? If I talk about the orchestrator over, there are a lot many orchestrators available in the market. Container orchestrator I'm talking about. Okay, so there are a few container orchestrators. I can name them for you. I think the first one we all know is Kubernetes, Docker Swarm, Apache, Mesosphere. These are some of the well-known container orchestrators available in the market. Out of which Kubernetes, out of these three, Kubernetes is the most popular container orchestrator. It has become the de facto standard for running any containerized application, Kubernetes. Okay. Why we'll talk about that, but first let's see how does the orchestrator solves the problem. So orchestrator, if I define what a container orchestrator is basically the technology that groups multiple machines to create a cluster of containers. Okay, basically it's a container clustering technology. How does it work? Let's talk about that over here. For example, let's suppose I have this machine number. Let me make a bigger picture. Okay, just 1 minute. So let's suppose I have this machine which has the OS installed on this, and I have a container runtime engine running over here. I have one more machine over here which is having the OS installed, container runtime engine. These are all standalone machines as of now. These all are your standalone machines. Okay, you have one more machine over here. Now it can be 1, 2, 3, as many machines as you want, you can have those. Okay, so I'm just starting with a basic 3 node. Okay, so now you have 3 machines, machine number 1, machine number 2, machine number 3. Now on these 3 machines, you want to create a orchestrator. You want to create a cluster, Kubernetes cluster, or you want to create a Docker Swarm cluster or Apache Mesosphere cluster. So what does these orchestrator will do? What does the orchestrator is going to do? Orchestrators are simply any orchestrator. Like for example, you talk about this Kubernetes. So what Kubernetes is going to do, or what Docker Swarm is going to do? The orchestrator, when you deploy orchestrator, it will create up a cluster network. It is going to create a network, a container network, okay, between all the machines. It's basically a private network, private container network. Okay, and what this network is used for? This network is basically used for providing the IPs to the containers that are running on different machines. Like you have container number 1 running here, container number 2 running over there, container number 3 running over here. Okay, these are different containers that you are running. Okay, now the thing here is that these containers are running on different machine. Container 1 on machine 1, container 2 on machine 2, container 3 on machine 3. All the containers are on different machine, but these containers will take the IP from this common network, which is created by the orchestrator. Any orchestrator do the same thing. You talk about Docker Swarm, you talk about Kubernetes, you talk about Apache Mesosphere. All the orchestrator do the same stuff, same thing. Okay, all the orchestrator has the same thing to do. They will first create a network between the machines so that containers can take the IP. Now, this container 1 and container 2 can easily talk to each other, although they are sitting on different machines. Earlier, this was not possible. Like you create a container on machine number 1 and you have a container on machine 2. The two containers sitting on two different machines cannot talk until and unless you are using an orchestrator. So here, if you're using an orchestrator, the orchestrator has created this network between those nodes, and all the containers sitting on the nodes can now interact. This is the primary responsibility of the orchestrator. It makes your solution scalable. Now you can run the containers on any node. Okay. Apart from that, let's suppose you think that this container number 1 is a very critical application. It's a very critical application. Okay. And you want multiple copies of this. You can scale the number of containers. High availability orchestrator can give you. For example, I can create one more copy of C1. And this C1 is running on node 2. I can create one more copy of C1 over here running on node 3. High availability. High availability is there. Let's suppose if this machine fails, if the machine number 1 fails, okay, then container number 1 will also fail. Yes, container is going to fail if the machine fails. In that case, do I need to panic? No, I don't need to panic. Why? Because this was a critical application. I know that. So already I have created 2 more copies of the same application running onto 2 different machines. So if this container is offline, I can access the application from these containers. It's possible. That is what orchestrator give you. High availability. High availability. That's another feature that orchestrator gives you. Scalability, high availability. And the third one is fault tolerance. For example, this container number 2, this machine fails. This machine fails. Container number 2 is offline. Container 1 is also offline over here. But let's talk about this. Container 2 is offline. So orchestrator is a smart guy. He knows what to do with the failed container. He will simply go and recreate the container on some other node automatically. That is the job of the orchestrator, to provide you fault tolerance. This is also called as a self-healing nature of Kubernetes, or self-healing nature provided by orchestrator. Kubernetes is a type of container orchestrator. Container orchestrator is a generic term. Like cloud is a generic term. AWS, GCP, Azure are type of clouds. OpenStack, all these are different types of clouds that are available in the market. Container orchestrator is a generic term. Kubernetes is a type of container orchestrator. Docker, Swarm, Apache, Mesosphere, these are type of container orchestrator. But yes, the main responsibility of the orchestrator is to give you a network for your containers, and that network will be spanning across multiple nodes. It gives you high availability. Apart from high availability, it gives you fault tolerance, FT. Okay, so these are the important features of an orchestrator. Okay, so guys, now we will be talking about a bit about Kubernetes. Okay, because we all are here for Kubernetes. We have talked about orchestrator. Why do we require orchestrator? Because orchestrator provides us scalability, high availability, fault tolerance for our container applications. Now we are going to talk a bit about Kubernetes, and after that we'll see a small demo around this. Let's talk a brief history about Kubernetes over here. Okay, so Kubernetes the short form for Kubernetes is K8s. Okay. Why we call it as K8s? Because you see the spelling over here. It starts with the letter K, end with the letter S, and between the first and the last letter, you have total 8 letters, 8 characters. You can see that. UBERNETE. So the first letter is K, total number, last is S. Between first and last, you have 8 characters. So the short form is K8s. Full form is Kubernetes. Okay. Now, on this Kubernetes was actually developed by Google in the year 2009. Okay. And from the year 2009 to 2013, this was used by Google as an internal project. Means nobody was knowing about this Kubernetes. Okay. Then something happened in the year 2013, and Google basically donated this Kubernetes project to CNCF. CNCF stands for your Cloud Native Computing Foundation. That is what your CNCF stands for. It's basically a community of lot many developers sitting across the globe and who are contributing to multiple projects which are owned by CNCF, which are managed by CNCF. Okay, Kubernetes is one of the project managed by CNCF, and as I told, they donated it to CNCF. CNCF is a open source organization. They mainly handle all the open source projects. So in the year 2018, Kubernetes became open source. Open source means the code is freely available on GitHub. You can go and check the source code of the technology. Okay, it's freely available, no licensing required, no vendor. You don't need to connect with any vendor. Like Linux is an operating system which is open source. Okay, you don't need to purchase any license for running Linux. Okay, you don't need to go to any vendor, but normally we go to vendors like Red Hat, Ubuntu, we run their operating system. But yes, it is open source. You can also deploy it by your own. You can do that. Okay, that's also perfectly, that's also very much feasible. So it became open source. Okay, and as it became open source, it started gaining the popularity. Okay, Kubernetes started gaining popularity from the year starting onwards, 2013 or somewhere around 2014. Okay, why? The first thing was it was open source. Okay, so anything which is open source, for which you don't have to pay anything, definitely get much popularity. And it was the first orchestrator in the market. It was the first orchestrator in the market. And we know that whichever technology is the first in the market is always have a highest market share, has a good market share, whichever is the first in the market. Okay, so like for example, AWS started in the year 2006, Azure in 2010. Okay, so we know AWS still has the highest market share. Why? The AWS was started quite before Azure or GCP. So it gained popularity because it was open source. It was the first orchestrator. Apart from that, the number of features that Kubernetes provides are way more than other orchestrators. This is another reason. Like if you compare AWS and Azure, the number of services that you will be getting in Azure and is around 60, 70, 80 services somewhere. Whereas in AWS, you will be getting more than 150 plus services. Okay, that is another beauty, that the number of services that your Kubernetes provides are more than what the other orchestrators are providing. Okay, that is another reason of gaining its popularity. Okay, so because of these reasons, Kubernetes became the de facto standard for running your container applications. Now, if anyone says that I'm running an application, I'm running a containerized application, okay, it means they are running the application on Kubernetes. Kubernetes has become the de facto platform, a de facto standard for running your containerized applications because of its popularity, because of its ease to use, because of the features that it provides, and it's open source. You don't need to pay to anyone. Okay, so that is the reason of the popularity of Kubernetes. Okay, so now we'll see a small demo on how do we work with Kubernetes, how do we create these containers into Kubernetes, how do we run our application into Kubernetes. Let's see a small demo as well on that. So just one thing to start off with, like in Kubernetes, Kubernetes actually manages pods, and in the pods, we create containers. We are creating containers in the pods. Okay, so that is what we do. Kubernetes never manages the container directly. Okay, there is another layer over the container that is called as a pod. Kubernetes will simply be managing the pod, and in the pod we run the containers. Okay, so let's see that. Let's see how we run it up. Okay, and how do we access our application? Let's see all these things. Okay, so to show you a small demo here, okay, I have created up a small cluster. You can see that. Let me close this. I'm using my GCP account. Okay, and you can see that I have created a Kubernetes cluster, and it's just for this particular webinar. I've just created this cluster. So I created this cluster at the start of the webinar. So you can see that this cluster is running hello cluster, and it will be having just one node. Right now I've just kept one node, but normally in production we keep multiple nodes. We keep 3, 4, 5 nodes depending on how many applications you want to run. For example, you just want to run 50, 60 applications. You're good with 5 nodes. Okay, but let's suppose you want to run thousands of applications. You need to have 20 or 30 nodes. Okay, but right now I just have one machine as a part of my cluster. It's fine. I can have a single node cluster as well. Okay, and you can see that this machine is over here. I can show you that on my compute engine. You can see the machine. Yes, this is the machine. You can see this one single machine is a part of my cluster. Okay, now let's go and start checking how we interact with the cluster. So to interact with the cluster, I will activate my Cloud Shell over there. I will activate the command line. So let me open up the command line over here. Just a minute, it is still opening up. And let me also make a full screen, open a new window. So this will open up it in the new window. Okay, so let this get opened up over here. It's provisioning my Cloud Shell machine. It is connecting to the instance. Okay, now it is connected. Okay, now let's see if I can connect with the Kubernetes. So command or the command line to interact with Kubernetes is kubectl. Kubectl get me how many nodes I have in the Kubernetes cluster, and this will tell me how many nodes I have. I need to authorize this command, and this says that you just have one node. You can see this, there's just one node ready, and it is running from last 40 minutes. I told you just at the start of the webinar, I created this cluster, and after the end of the webinar, I will go and delete the cluster as well. Okay, so I will not be keeping this cluster running because again, I have to pay the cost for this. So at the end of the webinar, I will go and terminate this. Okay. So I just have one node cluster running from last 40 minutes, and the version of Kubernetes that I'm running is 1.24.8. This is the version that I'm running, 1.24.8. Okay. Now let's see if I have anything over there. Kubectl. Kubectl is the command line utility. You also called as kubectl. Kubectl or kubectl, one and the same thing. So kubectl get me if I have any pod in the cluster. No resources found, nothing. Okay, it's all empty. Let's go and create. Let's go and create some pod. So kubectl run. Okay, my first pod or my first application. Okay, my first app. Okay, this is the name that you can give by your own. You can give any name: test app, web app, database app, whatever you want to give, you can give. Okay. After that, you have to give the container that you want to run in the pod. This is the name of the pod, basically. This is the name of the pod. Okay. Now, in this pod, you want to run a container. Okay. So, what container, what application you want to run? You need to just pass the image of that application. You just need to pass it. Okay. So, I'm giving the image as Let's suppose I want to run nginx. I believe we all know what nginx is, or let's suppose I want to run httpd, a simple web application. Nginx is also a web application. It's a front end. It can also act as a proxy server, load balancer. But yes, let's go with the very known service, HTTPD. Okay, it's again a web service. Okay, so I want to run a HTTPD container inside this pod. Let's hit enter, and it says pod created. kubectl get me the pod, and it says the pod is there, but in the pod the status is container creating. This is the name of the pod, and inside the pod the container is getting created. You can see 0 by 1. 0 by 1 simply means that total number of container is 1, total is 1, and out of 1, 0 is running. Okay. No container is running in the pod. This is the pod. This is your pod, my first step. Let's see the output again. I think it will be created. It will be running now. Let's see it again. kubectl get the pod and see it is running. It is running 1 by 1. 1 by 1 means this pod has one container, and out of which one is running. A pod can have multiple containers as well. Okay, you can see that it is running. Now let's go and see more detailed output. Let's see the more detailed output. So kubectl describe. I want to describe this pod. Name of the pod is my first app. Describe it. And this is going to describe the pod for you. See the events. See these events. Okay. These events will basically tell you a lot much thing. It says successfully assigned, okay, the default this pod to this node. This is the worker node that I have. I can show you the nodes as well. kubectl get me how many nodes I have, how many machines I have. See, this is the machine. On this machine, the pod is running. So in Kubernetes, you have a group of machines, and on those machines, you run the pod. You run the pod. Okay. So the pod that I created, my first app, is running on this node 52K1. Okay. As I have a single node, so it will be running on that machine only. After that, it says pulling image, successfully pulled image in 5.1 second, and then created container. And after that, it says started container. Okay. See the events. Let's see. Let's call it up. Okay. See, this is the pod name. This is the IP of the pod. And in this pod, you are running container. This is the container image HTTPD. And I'm not using a Docker container. I'm using container D. I told you there are multiple container runtime, container D. This is used by Google Kubernetes Engine, GKE. I'm using GKE, Google Kubernetes Engine. And Kubernetes has created the container, and that container is container D. It's not a Docker container. Kubernetes has the beauty, as it is open source, it can orchestrate any container tool. It can orchestrate your Docker, container D, okay, container D or cryo, whatever you have, it can orchestrate any of them. So different tools work with different containers. Like GKE uses container D. Now let's suppose if you talk about OpenShift, Red Hat OpenShift, if you have heard this name, it's also Kubernetes, Red Hat OpenShift. So Red Hat OpenShift is Kubernetes. It's an orchestrator. It's Kubernetes only. But Red Hat OpenShift uses these container, cryo containers. It don't use Docker, it don't use Podman, it don't use container, it use cryo. Okay. So different flavors of Kubernetes works differently. Okay. That's completely fine. Okay. Now I was talking about this output. See, the type of container that I'm running is container D. And the image is HTTPD. This is the image. Now, let's go and try to expose the application. Let's try to access our application. So to access our application, I need to expose this. I need to expose this pod. Let's expose this. So kubectl expose my pod, my first app, And the type of service, basically there's a type of a service I need to use here. I need to use a node port service, minus port of the application is 80. The port of the service is 80. And the port where my application is running is also 80. And the name I'm giving as my first SVC, first service, first SVC. So I'm exposing my pod. I want to access my application. I'm exposing it up. Okay. So let's hit enter. Okay. So it says it is exposed. Let's see that kubectl get me the service. Okay. Give me the services. See the service, first SVC running from last 7 seconds. Now I want to access this. I want to access this service. How will I use it? Okay. So for that, I need to have the IP of this node. Let me close this. Okay. I need to have the IP of this node copied, followed by the port number. Port number is 32671. So what I'm going to do is put this here and 32671. That's it. And see, my application is working. You guys can also access this. You guys can also try to access this. I can put the URL on the chat box for everyone. Just click on it, and the application that I have created in the pod, see this kubectl get me the pod. This is a HTTPD application. Okay. And this application, this pod is exposed by a service, and it's a node port service. So as it is a node port service, I can simply use the node IP followed by the port number. This is auto assigned port number. So I've used the node IP. Node IP is, I can see the node IP. Node IP is 34.102.110.91. That is what I'm using. Colon the port number 32671. I pasted the URL on the chat. If you just click on it, you will be able to open the web page, and it should tell you it works. It should be written here, it works. It means I'm able to access the application. I can use another, I can use another service as well. Like right now I'm using a node port service. I can use cluster IP, but cluster IP I cannot access from outside. Cluster IP service is used for internal access. Okay, that is where cluster IP is used. And if you want to get a load balancer will have an external IP. Like here, the load balancer will, there are different types of services in Kubernetes. Okay, one is a node port. Node port means that you're using the node IP followed by this port number that is auto assigned. Cluster IP only for internal access, no external access. I cannot access this service from outside. I cannot do that. And there's one more, load balancer. Load balancer is same like node port, but there will be another load balancer created. Okay, that will be load balancing between multiple nodes. And when you hit the load balancer IP, you're actually hitting this service. I can show you load balancer as well. For example, I go and create another service. I go and create one more pod. kubectl run my second pod minus image is equal to nginx. I'm running one more pod, and the application is nginx now. Let's expose this. kubectl expose the pod, my second pod. Okay, and minus type of service as load balancer. Okay, load balancer, B capital only, A small. Okay, it's, you have to be precise with the syntax, uppercase, lowercase. Okay, minus port as 80, minus target minus port as 80 for the application, and minus name as I give second SVC. Okay, so target port I have given, so it is created. Now you can see kubectl get pod first. Second pod is running. Yeah, running from last 47 seconds. Let's see if the service is running. kubectl get me the service. See, second service is running. It's load balancer. Now with load balancer, you are also getting same, but you will also get this IP. With node port and load balancer services are exactly same. The only difference is that node port will not get any external IP. Load balancer will get a external IP as well. Let's see it again. Okay. Let's see it. It is still pending. This will take a bit of time, but this will come up. Okay. Why load balancer will get an external IP? Because on the back end, when you're using load balancer service on GCP, a load balancer is also created. Let me show you that. Okay. So if you go here, network services or VPC, where it is, the network services load balancing, you can see that on the back end, when you created a load balancer service, a load balancer is also created. See this over there. A load balancer is also created over here. See this. And this is the IP of load balancer 34.102.39.189. Same you can see here. kubectl get SVC 34.102.39.189. Node port, load balancer are exactly same. The only difference is node port will never get an external IP. Load balancer will get an external IP as well. Now I can access my application using this IP. That's it. Copy and paste. That's it. See, my application is running. It says welcome to NGINX. Okay, you can see that it says, and it is working exactly what I want. Okay, it is exposing my application. So this is how basically you run your applications into Kubernetes and you expose them using services. And if you're using load balancer in the backend, a load balancer is also created. Okay, and you're getting charged for this load balancer. I'm getting charged for this load balancer. Okay, so normally using load balancers, again, a costly affair on the cloud side. So it's good to go with node port services. But let's suppose if your node don't have any external connectivity, then you can go with the load balancer.
What is Ansible? Well, Ansible is a simple open source IT engine which automates the application deployment, intra-service orchestration, cloud provisioning, and many other IT tools. Not only this, but Ansible also is very easy to deploy because it does not use any agents or custom security infrastructures. So Ansible uses playbook to describe automation jobs, and playbooks use very simple language, that is the YAML. So what do you think this YAML is? Well, YAML is a human readable data serialization language and is commonly used for configuration files, but it can be also used for many applications where data is also stored. So this means it is very easy for the humans to understand, read, and write, isn't it? So the advantage of YAML file is that even the IT infrastructure support guys can read and understand the playbook and debug if needed. So it's basically a really simple language and makes it really easy for the humans to read, write, and understand. Now moving on with the session, as Ansible is designed for the multi-tier deployments, Ansible does not manage one system at a time. It models the IT infrastructure by describing all of your systems which are interrelated. So Ansible is completely agentless, which means that Ansible works by connecting your nodes through SSH by default. But if you want any other method for connection like Kerberos, Ansible also gives you that option. So after connecting your nodes, Ansible pushes some small programs called as the Ansible modules, and Ansible runs that modules on your nodes and removes them when they are finished. So it also manages your inventory in simple text files. Those are basically the host files that you can see on the screen, where Ansible uses the host files where one can group the hosts and control the actions on a specified group in the playbooks, right? Next, as I was telling you about Ansible, and Ansible is the tool for configuration management, you should also understand configuration management before you understand how to deploy it with the tools. So talking about configuration management in terms of Ansible means that it maintains the configuration of a product performance by keeping a record and updating detailed information which describes an enterprise hardware and software. So such information typically includes the exact versions and updates that have been applied to install software packages and the locations and also the network addresses of the hardware devices. So for example, if you want to install the new version of the WebLogic server on all the machines present in your enterprise, it is not feasible for you to manually go and update each and every machine, right? So you can install the WebLogic server in one go on all your machines with the Ansible playbooks and inventory written in most simple way. So all you have to do is that you have to list out the IP addresses of your nodes in the inventory and write a playbook to install the WebLogic server. After that, you have to run the playbook from your control machine and then it will be installed on all your nodes. So guys, now that you've seen what configuration management is, let me show you how does Ansible work. So basically, Ansible works by connecting your nodes and pushing out small programs called as Ansible modules to them. So Ansible then executes these modules over SSH by default and then removes them when finished. So your library of modules can reside on any one machine and there are no servers, daemons or databases required. So the management node that you can see on the screen is basically the controlling node which controls the entire execution of the playbook. It's the node from which you're running the installation, and the inventory file provides the list of the host where the Ansible module needs to be run, and the management node does a SSH connection and then it executes these small modules on the host machine and installs the product. So the beauty of Ansible is that it removes the modules once those are installed so that it effectively connects to the host machine and then it executes those instructions, and if it's successfully installed, then it removes the code which was already copied on the host machine and that was which was executed. So guys, that's how Ansible works. Now, if you talk about the features of Ansible, let's take a look at them one by one. So the first is that it is agentless. By agentless, I mean that there's no kind of software or any kind of agent managing your node, unlike Puppet or Chef, where you need to install a Puppet agent or a Chef client on all your node machines. But for Ansible, what you just have to do is you just have to install Ansible in your control machine and then you're good to go. After that, it is built on top of Python, and this helps to provide a lot of functionalities of Python, right? Now coming to SSH, Ansible uses SSH for secure connections. Now SSH is a very simple passwordless network authentication protocol which is very secure. So our responsibility is to just generate a public key in your control machine and copy the same key onto your node machines. So coming to the final feature, the Ansible is also a push-based architecture for sending configurations. So in the case of Ansible, where you want to make any kind of configuration changes on your nodes, all you have to do is you just have to write down those configurations and then you just have to push them all at once in your nodes. So if you talk in simple terms, what it does is that it gives you full control on whenever you want to make changes on your nodes and also makes it very easy and fast to set up and needs very minimal requirements. So guys, the features of Ansible are it's agentless, it's built on top of Python, it uses SSH and also uses the push-based architecture. Now, as in the features section, I was talking about that Ansible is a push-based architecture. What do you think is the difference between the push-based architecture and the pull-based architecture? Well, tools like Puppet and Chef are basically pull-based configuration management tools, whereas Ansible is push-based configuration management tool. Now, in the case of Puppet and Chef, their agents present the agent software that Puppet has and is basically called the Puppet agent, and in case of Chef, it is known as the Chef client. So what this agent actually does is that it keeps on pulling the central server periodically for any kind of configuration information, and whatever it finds, it pulls those changes and then gets them affected on your node machines. Whereas in the case of Ansible, since there are no agents present, whenever you want to make any changes, you can make those changes directly and you can push those configurations directly whenever you want to, as you've got full control over it. Not only this, but also in a push-based configuration management system. So as you can see on the screen, there's a version control system which manages all the changes in the code base, and then we have a server. So basically this server will have Ansible or any other configuration management tool system installed there, and then we'll have a bunch of nodes. So these bunch of nodes are basically the collection of web servers and application servers and also the database servers, and all these are connected to the main server via SSH. Now, what happens here is that these main servers constantly pull the version control system for any changes in the code base. By this, I mean that it constantly keeps on checking the status of version control system at regular intervals of time. And whenever there are any kind of changes, those specifications are sent to the main server, and then the server decides on how to take those configuration changes according to the changes in the code base. Now, in the situation where you want to write all these new configurations, you can directly push them all at once onto your node machines. So you've got full control here, and whenever you want to make any changes, you can make the required changes. Now, coming to the pull-based configuration, the relation between the version control system and the central server is the same. It basically constantly pulls for the changes to the version control system for any changes in the code base, and whenever there are changes, it pulls those changes. But the main difference between both the architectures is that from a push-based configuration management tool, it has got an agent present, and then this agent or the client is a software that manages all the nodes. So what this agent does is that it constantly pulls the central server for any configuration changes. By this, I mean that it keeps on checking the central server for any changes in the configuration that needs to be made, and whenever it finds any kind of configuration changes, it pulls those changes and then only it gets affected onto the node machines. So at this point, you have to wait for an agent to pull those changes, and only then the configuration changes will get affected onto your nodes. So the basic point is you have to be a little bit dependent on the agent here and the improvement tools, right? So as I was chanting from the beginning of the session that Ansible is really simple, it's very easy to learn because it gives us the simplicity of push-based system. But there's a disadvantage with the system. That's because you cannot achieve full automation with the push-based system because it's not usually possible to boot a server and have it configure without some sort of client or server protocol, and also it gives you a lack of scalability, as well as when you're dealing with hundreds of servers, a push-based system will start showing its limits unless you make use of threading or multiprocessing. Alright guys, so those were the differences between the push-based configuration and the pull-based configuration. So Ansible is basically a push-based configuration management tool. Now moving on with the session, as I've talked so much about Ansible, you would be interested to install it. So how do you think that you can install Ansible? So before I start telling you the steps to install Ansible, let me tell you that there are basically two types of machine when we talk about deployment. Those are the control machine and the remote machines. So the control machines are the machines from where we can manage other machines, and the remote machines are those machines which are handled or controlled by the control machine. So there can be multiple remote machines which are handled by a single control machine. So for managing remote machines, we have to install the Ansible on the control machine. So now let me tell you the steps to install Ansible. So for that, you just have to type in the command sudo apt-get update. So this command will basically update your repositories. Now once that is done, you have to install the common software properties. So for that, you'll type in the command sudo apt-get install software-properties-common. So you can see that on the screen that your installation is going on. Now once that is done, you'll type in the command sudo apt-add-repository space ppa:/ansible. So this will basically include your Ansible's repository. So you can see a description about Ansible. Now if you want to continue, you just have to press on enter. So once you press on enter, you can see that it is getting continued. Now once this is done, you again have to update your repositories. So for that, type in the command sudo apt-get update. Now once you're done updating your repositories, you have to install Ansible. So for that, you'll type in the command sudo apt-get install Ansible. So this will basically install the Ansible tool. So you can see that your Ansible has been installed. So guys, that's how you can install Ansible. Now let's move on with the session. So now let me just give you a summary of the commands that you need when you install Ansible. You just have to update your repositories. Once you're done with that, you have to install the common software properties. Once that is also done, you'll add a new repository on the name of Ansible, and then you'll update your own repositories, and then finally you'll install Ansible. So these are the commands that you have to use. Now moving on with the session, what do you think this host inventory is? Well, inventory defines a group of hosts which are alike in any way. So for example, you would want to group your web servers in one group and application servers in another, right? So a group can have multiple servers or a single server that can be a part of multiple groups. So the name of the group is enclosed in square brackets, and the server names can be their DNS names or IP addresses. So by default, Ansible looks at the inventory file, but that can be modified by passing the inventory part to the Ansible command line. So we can modify the way Ansible connects to our host by supplying the additional information in the inventory file. So as you can see on the screen, this is just a list of IP addresses on my nodes. And also you can name the groups of your different IP addresses. So for example, if I want to group my web servers together and my data servers together, all I have to do is I have to write a group name between the two square brackets and a big group together. So whenever you want to make configuration changes just on the web server and not on the database server, all you have to do is you just have to mention the group name on the host, and then it will automatically configure your web server. So guys, that was about host inventory. Now, if you talk about another key term in Ansible, that is Ansible modules. So modules are those executable plugins that get the real job done. So usually modules can take the key value arguments and run in a customized way depending upon the arguments themselves. So a module can be invoked by command line or can be included in the Ansible playbook. Now, let me tell you some commands related to Ansible modules. Now, if you want to use the modules from command line, you have to type in the command ansible all-m ping. Now, if you want to use the ping module to ping all the hosts defined in the inventory, then you have to type in the command ansible web servers -m command -a ls. So this will basically list all the modules present and then it will ping. Now, if you want to flush IP table rules on all the hosts in the inventory, then you have to type in the command ansible -i inventory all-m command -a IP tables f -become -ask -become -pass. So this will basically tell Ansible to execute the command with sudo privileges. So if you want Ansible to gather facts about the host, then you have to type in the command ansible all-m setup. And also if you want to extract particular facts in the documentation of the setup module, you have to type in the command ansible-doc setup. So guys, these were few commands that you can use with Ansible modules. Now moving on with the session, let me tell you about the YAML files because that is the file that has been used. So Ansible uses YAML syntax for expressing Ansible playbooks. Ansible uses YAML because it's really simple for humans to understand, read and write when compared to the other data formats like XML or JSON. So every YAML file optionally starts with 3 hyphens and ends with 3 dots. So as you can see on the screen here, it starts with 3 hyphens and ends with 3 dots. Now, you can also use abbreviation in YAMLs to represent dictionaries. So as you can see on the screen, it basically follows the pattern of a key value pair. So here the key value is James and it has various values like its name, roll number, division, sex, everything. So the key James has many values like the name James John, the roll number to be 34, the division to be B and the sex to be male. Not only this, but we can also represent the list in YAML file. So every element of the list should be written in a new file with the same indentation starting with a hyphen and a space. So for example, as you can see on the screen, after writing countries, we have written America with a hyphen and a space, and then the next value comes in the next line with a hyphen and a space, that is China, similarly Canada and Iceland. So if you have to represent this list in an abbreviation form, it can be represented in the form of countries, colon, and in a square bracket, you can type in America, China, Canada and Iceland. Right? Now, further talking about YAML files, you can also represent a list of dictionaries. So YAML uses the pipeline to include new lines while showing multiple lines and uses the greater than symbol to suppress new lines while showing multiple lines. So due to this, we can read and edit large lines, and in both the cases, indentations are ignored. So guys, that was about the YAML files. Now talking about Ansible playbooks, let me tell you how to write an Ansible playbook. But before that, let's see what exactly Ansible playbook is. So as I've told you before, that the playbooks are the files where Ansible code is written, and these are written in the YAML format. So YAML stands for yet another markup language, and playbooks are one of the core features of Ansible and tell Ansible what to execute. So they're like the to-do list for Ansible that contains a list of tasks, and playbooks contains the step which the user wants to execute on a particular machine. So playbooks run sequentially, and playbooks are the building blocks for all the use cases of Ansible. So each playbook is an aggregation of one or more plays in it, and playbooks are structured using the plays. So they can be more than a play inside a playbook, and the function of a play is to map a set of instructions defined against a particular host. So since YAML is a strict type of language, we need to take extra care while writing the YAML files. So now let me tell you how can we create a playbook. So as I mentioned before, YAML starts with 3 hyphens and then we have different YAML tags. So now let's go through each and every YAML tag. So the different tags that are included are the name, host, vars and task. So the name tag specifies the name of the Ansible book. So basically I'm talking about as in what this playbook will be doing, or any logical name that can be given to this playbook. Coming to the host tag specifies the list of hosts or the host group against which we want to run the task. The host field or tag is mandatory and it tells Ansible on which host to run the listed task. So the task can run on the same machine or on a remote machine, and one can run the task on multiple machines, and hence the host tags can have a group of host entry as well. Coming to the vars tag The vars tag lets you define the variables which you can use in your playbook, and usage is very similar to the variables in any programming language. Now coming to the final tag, that is the task. All the playbooks should contain tasks or a list of tasks to be executed. So the tasks are the list of actions one needs to perform. So a task field contains the name of the task, and this works as a help text for the user. Well, it's not mandatory but proves useful in debugging the playbook. So each task internally links to a piece of code called module. Now let's move on to the hands-on part where we'll basically, create a playbook, and then I'll show you the working of Ansible. So let's get started with our hands-on part. So first we have to create an SSH connection, right? To create an SSH connection with the node, so for that you have to type in the command ssh-keygen. So this will basically, generate your key. So once you type in the command, you can see an output that it is generating a RSA key pair. Now if you have to mention the directory where you want to store the key, but if you press enter, it will store it as a default location. So let me just press enter. And once you press enter, you can see an output that it has created a directory for SSH. Now you have to enter the passphrase. So for that, let me just press enter again. And again, we have to mention the same passphrase. So for that, let me just mention it again. And you can see that, our key has been generated. All right. Now, once your key has been generated, you have to create a host inventory file. So we're creating a host inventory file so that we mention the specifications of the node IP address that we want to connect with. So for that, you'll type in the command. Sudo, and then you'll mention the directory of your host. So I've just mentioned the directory, and then I'll press on enter. So it will ask for my password. So I'll mention the password. So as you can see on the screen, this is the default host inventory file. Now, as we have to mention the name of our servers, I'll just mention it in the square brackets. Let's say I mention the name to be test servers. So for that, I'll type in test servers, and then I'll mention the name of the node. So let me just type in the name of the node. So over here, my name of the node is knode. So I've mentioned that. Now, once this is done, just save this file and close this file. So for that, you'll press the keyboard shortcut Control X and then press on Y. So this will save your host inventory file. So once you're done with that, you have to mention the SSH generated key in the K node. That is the node that we just configured, right? So for that, you'll type in the command ssh-copy-id space -i space and the name of the node. So over here, my name of the node is K node. Once I'm done with that, I'll press on enter. And you can see that, it will ask for a confirmation. So let's just say yes. So you can see the output that our key has been copied. Once you're done with that, you'll be asked for your password. So let's just type in the node password. And you can see, your key has been successfully added to your node. Now, before I move forward, I've just cleared my terminal. So just in case if you want to know the command is clear. So once you type in clear, the terminal gets cleared. Now moving on with the hands-on. Now, once your key has been generated, you have to, create a playbook. So before I start creating a playbook, let's just check if our test servers are running or not. So for that, you have to type in the command ansible space -m ping and the name of the server. So here I've given test servers. So I'll just type in that command and then I'll press on enter. Now, once this is done, you can see an output that, it is successful. So now let's start creating playbooks. So to start creating playbooks, you have to first create a YAML file. So for that, you have to type in the command sudo nano. Let's say I give the name to be edureka demo.yaml. So this opens up a YAML file. Now let's start mentioning the specifications required. So first I'll mention the host. So as I mentioned before, that YAML file starts with 3 hyphens. So let me just mention 3 hyphens and then I'll press on enter. So let's start by mentioning the YAML tags. So let's start with the host. So for that, I'll type in -host space : I'll mention the name of the server, that is the test servers. Then I'll mention become. And over here, you make sure that, you do not miss out the space. So it has to come in one go. And then let's say I put it true. Then I'll mention variables. So for that, I'll type in the command vars. And then you have to make sure that, you're maintaining the syntax. So I'll type in vars, mention a colon, and then inside which I'll type in ansible -become -pass to edureka. That is basically our password. Then I'll again mention task space : and then inside which I'll mention the name. That is basically the name of the task. So for that, I'll type in -name space : install nginx. And then let's mention the package also. space colon space pkg is equal to nginx space state is equal to installed, and then I'll put in a space, and then after that, so let me just put in spaces, and then I'll mention notify colon, I'll press on enter, I'll go inside that, I'll mention hyphen start nginx. After that, let's press on enter, and now let's mention the handlers. So for that, let's again maintain the spaces, space colon, inside which we'll again mention the name. So for that, we'll mention name space colon start space nginx, and then mention the service. So that is name nginx state is equal to started. So guys, this was my YAML file to create a playbook. So for that, I'll press the keyboard shortcut Control X, and then I'll press on Y. So this will save my file. Now, once you have saved this file, you have to run your playbook. So for that, you'll type in the command ansible -playbook and the name of the YAML file. So over here, it's Edureka demo. So I'll mention Edureka demo.yaml, and then I'll press on enter. So you can see on the screen that the playbook is running. So as you can see, the playbook has run. So basically it mentions name of the server, that is the test servers. It mentions the task. So we wanted to install nginx, so it has mentioned the task. Then it also mentions the running handler node, that is the K node over here. And then it also mentions whether it is unreachable, failed or not. So guys, this is how playbook runs. Now, once the playbook runs, it automatically installs your nginx container. That is basically the task that we mentioned. Now, to check whether it is running on the other node or not, you have to switch to your other node. So let me just switch to my other node. So now to check whether nginx has been installed or not on the other node, let's type in the command ps aux, that is WAUX space pipeline space grep, the name of the file that we installed, that is nginx. Now let's press on enter. So you can see the output that it has been installed. So guys, that's how Ansible basically works. It's really simple to do, right? So you just have to mention on one node and all the actions will happen on all the other nodes connected to it.
What is Prometheus? Prometheus is a free software application used for event monitoring and alerting. Now, what it really does is it records real-time metrics. We'll talk about metrics later on in the session. Now, this metrics that it records is stored in a time series database built using a HTTP pull model. And with this, you also have flexible queries and real-time alerting. Prometheus basically pulls these metrics, which are in a key value format, and stores the data as time series, allowing users to query data and alert in a real-time fashion. At given intervals, Prometheus will hit targets to collect metrics, aggregate data, show data, or even alert if some thresholds are met, in spite of not having the most beautiful graphical user interface. Now that we know that Prometheus is basically an alert monitoring system, now let's move on and understand why we need Prometheus. As I've already mentioned in the introduction, it basically contributes to the DevOps system by monitoring cloud-native applications and infrastructure, and also by watching over hundreds of microservices. Now, it really works well for recording any purely numeric time series data. Now, another really important benefit of Prometheus is that it fits both machine-centric monitoring as well as monitoring of highly dynamic service-oriented architectures. This is a real advantage. Now, in a world full of microservices, its support for multi-dimensional data collection and querying is a particular strength. Now, another advantage of Prometheus is that it is designed for reliability, to be the system you go to during an outage to allow you to quickly diagnose problems. Now, each Prometheus server is standalone, not depending on network storage or other remote services. You can easily rely on it when other parts of your infrastructure are broken, and you do not really need to set up an extensive infrastructure to use it. Now, you must be wondering why Prometheus really, because there are other time series databases that can be used too, right? So one of the noticeable differences between Prometheus monitoring and other time series databases is that it is a pull-based tool, unlike Nagios, Sensui, etc. Now, because it is a pull-based tool, what it really does is it actively scrapes targets in order to retrieve metrics for them. For example, the node exporters or application exporters. So Prometheus expects to retrieve metrics via HTTP calls done to certain endpoints that are defined in Prometheus configuration. Node exporter and application exporters will listen on particular ports, and Prometheus server initiates a HTTP call to this particular exporter and fetch system or application metrics from the end. Now that we know why Prometheus is so important, let's move on and understand continuous monitoring in Prometheus. Monitoring applications and application servers is an important part of today's DevOps culture and process. Now, via continuous monitoring, you obviously want to continuously monitor your applications and servers for application exceptions, server CPU, memory usage, or storage spikes. And you also want to get some type of notification if the CPU or memory usage goes up for a certain period of time, or a service of your application randomly stops responding, so that you can perform appropriate actions against those failures or exceptions. This is why Prometheus is used in continuous monitoring. Now, with monitoring, there are a number of tools out there such as Amazon CloudWatch, Nagios, New Relic, and many others. But Prometheus is a very popular free and open source project for monitoring dozens of servers, as I've already mentioned, even microservices. Now that we know what is Prometheus used for in continuous monitoring, let's move on and check out the Prometheus architecture. So in Prometheus terms, we call the main monitoring service the Prometheus server. You can see that on the screen. And the things that Prometheus monitors are called targets. So the server is the monitoring service, and the targets is what the Prometheus monitors. So I hope that is clear. So in short, the Prometheus server monitors targets. I said earlier, targets can also refer to an array of things. It could be a single server or a target for probing of endpoints over HTTP, HTTPS, DNS, TCP, or it could simply be a HTTP endpoint that an application exposes, through which the Prometheus server gets the application's health status from. So now let me explain a little bit about metric. Each unit of target, such as current CPU status, memory usage, or any other specific unit that you would like to monitor, is called a metric. So Prometheus server collects metrics from targets over HTTP, stores them locally or remotely, and then displays them back in the Prometheus server. Now, the Prometheus server scrapes targets at an interval that you define to collect metrics from specific targets. For example, for a minute or 30 seconds or whatever you want, you can give the target as, and then it will finally store it in a time series database. You can see the storage box that is in between. That is your time series database. Now, you define the targets to be scraped and the time interval for scraping metrics in the prometheus.yml configuration file. You get the metrics details by querying from the Prometheus time series database, where the Prometheus stores metrics, and you use a query language called promql in the Prometheus server to query metrics about the targets. So in other words, you ask the Prometheus server via promql to show us the status of a particular target at one particular time. As you can see in the third white box, it accepts queries, that is, it accepts promql queries. Now, Prometheus provides client libraries in a number of languages that you can use to provide health status of your application. But Prometheus is not really only about application monitoring. You can use something called exporters to monitor third-party systems. Now, exporter is a piece of software that gets existing metrics from a third-party system and eventually export them to metric format that the Prometheus server can eventually understand. Now, a sample metric from a Prometheus server could be the current usage of free memory or file system free via a node exporter in the Prometheus server. We'll learn all of this in the demo part of this session. Now, I hope Prometheus server is clear to you. So the main component here is the Prometheus server, which is divided into three parts: the retrieval part, the storage part, and the HTTP server. So the HTTP server really accepts queries and displays it in the graphical user interface. Also, we'll be learning about Alert Manager later on in this session. So I hope all of these are clear. Let's move on to the next part of this session and learn about Prometheus metrics and its types. So here, each unit of a target, such as the current CPU status, memory usage, or any other specific unit that you would like to monitor, is simply called the metric. So the server collects the metrics and stores them either locally or remotely, and then eventually displays it on the Prometheus graphical user interface. Now, moving on, let us check out the 4 different types of metrics that are available. The first one that we'll be talking about is the counters. A counter is simply a cumulative metric that represents a single monotonically increasing counter whose value can only increase or be reset to 0 on restart. Now, for example, you can use a counter to represent the number of requests served, tasks completed, or errors. You always have to remember this to not use a counter to expose a value that can decrease. Now, for example, do not use a counter for the number of currently running processes. Instead, use a gauge. We'll be talking about gauges in a bit. Now, client library usage documentation for counters are Go, Java, Python, and Ruby. Let's move on and understand the next metric type, that is gauges. I'm sure you must be aware of gauge. Now, a gauge is a metric that represents a single numerical value that can arbitrarily go up and down. Gauges are typically used for measured values like temperatures or current memory usage. If you check out a speedometer in a car, it looks like a gauge, right? That is a gauge. That's exactly what we're talking about here. So the client library usage documentation for gauges are Go, Java, Python, and Ruby. The next metric type is the histogram. Now, a histogram samples observations and counts them in configurable buckets. It also provides a sum of all observed values. A histogram with a base metric name of base name exposes multiple time series during a scrape. Now, when you're operating on buckets, remember that histogram is cumulative. Now, moving on to the next metric, we have summary, which is very similar to histogram. A summary samples observations, while it also provides a total count of observations and a sum of all observed values. It really calculates configurable quantiles over a sliding time window. Now, a summary with a base metric name of base name exposes multiple time series during a scrape. Now, the difference between summary and histogram is that here you do not know what the range of values will be upfront, so you cannot use histograms. Whereas in histogram, you know what the range of values will be upfront, so you can just define it on your own. Now, with this, let's move on to the demo part of this session and install Prometheus on our Linux virtual machine. So I'm just going to check out my Ubuntu machine number. So the first thing what we're going to do is we're going to install Prometheus from the official website. So I'm going to go to my web browser. So I'm just going to type in Prometheus in my web browser and I'm going to click the first link. And as you can see, this is the official website of Prometheus. I'm going to click on the download button. So once I click on the download button, it will redirect me to a page. So as you can see here, there are a lot of products: Prometheus, Alert Manager, Black Box Exporter, and a lot more if you keep scrolling down. Right now, we're going to be downloading Prometheus. So we're just going to stay here and I'm just going to click on the operating system as Linux. And this will just show the tar file for the Linux operating system. I'm just going to right click on that and I'm going to click on copy link location. And I'm going to switch back to my terminal and click on wget. And this will download Prometheus for me in my Linux operating system. Now that it's downloaded, I just want to see the list of files in my tar file. So as you can see, there's the Prometheus Linux tar file, which is present currently in my Prometheus folder. Now what I'm going to do is I'm going to copy this file and then untar it using the command tar -xvf. And then I'm just going to paste this file. This will immediately untar the file for me. Once that is done, now I'm just going to list down the number of files that are currently present in my Prometheus file. Now you can see that there's an file which has been untarred here. Clear my screen. Okay, now I'm again going to just list it so you can see it clearly. Now I'm just going to copy this file and enter this directory. So I'm just going to list down all the files that are present. You can see there's console libraries, there's consoles, license notice. There's a file that's named Prometheus. So this is the application, the Prometheus application. So I've already mentioned before that the Prometheus.yml configuration file really just defines the targets that has to be scraped, right? and also the time interval for scraping metrics. Now let's just check if all of those parameters that I just mentioned are there in the configuration file. So I'm just going to use scat command for it. You can see that there's a scrape interval parameter of 15 seconds. You can set the scrape interval to every 15 seconds. Default is every 1 minute. So I also have an alert manager configuration. Right now, we haven't set that up, but it's just there. You can also load your own rules and evaluate them according to the global evaluation interval. And you can see by default, it is currently active on the 9090 port. Okay. And by default, a scrap configuration containing exactly one endpoint to scrape is given. That is the Prometheus itself, right? As I've already mentioned before, Prometheus is a tool or an application that will scrape out metrics from different applications. But by default, right now, we have the Prometheus itself to be scraped, and that is currently present on the port number 9090. So I hope that is clear. We will learn about the rules in the next part of the session. We'll also learn about the alert manager configuration in the later part of the session. So both of these will be clear later. But I hope the scrap interval and the scrap configs are clear to you. Now let's move on to the next part. Now I'm just going to clear the screen. Now I'm just going to execute Prometheus by using /Prometheus, and this will immediately activate and get my Prometheus application running. If we move back to my web browser and just type in localhost 9090, this will redirect me to my Prometheus application, as you can see. Now, if I come out of my terminal, right, okay, and I reload my page, you can see that it is unable to connect to my Prometheus. So what I'll have to do is I will have to create a Prometheus service and get that running. So let's learn how to do that. I'm just going to clear my screen. So now to be able to run Prometheus as a service, I'm going to use the copy command. I'm just going to use the cp-r command. I'm just going to copy all of these files that are consisting in this folder to the destination folder. And I'm going to use this command -user local -bin Prometheus. Now, for any application to be run as service, you will have to compulsorily have a .service file. So let's go ahead and create one. So to create the service file, I'm just going to use the command sudo vi, and I'm going to enter that particular folder. So as you can see, I just typed out a tiny piece of code. And as you can see here, this is my executable command and this is my configuration file. Let's go ahead and save this. Okay, great. So now that our service file has been created, I'm just going to clear my screen, and now we're just going to start our service file. Now, once that is done, I'm just going to check the status of Prometheus. It is active and running. Great. Now, if I want to stop Prometheus, I'm just going to type in the command sudo service Prometheus stop. Okay. Now that I refresh my page, you can see that Prometheus is up and running. So that's great. I hope it's clear how to create your own service file so you can get Prometheus up and running. I hope it was very clear, and I hope you understood how to install Prometheus into your virtual machine. Now, in the next part of the demo, I'm just going to brief you all about the graphical user interface of Prometheus, so stay tuned. Okay, so now we're going to check out the user interface of Prometheus. So in the previous session, we installed Prometheus and we got the instance running. Now, if I click on Prometheus, this is where it will take me. Now you can see that there are three options that says enable queue history, use local time, enable autocomplete. You can use the local time if you'd like to enter some time to evaluate the queries. So there's a search bar here for you to type in the expression that you'd like to execute. Now the expression or query that you'd like to execute is usually executed in two different forms, that is the table form and the graph form. As of now, since you don't have any expression and query, it says no data queried yet. Now on the top, you can see three options that says enable query history, use local time, enable autocomplete. So this option will allow you to use your local time. Since I'm in India and it's 10:08 right now, so that's my local time. Now, if I want to also enable my query history, that is all the queries that I have executed in the past. So this option will simply enable me to check out the queries that I've executed in the past. So I'm just going to untick that because I don't have any queries that I've executed in the past anyway. Another interesting thing in this page is that you can add several panels, right? So you can execute different queries all at once. This is great. And this option add panel has been added in the recent times. So this is the new user interface. You also have a classic user interface. I'll shift to that. And you can see that here you can enable query history. That's the only option that's common from the new user interface. Also, you have a bar that will allow you to type in your expression or query. You can also insert metric at cursor. Now, since Prometheus is written in Golang, so you have a lot of metrics that are related to that. You also have metrics related to Prometheus. Now, if I want to execute any of these metrics, I can just click that and I can execute it. You can see that the instance localhost of port 9090 is currently up and running and the job is Prometheus. I can view the graph too if I'd like to. Now let's just execute another query. I'm just going to click Go Info, and this will just give me the version of the Golang and the job, etc. So you can just really execute all the queries directly from this option in your classic UI. But as you can see in the new user interface, that option is unavailable. Now let's move on and check out the other options that are available in this panel. Let's click on alerts. Currently, we have no alerts. As I've already mentioned before, that alerts are simply conditions that you will have to specify. And if these conditions are satisfied, so the alert will be triggered to that particular maintainer or manager. So currently, as we have none, it just shows nothing here. So these options will allow me to check my inactive alerts, my pending alerts, my firing alerts. So usually it's an inactive state if the condition is not satisfied. If the condition has been satisfied, then it'll go to the pending stage. And finally, if it exceeds the critical limit or the critical amount, it will enter the firing stage. So you can view the alerts based on these three states, that is the inactive state, pending state, and firing state. Moving on, we have graph. So this is the same as the homepage of Prometheus, right? So we've talked about that. So once I click the status option, you can see that there are 7 different options that drop down. The first one is runtime and build information. This just really gives me, the information about Prometheus. That is the start time of Prometheus, the working directory, the configuration reload. Extra information about my runtime and build is given in this option. Now the alert managers, there are none, so it just says endpoint. Now you can also see the Go version here. You can see the build user, build date, all of that. The version of the build information also is given here. So this is what the runtime and build information is all about. The next option in the status is TSDB status. What is TSDB? TSDB is simply the time series database. So this option allows me to check out my database's status, right? The number of series, the number of chunks. So I can just view the statistics of the head cardinality. So I can just view the top 10 label names with value count. I can view the series count by metric names. And I can also check out the label names with high memory usage. In fact, I can also, take the queries from this top 10 series count by metric names. I can just execute it as a query. And you can see that this gives me the data of and this just executes the information and gives me the data, the list of data that allows me to check out my HTTP request duration in seconds. So also I can view this in graph. So I'm just going to click on that. And this just gives me information of all of the data that is available in the table in terms of graph. So I hope this is clear. Now moving on, we'll check out command line flags. This is just the command line flags that I can use to really make changes in my service file, we created a service file, right, to run this particular service of Prometheus. So this just really gives all the information about my service file. So you can see that there's config file currently in this location. There is also query timeout, and you can view all of that, all of the extra information here. You can check out the web listen address. It's in port number 9090. You can also check out the web page title. Currently, the web page title is Prometheus Time Series Collection and Processing Server. You can change this if you'd like to. You could also check out the web read timeout. So all the information basically about this service that we've created is given in the command line flags. So moving on, we will check out a configuration file. This configuration file we've already seen before, right? This is our prometheus.yml file, right? So this is simply the same file that is given here. You can see global, alerting, scrap configs. You can check out the targets and then finally the port number. Okay, so if you'd like to copy this, you could just copy to clipboard. Moving on to the next option, we have rules. There's none right now, so it shows nothing. Later on in the session, we'll be creating our rules, so stay tuned for that. Now, the next option is targets. There's only one Prometheus service that is up and running, and that is of port number 9090. So the state is up. You can see the instance, you can see the job, and the last scrape, the scrape duration, and if there are any errors, that will appear here. Before we move on to the next option, so I'm just going to show you the metrics of this instance, the Prometheus instance that we're running. I'm just going to click on metrics. Now you can see that Prometheus defines a very nice text-based format for its metrics. I'll just zoom this a bit so you can view it better. So now you can see that the data is relatively, human readable. And we even have the help and type decorators to really increase the readability, right? As I've already discussed before, Prometheus has only 4 types of metrics, right? To keep everything really simple, that is counter, gauge, histogram, summary. Now the type and help attributes here help us provide user-friendly hints for each metric in the output. So that's what this help and type decorators really do. They just increase readability. You can't really view all of these metrics and understand what they are. So they're just helping you with the readability. You can see that the help here says go GC duration seconds, a summary of the pause duration of garbage collection cycles, and the metric type is summary. Here you can see the type is gauge, and you can see all of that information. Here the type is counter. Also here the type is counter, gauge again. So that's what really the type will do. So the type will just give you an insight of what type of metric it is. So help will just really describe the metric, and type will just give you the type of metric. So I hope this is clear. So I hope metrics was easy to understand. Now that we finished targets, let's move on to service discovery. And this just shows you, so currently there's just one endpoint that has been scraped, and that is our current running active instance, that is Prometheus. Now it just shows the address, the metrics path, and the scheme, the job, and just shows some labels of the target. So that's all service discovery is all about. And if you'd like to check out and know more about Prometheus, just click the help option in the panel, and this will redirect you to the Prometheus official website. Now the classic UI we already discussed, and this is all for the graphical user interface of Prometheus. I hope it was easy to understand. I hope it was easy to learn. Now let's move on to the next part of the session. Okay, so now in this part of this session, I'll be downloading the Prometheus node exporter. So for all of y'all who don't know what the node exporter is, it really is a way to measure various machine resources. Now the machine resource can be your memory, disk, or even your CPU utilization. So it's a very famous application of Prometheus. So without much ado, let's go ahead and download our node exporter. I will go to my web browser and I'm going to the official website of Prometheus. So the first link will redirect me to the official website of Prometheus. I'm going to click on the download button and I'm going to scroll down and look for node exporter. So I'm just going to copy the link location. I'm quickly going to move back to my terminal and I'm going to download node exporter. So now that the node exporter has been downloaded, now let's just check if the file is available, and it is. So I'm just going to untar this tarred file with the command tar xzf, and I'm just going to copy this. And this command will just untar my file. Okay, so I'm just going to clear the screen. Now let's just move ahead and check out what are the files that are there in our node exporter file. So we have license, node exporter, and notice. Now what I'm going to do is I'm going to use the sudo cp command. So I'm going to copy the node exporter file to my user local bin location. So with the help of the copy command, that is the cp command, I'm just going to create a copy of the node exporter file into my user local bin location. Okay. Once that is done, I'm just going to check out the files that are present in my user local bin location. You can see that there is a node exporter file that has been copied, right? So I've just copied this file into this location. That's all I've done. Moving on, we'll now create a service file. So we created a service file for a Prometheus application, right? So even for the node exporter, I'm going to create a service file using the command sudo vi. So I'm just going to name this as node exporter.service. So I have written down a piece of script the same way we did to a Prometheus service file. Here you can see the description, which says Prometheus node exporter service. You also have the type, you have execution start, which is currently present in the user local bin location. Now, once that is done, I'm just going to save this and I'm going to reload my system. Now I'm just going to start the service. You'll have to make sure of one thing, and that is the node exporter. So what you're naming the service file, you'll have to initiate the same name. So as you can see here, the service file is named as node exporter. So I'm just going to type the same thing here and I will start the service. Once I start the service, I'm just going to check its status and you can see that it's active and running. So that's great. So the node exporter is currently running on address 9100 ports. So we're just going to check it out. And it opens. So you can check out the metrics that are currently running in our node exporters. So this is the endpoint as to where our Prometheus will scrape all of its data. So now that we have node exporter up and running, let us configure the node exporter into our prometheus.yml file. So every time you'll have to configure a particular target, you will have to go to the prometheus.yml file and add the target there. Okay. So what I'm going to do is I'm going to move to my directory. Okay, once that is done, I'm just going to list out all the files. So you have the Prometheus file here. Here you can see the prometheus.yml file, right? I'm just going to clear my screen. So now I'm just going to view all the files that are present in Prometheus. As you can see that there's the YML file here. So we're going to use the command sudo vi prometheus.yml to edit our configuration file. So now you can see there is only currently one job, and that is Prometheus. We have to add another job to our file. So here I'm adding node exporter as my job name, and the target is with IP address 9100, right? So make sure the indentation is correct. So once the indentation is correct, we have applied a target. We have added a target to our configuration file, and we can just save this. Once that is done, I'm just going to clear my screen. So now I'm going to restart my Prometheus and check the status. It's active and it's running, so we can just go back to our page. So you can see here the node exporter has been added to our service discovery with address as localhost 9100. It's localhost because we are currently working on our machine. If you want to add another machine's port address, you can do that too in Prometheus by mentioning their address. And now you can just go back and you can check out the configuration file has its changes. So it has another target that's named node exporter, and also its port number is 9100. So if I move back to my classic UI2, I can check out the metrics that are here. If you notice, there are a lot more metrics than before, right? You also have the node metrics. If I want to check out the node CPU seconds in total, I can execute it, right? So now that I've executed it, you can check out the CPU's total number of seconds it is hosting the node exporter for. You can also check out the username info of the node. You can see that the instance name is given here, the machine that we're currently working on, the node name is Edureka, the system name is Linux, the version is given here, and also, so the entire node's username info is given if we execute this query. So this is great, right? Like, now your node exporter has been successfully configured into Prometheus. Let's move on to the next part of the session. Before moving on to the next part of the session and configuring Alert Manager, let's understand querying a little bit more in detail. So Prometheus, as we all know, fundamentally stores all of its data's time series, right? Now, each time series is identified by a metric name. We've also discussed this before, and as well as a set of key value pairs that Prometheus calls labels. Okay. Now, the metric name indicates the overall aspect of a system that has been measured. Let me just execute this query, Prometheus HTTP request, duration seconds total. Okay. Now you can see that labels serve to differentiate subdimensions of a metric, such as, the handler, the code, the instance, the job that it's currently running on. Finally, a sequence of samples forms the actual data for a series. Okay. Each sample consists of a timestamp and a value, where timestamps have millisecond precision, and here values are always 64-bit floating point values. The best part of Prometheus queries is that you can add regular expressions, you can specify a time limit, a certain time limit. You can also use different functions. We'll see all of this. So now I could add a certain filter to my query. Now, if I want to just execute the queries with label code 400, I'm just going to add that filter here and execute the query. And this will automatically display the HTTP requests in total with code 400. And you can really, add whatever you'd like to in your filters. So that is one way to work with queries. And also, as I've already mentioned, you can also add regular expressions, right? So you can use not equal to, is equal to, and many other things. So for example, if you want to list all the series, no matter which metric name or job, where the handler name starts with API, okay? So you can just simply run this query. What we've done in this regular expression is, so this is obviously a regular expression, right? So in this regular expression, it needs to end with a full stop and a star. Okay, since regular expressions always match a full string in Prometheus. Now, the resulting time series is usually a mix of series with different metric names. Now you know that how to select your time series by the metric names as well as a combination of their label names. So in the next part, we will learn how to calculate rates or deltas of a metric over time. Now, one of the most prominent frequent functions you will use in Prometheus is the rate function. Now, instead of calculating event rates directly in the instrumented service in Prometheus, it is a very common thing or a common way to track events using raw counters. Okay. And to let Prometheus server calculate rates ad hoc during query time. This has a number of advantages, such as not losing rate spikes between scrapes, as well as being able to choose dynamic averaging windows at query time. Counters start at 0 when a monitored service starts and get continuously incremented over the service process's lifetime. Occasionally, when a monitored process restarts, its counters reset to 0 and begin climbing again from there. Graphicking raw counters is usually not very useful, as you will only see an over increasing line with occasional resets. Now we will just use another query for this example. Now I'll just explain you how the rate function really works. And for this, I'm just going to use the query Prometheus HTTP request duration seconds count. Okay. And I'm just going to specify the job as Prometheus. And you can also view the graphs. It looks something like this. Okay, now to make counters useful, we can use the rate function to calculate their per second rate of increase. This is really why we use rate function. We need to tell rate function over which time window to average the rate by providing a range selector after the series matcher. Okay. Now, for example, to compute the per second increase of the above counter metric as averaged over the last 5 minutes, we can just add the rate function and just specify the time limit as 5 minutes. I'm just going to close the braces and execute the function. Okay. You can check out the graph now. You can see now the result is much more useful, right? Rate function is very smart and automatically adjusts for counter resets by assuming that any decrease in a counter value is a reset. The variant of rate function is irate function. While rate function averages the rate over all samples in the given time window, that is 5 minutes in this case, irate function only ever looks back 2 samples into the past. Okay, it still requires you to specify a time window like 5 minutes to know how far to maximally look back in time for those 2 samples. Now, irate function will really react faster to rate changes and is thus usually recommended for use in graphs. In contrast, the rate function will provide smoother rates and is recommended for use in alerting expressions. Okay, now let's execute the irate function for this. You can see that the graph would look like this, okay, uncovering short intermittent dips in the request rates. Rate and irate functions always calculate a per second rate. So here sometimes you'll want to know the total amount by which a counter increased over a window of time, but still correct for counter resets. You can achieve this with the increase function, okay? For example, to calculate the total number of requests handled in the last hour, you can use the increase function. And I will change this to 1 hour. Now that we know how queries work, how you can use regular expressions, and how you can really use functions in your queries, let's move on to the next part of this session, that is custom roles. Okay, so time series queries can quickly become quite complicated to remember and type using the expression browser all the time, right? So what you can do is, sometimes in some situations you'd want to use some queries very frequently, right? But you don't want to really type the same query over and over again. So in this case, rather than remembering and typing this particular query every time, we can create a recording rule that will run at a chosen interval and make the data available as a time series. So how are we going to do it? So this is a pretty popular query that I'm going to execute. That is node memory 3 bytes. Okay. I'm just going to execute this query. This will just give me how much of free bytes is available in the node exporter. You can see the free number of bytes here. But what if I want to execute this in terms of, percentage? So here you can see the number of memory that the job node exporter is using, and it's just 4. So I'm just multiplying by 100 to check in percentage form. So you can see that it is only using 4 bytes of memory. Now, if I want to see how much of memory is remaining, I'm just going to minus the entire query with 100. So you can see that 95% of bytes is left over. Now, what if I want to execute this query very often, right? So it'd be very time consuming for me to type the whole thing out and then execute it, right? So, but there's an easier way to make this a query, right? So it'll just drop down in your drop down list, and then you can just search for it and execute it, right? So how do we do that? So what we're going to do is we're quickly going to shift back to our terminal. I'm just going to clear my screen. Okay. And I'm just going to move into the user local bin Prometheus directory. And now here we have to create a new file called Prometheus rule. So that's what I'm going to do. And since it's a YML file, I'm just going to add the YML extension. Here, I'm just going to add the name as custom rules. And I'm just going to specify my rule here. So I just type the whole thing out. I have named this custom rules and I've recorded this query as node memory free in %, and the expression we've already executed is the same one. I'm just going to go ahead and save this. I'm just going to clear the screen. So Prometheus usually comes with a tool called Prom tool, and this Prom tool can be used to really check your rules files, and you can do really a lot of things with Prom tool. For now, we're just going to use this command which I typed out, and we're going to execute this command to check if our file is running okay. And you can see that it checks the Prometheus rules file and it says it's success. Now let's go ahead and add the Prometheus rules.yml reference to the Prometheus YML rule file section. I'm just going to clear the screen. Now I'm just going to enter the prometheus.yml file. So here I'm just going to enter the prometheus_rules.yml file. So now I'm just going to save this file. Now once that is done, I'm just going to restart the system. And I'm just going to check the status too. Okay, great, it's up and running. So we're just going to switch back to Prometheus. And I remember naming it Free Bytes. I'm just going to switch to the classic UI so I can look for it. And it was named node memory free in %, right? This is exactly what we named our query. And I'm just going to execute this. And you can see that it's 95%. So this is how easy it is to make your own queries and execute them. Okay, so now that we've created our, custom rule, so let's just go check out our custom rule. And you can see that it's here. And the state says, okay, so that's great. Now let's go ahead and create our first alert rule. Okay, the same way that we created our custom rule, we're going to be creating our alert rules. This is exactly why I explained you custom rules in the beginning. So I'm just going to switch back to my terminal. I'm going to clear the file. I'm just going to go to the prometheus_rules.yml file. And once that is done, so I'm just going to type in my alert in this prometheus_rules.yml file. And once I'm done typing, so I'll just explain you the alert after that. So I've created a rule named alert rules, and this alert will allow you to recognize when your instance is down. So we have currently the Prometheus instance that is running, and we also have the node exporter that's running. So if any of these instances go down for up to 1 minute, and then the alert will be up. Okay, so the severity is pretty critical, and we have given annotations too where we have mentioned the instance. So this just gives a summary of what instance is going down and a description too of the job type. And also we have mentioned the job type and that it has been down for more than 1 minute. Okay, so once this is done, we're just going to save this. I'm going to clear my screen. So the same way that we executed the prom tool command, we're just going to execute that. So we're just going to execute this command. And it says 2 rules found. That's great. Now I'm just going to restart my Prometheus and I'm going to check the status. Okay, it's up and running. Let's switch back to our Prometheus and reload it. Now you can see that there is now an alert rule, okay, which has the alert instance down and the expression is up is equal to 0. So this expression that says up is equal to 0 is pretty interesting because now if I go to my Prometheus and just execute up, it'll just tell me what are the jobs that are currently up and running. Now the value is currently 0. So if the expression turns 0, So then the alert will be activated. So here, this is what the expression really means. So here, if the up is equal to 0 for more than a minute, then the alert will be immediately activated. As I've already mentioned before, the three states, that is the inactive stage, pending stage, and then the firing stage. If none of the alerts are up, then it's just going to be an inactive state. And if, for instance, one of the jobs go down, okay, then it will immediately move to the pending state. So once it immediately moves to the pending stage, then it will wait for a minute, because we have specified the condition that it should be in the pending state for a minute. And if it goes beyond a minute, then it should go to the firing stage. Okay. So once it reaches the firing stage, all of the managers that are involved in getting the notification about this alert, then they will be informed about it immediately. So I really hope you understood how to create your own rules, how to configure them into your Prometheus rules.yml file, and then just really, understand how they really work. Now let's move on and install and configure our alert manager. We'll have to just simply go to the Prometheus official website, click on download, and then you'll get an option called alert manager. I'm just going to click on that. And then I'm just going to copy the link location of Linux, because I've been clearly using Linux machines. So I'm just going to copy that link location, clear my screen, and so I'm just going to download Alert Manager. So once I copy the link location, what I'm going to do first is I'm just going to move back directories. So now I'm just back to my root. I'm just going to move into my Prometheus directory. So I'm just going to download my Alert Manager here. Okay, as you can see that the download is complete. I'm just going to list out the files. And you can see that there's an alert manager, the tar alert manager file. I'm just going to untar this using the command. And you can see that using the command sudo tar -xvf, and then I'm just going to paste the link. And you can see that the files have been untarred. I'm going to clear my screen and I'm just going to list out the files. Yeah, so the alert manager file has been untarred. I'm just going to enter into this directory and check out the files that are currently in this. You can see that there's an alert manager executable file. You have alert manager.yml, the configuration file. You have an AMP tool. So now what we're going to do is we're going to be running alert manager as a service. The same way we ran Prometheus and Node Exporter as a service, we're going to also run alert manager as a service. So what I'm going to do first is I'm just going to copy my files into the user local bin. So now I'm just going to create the alert manager service file. If you remember, we also created a Prometheus service file and also Node Exporter service file. So we're just going to do the same. We're going to create an alert manager service file. So once you create your alert manager service file, this is what you'll have to type out. I've typed out the script. So you have a description, you also have the type of the service, and you're just going to mention the location of the configuration file and where the execution will begin from. Okay, once this is done, I'm just going to save this file. I'm going to clear the screen. So I'm just going to shift locations to the user local bin alert manager directory. So I'm just going to list out the files, and you can see there's the alert manager.yml file. So here is where we'll have to make a few changes. That is the alert manager configuration file. So I'm just going to make some changes there. So this is the default file. I'm just going to make some changes here, and I'm just going to explain what the changes are about. You can see that you have receivers where you have to configure your email ID, that is your email ID from where you're sending the message, and the receiver who's going to receive the message, right? So you're just going to add a to email ID, you're going to add a from email ID, and you're also going to add a username, you're going to add identity, that is the email ID, And then you're also going to add the Gmail password. Now that all of my email IDs are in Gmail, so I'm just going to mention the public Gmail host server. So I'm just going to add in all my credentials and cut to the next part of the session. And as we have already seen before, there's a tool that is called AMP tool in the Alert Manager. So the AMP tool is just an executable that allows you to view or to modify the current state of the Alert Manager. So I'm going to execute this command user local bin alert manager AMP tool and check the configuration file and then just give the location of my service file. Okay, and once that is done, it's going to check. So I'll just check if it's successfully configured. Once that is done, you can just see that there's one receiver on this end. Okay, I'm just going to clear my screen. And I'm going to start my alert manager. So once I've made changes to my service file, so now I'm just going to execute my command user local bin alert manager AMP tool. Now for all of y'all who don't know what AMP tool is an executable that allows you to view or to modify the current state of the alert manager. Okay, so once this is done, this is successful. So you can just check the config file with the help of AMP tool. And once that is successful, you can just see that there's one receiver. So what I'm going to do is I'm just going to clear my screen and I'm going to start my alert manager service. Now that the alert manager is up and running, you can see that it's currently running on port number 9093. So I'm just going to check out the port where the alert manager is up and running. As you can see that there is 4 different options that are given: alerts, silences, status, help. And you can just filter your alerts, group your alerts, and you can also see the status of your alerts. And you can also see the active, pending, and expired alerts. You can get help from this page too. So you can just see your alert manager in general. And now now with the alert manager active, let's move on to the demo part. Okay, so now that we have set up our alert manager, so we'll quickly shift back to our terminal and I'll clear my screen. So now we have to configure alert manager into Prometheus. I'm just going to move out from this directory and I'm just going to enter the Prometheus directory. I'm just going to list out the files that are present here. So I'm just going to edit my prometheus.yml file. And here, as you can see, I'm going to specify my alert manager. So I'm just going to specify my alert manager to port number 9093. And once I'm done with that, I'm just going to save this file. And now I'm going to restart Prometheus. Okay, it's up and running. So I'm just going to check if my endpoint has been successfully scraped in my runtime and build information. And if I scroll down, you can see that, so the alert manager has an endpoint, right? And this is it. So that's great. We have Prometheus, we have alert manager up and running. Now let's just go check the status of all our targets. We have node exporter, which is up. We have Prometheus, which is up. Okay, now let's go to our alert stage. We have one alert rule that we've currently written and it's inactive. Now let's get into the demo part and let's just stop one of the instances. I think I'm going to stop my node exporter instance, and once that starts, so let's just see how the alerts go by when one of the instance is shut down. Okay. So I'm just opening a new terminal, and what I'm going to do here is I'm just going to okay, now what I did is I just entered my Prometheus directory. I just listed down the files, and we have the node exporter file. I just changed the directory to the node exporter and listed down the files. And currently the node exporter is up and running, obviously. But now what I'm going to do here is I'm just going to stop this service. Okay, before that, I'll just clear my screen and I'm just going to stop the service. And I'm just going to check the status. So it's inactive. And once that is done, I'm just going to quickly shift to my status of the target. So you can see that one of the target is down. And I'll just execute the up query. And you can see that the node exporter has the value 0. That is, it's down. Okay. I'm just going to check the alerts. You can see that the alerts is in the pending state, right? There's 0 in inactive and there's just 1 pending. So it's just going to be in the pending state for a minute. If you remember, we had specified that for a minute, it's going to wait if the instance is going to be down. So once it crosses the 1 minute threshold, it's going to go to the firing stage. Here, it's going to alert the manager. That is me currently. I will receive the mail saying that one of the instance is down and it's a critical alert that you will have to address immediately. Okay. So that's how it really works. Now let's reload the page. And you can see that after a minute, it's entered the firing state. Okay. And there are none in pending state. So it was in pending state for a minute and then it moved to the firing state. So in the previous session, we learned about how to create our own alerts in Prometheus and how to be notified about these alerts so that we can take discrete actions whenever necessary. So in the next part of the session, I'm just going to integrate Prometheus with one of the most famous visualization tools in DevOps, that is Grafana. So before I explain you about Grafana, I'm just going to briefly explain you about Node Exporter and how we're going to be displaying its metrics in Grafana. So Node Exporter is simply an exporter that collects technical information from Linux nodes, right? Such as CPU, disk, memory statistics. I'm sure you must be aware of this by now. So the metrics that the node exporter exposes of the Linux machine that we're currently working on, that is Ubuntu, all of these metrics are going to be visually represented in Grafana. We know that Prometheus doesn't have like a great UI, right? All of the information is very textual and it's not very like visually appealing. So with the help of Grafana, I just really want to, expose all of these metrics in a graphical representation like gauges or, bar graphs, anything. It could be anything. So before we download Grafana onto our Linux machine, I am quickly going to be making some changes in the YML file. Before that, I'm just going to check if my Prometheus is up and running. It is. And I'm also going to check if my node exporter is up and running. It is. So that's great. I'm just going to clear my screen. Okay, so now that is done. So I'm just going to list down the files that are currently in the Prometheus directory. And I'm just going to shift to my Prometheus file. So I'm just going to move into this directory. I'm going to list the files. Okay, great. So we're just going to make some changes in the prometheus.yml file. I'm just going to... Okay. Now you can see that you have our alert manager configuration, our rule files, scrape configs, a job name. But here in the static config, so I'm just going to add the node exporter as a target too. I'm just going to add the IP address of, currently it's running on localhost 9100. Okay, great. Just going to save this. And I'm going to restart Prometheus. Okay, it's up and running. I'm just going to clear the screen. Okay, great. Just going to go down. So now I'm just going to go back to my Prometheus directory. And now let's go ahead and download Grafana. I will click on my web browser and I'll just go to the official website of Grafana. So this is the official website of Grafana. I'm just going to click on the download button. So on this page, you can just click download. And then if you scroll down, you can see Linux. So these are some of the commands that you can use to download Grafana on your Linux machine. So I've already made a list of all of these. So I'm just going to use them to download Grafana. And okay, now that Grafana has been installed, I'm just going to clear my screen and I'm just going to check if it's up and running. So I'm just going to use this command to start the Grafana server, and then I will check the status of it. And it's up and running. Currently, it's running on port 3000. I'm just going to quickly shift to my web browser and check. As you can see that Grafana is up and running. That's great. If you've newly installed Grafana, the email address and the password by default is admin. Okay, and you can obviously create your own password. So once you're prompted with your credentials admin, then you can just create your own password and submit it. But I'm just going to skip this for now. And this is how the Grafana user interface really looks like. Okay, you can see that there's a search button, there's some icons on the left hand side, and there are also panels that you can play around with. So you can create your dashboard that will allow you to create beautiful visualizations for your data source, right? So once that is done, I'm just going to add my first data source. Just going to click this option in the basic panel. And here, as we are going to be working with Prometheus, we want our data source to be Prometheus. I'm just going to select this and it says data source added. So you can name your data source anything you'd like, but I'm just going to let it be Prometheus for now. And our URL of Prometheus is localhost 90, right? Once that is done, I'm just going to check if everything looks fine. Yes, it does. So for adding a data source, all you have to do is name it and then add a URL. That's how easy it is. I'm just going to save and test this. And this is great. It's working, right? So once I've saved and tested it, so I'm just going to click the Grafana icon that's present on the left corner, left top corner, and this will redirect me to my homepage of Grafana. Okay, now that we are done with this, I'm just going to click the plus icon and click on the option import. So what we're going to do is we are going to import the dashboard from grafana.com. So if I search for Grafana Node Exporter dashboard and click on the first link that's available, it will redirect me to a page which has the name Node Exporter Full, right? So what it really does is it has an ID. The Node Exporter has an ID. So I'm just going to copy this ID to the clipboard and I'm quickly going to import this ID here, okay? And I'm going to load it. Because we're using the Node Exporter dashboard in Grafana, I'm just going to copy that ID and I'm going to go down. If you want to change the name, you can do that. And I'm going to select Prometheus as my data source. And I'm going to import this. Once that is done, you can see a beautiful representation of your CPU, your system load, your RAM used, and the root FS, the swap used. All of the information is beautifully being represented in gauges, right? These are gauges, okay? And these are the graphs currently. You can see that it's just been used here. You can see busy system, busy user, and all of how long it's been idle for. All of the information about the CPU. This is basic CPU information. You have storage disk. You have 8 panels here. You can see that here. So there's several different panels that have already been created by Grafana. And all you have to do is import it and add your data source. That is your Prometheus, right? And this is way better than viewing it on Prometheus because Prometheus has everything in text and in terms of metrics. So it is very boring to view it like that. I'd obviously prefer Grafana to just view all of this.
Now let's talk a little bit about
DevOps and cloud, or DevOps on cloud. Why do we need DevOps on cloud? Now, understand that DevOps and cloud go hand in hand. They can be implemented individually, of course, but DevOps becomes twice as much efficient and beneficial when clubbed with a cloud. It can help an organization deliver new software features much faster in a more effective manner. Many organizations try to fix their application development processes by shifting from waterfall to DevOps. Now, they have this understanding that DevOps alone won't be that effective. So public and private cloud solutions are now evolving together with DevOps. This brings in products at a faster rate to the market through quick access to development environment and streamlined developer processes. Infrastructure as code and automation together reduces the cloud complexity and maintenance of servers and resources, which our ops team previously was very concerned about. The security also highly increases with automated, repeatable processes that serve to eliminate error that can cause further issues. And even more importantly, it builds security controls from the very beginning to the very end of the process. Now, because you don't have any servers and your continuous operations are cloud-based, it also eliminates a lot of downtime. And last but not the least, scalability, which is one of the most important factors for applications as they are developed. When DevOps and cloud are clubbed together, it reduces the cost of infrastructure, and global reach also increases with this. Now that you know why you need a cloud platform, let's go ahead and look at our cloud platform of choice today, which is AWS. So what is AWS? Now, back in the day, handling and storing data was way different than it is now. Companies preferred storing data using private servers, and that was obviously for security reasons. But however, with better usage of the internet, the trend has seen a paradigm shift for industries as they are moving their data to the cloud. Now, this enables companies to focus more on core competencies and stop worrying about storing and computation. For example, back in the day, if a streaming platform or a search engine platform, anything with a high volume database suffered a corruption, it would take days before their operations resumed. They would face problems scaling up, and only then would they realize the need for a highly reliable, horizontally scalable, and distributed system is what they need. But now, with cloud services and public cloud platforms, this wouldn't be a problem. Now, since every company has started to adopt cloud services, it can be claimed that the cloud is the talk of the town, and AWS in particular is the leading cloud service provider in the market. AWS, which stands for Amazon Web Services, is an Amazon.com subsidiary which offers cloud computing services at an extremely affordable rates. Therefore, its customer base is strong and it targets everyone from individuals to startups to tech giants running the IT landscape. If you might wonder what cloud computing is basically the use of remote servers on the internet to store, manage, and process data, as opposed to an actual physical server or a personal computer to do the same. As we are talking about AWS, it is kind of an IaaS or infrastructure as a service, which basically gives you a server in the cloud that you have complete control over. In IaaS, you are responsible for managing everything starting from the OS completely up to the application you are running. So now that we have discussed about DevOps and AWS, let's move on to our CI/CD pipeline. Now, what is a pipeline or CI/CD pipeline? It's nothing but a series of steps that must be performed in order to deliver a new version of the software. At its bare bones, at its most basic, you have your build, test, and deploy stage. The CI/CD basically stands for continuous integration and continuous deployment. So CI is basically continuous integration, which basically means bringing together all the developers' working copies to a shared mainline. All the developers working on parallel branches of a certain upgrade of an application merge their changes into one main branch. And CD stands for continuous delivery and deployment. Now, while the CI includes building and testing of your application, continuous deployment is about the processes that have to happen after the code is integrated for the app to be delivered to the users. These processes involve testing, staging, and deploying the code. So at the end of this session, what we aim to do is build a CI/CD pipeline for our demo app on AWS. So for that, we will have to look at a few components of AWS. So DevOps, when implemented on AWS, becomes a lot more efficient and effective for a productive lifecycle. And the steps that are involved in AWS DevOps are code commit, code pipeline, code build, code deploy, and optionally code start. So first of all, we have AWS Code Commit, which is a fully managed source control service, somewhat like GitHub, that hosts secure and highly scalable Git-based repository without the need of operating the system. It's mainly designed for developers who are supposed to store and version their code securely and reliably. For example, you have your IT administrators that store their scripts and configurations, and your web designers who can store their HTML pages and images, etc. The code commit is fully managed, has great availability, is secure, scalable, and pacens up your development lifecycle. For people not aware of code commit, think of it as versioning in your S3. But how it's different is that S3 supports versioning, but not collaborative file tracking features, which code commit obviously does. It manages batches of changes across numerous files made by multiple developers parallelly. How it works is that you create a repository in AWS Code Commit service via the console or CLI, and later using Git from the development machine, you can run git clone to connect the local repository and the AWS Code Commit repo. You can then modify your files on your development machine via the local repository and then run git add, git commit, and push it to the AWS Code Commit repository as you do with GitHub. Again, like Git, even Git pull can be used here to synchronize the files in AWS Code Commit repository with your local repo, which ensures that you're working with the latest version of the files. Next on our list, we have AWS Code Pipeline, which is a combination of continuous integration and continuous delivery services for a quicker and more reliable infrastructure and application updates. It automatically builds, tests, and deploys a user code whenever there is a code change, and it is completely based on user-defined release process models. It also integrates with AWS services like AWS Code Commit, Amazon S3, Code Deploy, Elastic Beanstalk, OpsWorks, and AWS Lambda. You can configure the pipeline either with your CLI or your graphical user interface. And like most services on AWS, even with pipeline, you only have to pay for what you use. All of this is great and all, but why should you use Code Pipeline? Simple. By automating your software build, test, and release processes, AWS Code Pipeline enables you to increase the speed and quality of your software updates by running all new changes through a consistent set of quality checks. It automates your release process, it speeds up your delivery with quality, it allows you to choose your tools of choice, establish consistent release processes, and provide a pipeline history detail as your source of truth. Code Pipeline basically breaks up your workflow into a series of stages like your source, build, test, and deploy, and gives you a revision option as a deployable content. Each stage can process only one revision at a time, even though multiple revisions can be processed in the same pipeline. And each stage will have at least one action to be performed, which is some kind of task performed on the artifact. Once all of the actions that are configured in a stage is complete, the stage is considered as complete. After a stage is complete, it transitions the artifacts created in that stage to the next stage of the pipeline, where you can manually enable or disable it, so it prevents changes from running through an entire pipeline. An approval action is granted only by the IAM user, and if an action fails, it does not transition to the next action or stage at all. So when a developer completes working on his code, he or she commits it to the source repository, and Code Pipeline automatically detects the changes and builds those changes. After that, the build code is deployed to the staging server for testing, and then additional tests such as integration or load tests are run by the Code Pipeline. Once all of the tests are run, if the code receives manual approval, then AWS Code Pipeline deploys the tested and approved code to the production instances. Also, every time when a user creates a pipeline, the Code Pipeline creates a folder for that pipeline in an S3 artifact bucket in that particular region to store input and output artifacts. Next on our list, we have AWS Code Build. Now, this is a fully managed build service in the cloud, which compiles your source code, runs unit tests, and produces artifacts that are ready to deploy. It eliminates the need to provision, manage, and scale your own build servers. It provides pre-packaged build environments for the most popular programming languages and build tools, and scales automatically to meet your peak build requests. Now, one prerequisite is that you must provide the AWS Code Build with a build project, which should include information as to where to get the source code from, build environment, build commands, and where to store the build output. How it works is that the code build will use the build project to create a build environment. AWS Code Build then downloads the source code from the build environment and performs tasks that you would specify in the build specifications. If there is any build output, the build environment uploads its output to the S3 bucket, and while the build is running, the build environment sends information to Code Build and CloudWatch logs. You can use the Code Build console, AWS CLI, or AWS SDKs to get summarized build information from Code Build and detailed build information from CloudWatch logs as well. Now, that was all about Code Build. Now, finally, let's talk about Code Deploy. Now, AWS Code Deploy is a service that coordinates your application deployment and updates across the fleet of AWS EC2 of any size. It automates your code deployment to any instance, handles the complexity of updating them. It also avoids downtime during application development and rolls back automatically if failure is detected. Apart from that, it also integrates with third-party tools and AWS to make your job easier. It has 6 primary components to be specific. You have application revision, compute platform, deployment group, deployment configuration, and the code deploy agent. Now, the basic skeleton of how your deployment workflow pursues is as you can see on your screen. You basically create an application with a unique name and set up a deployment group by specifying the instances to which you want to deploy your application and the deployment type. If you're using the Lambda platform, you just deploy your deployment group's name, followed by which, in your deployment configuration, you specify the success or failure condition of deployment and to how many instances you want to deploy parallelly. Then you upload the application specification file to the S3 and deploy your application as specified with the help of your code deploy agent, which is running on each instance on an EC2 platform, or as specified in your specification file to the deployment group when you're using a Lambda platform. And finally, you check your deployment results. And if you face any bugs or issues, you can always roll back and redeploy. Finally, let's discuss a little bit about CodeStar, which is basically a cloud-based development service that provides tools that you need to quickly develop, build, and deploy applications on AWS. It's basically a very templatized format where you start developing on AWS in certain minutes and you could choose from a variety of project templates. All of the software delivery is easily managed and you can work across your team very securely using the CodeStar. And apart from all of this, you also are provided with a project management dashboard to monitor your application continuously. All you have to do as an AWS CodeStar admin is create a project and add users. Your users or team members will commit changes, which in turn will be built and deployed. And through consistent monitoring of the application, if there are any updates required or any bugs, the developers take a decision, make updates, fix bugs, and then the loop closes back in on the team, and that's about it. The development process takes little to no time using CodeStar. Now that we have spoken about all of these different components of AWS DevOps, I hope building the CI/CD pipeline would seem a tad more tangible to you. If you're new learners, you can always sign up for a free tier, which is free for the entire year. Obviously, there are limitations to all of the services beyond which you shall be charged, but that rarely happens. So if you're starting out with AWS and want to try out all of its features and services, the free tier is a pretty good idea. We already have a video on how to create a free tier on the AWS console. If any of you want to know how to create a free account, you can just go ahead and check that out. So we're going to be building a CI/CD pipeline using AWS, using Code Pipeline, and I'll try to be as slow and verbose as possible, as comprehensive as possible, so as to help you guys to follow me each step of the way. So what we'll be doing here is that we'll be creating a demo application, platform as a service application, and we shall be deploying it using the Code Pipeline. So let's go ahead and create our application first. So to create an app, we will be using the Amazon Elastic Beanstalk, which basically has a bunch of templates ready for you. Now, since this is a demo about Code Pipeline and not web development, we'll be creating a pretty rudimentary app. So let's go ahead and type Elastic Beanstalk. Using Elastic Beanstalk, we can make simple apps very, very quickly. And if you have already created an application, created a few applications, they are going to appear right here on your screen. But since we have created no applications using this particular account, this is a screen that will greet you. So we're going to go ahead and click on Create Application. So let's call this Deployment App. We're not very original, are we? We're not going to put in any application tags. You could put them if you like, but currently they are completely unnecessary. On platform, let's pick PHP, and it automatically fills up the platform branch and version with the latest ones available. Then I'm just going to be using the sample application code and click on Create Application. Now this is a platform as a service app. So basically, once I click on Create Application, I wouldn't have to worry about any background processes or creating the infrastructure. Elastic Beanstalk is going to do that for me on its own. And here, it's going to show you all of the steps that are taking place, like create environment is starting, using Elastic Beanstalk as Amazon S3 storage bucket for environment data, so on and so forth. Now this will take some time, so let's go ahead and parallelly do something else. I'm going to open another tab. Now the AWS console. Okay, thankfully it did not ask me to sign in again. So while my app gets created, what I'm going to do is I'm going to create the pipeline. So I'm going to type in Code Pipeline. And the funda is simple even here, guys. You're just going to put in certain details and your pipeline will be created for you. Now, this is your dashboard. This is where all of your recent pipelines will appear. Since in this free tier, we have no pipelines created, hence you have no results to display. So first things first, I'm going to create a pipeline. So click on this big orange button which says Create Pipeline. I'm going to give the pipeline a name. Let's just call it Demo Pipeline. So as a default, I'm just going to fill in a role name, AWS Code Pipeline Service Role US East Demo Pipeline. Then click on Next. So for source provider, I'm going to use GitHub. And for that, I'll have to connect to GitHub. And it'll ask me to authorize the code suite. Okay. Okay, once you have successfully authenticated the account, you can go ahead and search for the repository. Here, I'm going to choose the demo-code deploy app, which is actually a sample app I have forked from the AWS Code Pipeline repository. You can go ahead and look for it as well. It will be available in the AWS Code Pipeline's GitHub account. Yeah. And in the branch, let's select master branch and click on Next. Now we move on to the build stage. Because I have nothing major to build, I'm just going to go ahead and pick skip build stage. Then you will be prompted with a notification which will ask you if you're sure to skip your build stage. Now, since I have nothing major to build, yes, I am going to skip this build stage. And for deployment, here we are going to choose a deploy provider. So here I'm going to use Elastic Beanstalk and put in my application name and my environment name. Now our application name was deployment app and our environment name would be deployment app environment. This is something which gets created automatically. So we're going to go ahead and click on next. And finally, we are at the review stage where you can go ahead and review all of the details that you have just put in for your code pipeline. And I'm just going to create this pipeline. It's pretty simple to do. Now this might take a few moments, so kindly be patient. And then you are greeted with a notification which says, "Success, congratulations, your pipeline has been created." Now here you can go ahead and release changes if you want. Our IAM role is in place that we had created earlier. Our pipeline is a success. Now all we have to do is wait for our application to get created, and then we can go ahead and deploy our application. All right, with that, our application has been created. It has OK health, and you can see the platform here. You can see the running version. You can see all the details, all the recent information regarding the app. Now, this is a platform as a service. It basically runs all of your processes in the background. Now, if you would have gone ahead, created this app, configured your IAM user, configured everything else that was needed, this would have taken you a lot of time. But because you are using a platform as a service feature of AWS, this entire process is automated and your work is simplified. So if you go down and look at the recent events, one thing you can see is your instance deployment is completed successfully. Just in the line above that, you can see that your new application was deployed to running EC2 instances. So basically an instance is running on EC2. So let's go ahead and go to EC2, click on instances running. There is one instance running, obviously, we all know which one that is. And this is your deployment app. Now if we go ahead and click on it, here you can see the instance state, it's running, and your pipeline, your source has succeeded, your deployment has succeeded. You go here, you can go down, take a look at your IAM role, your subnet ID. So with that, your instance has been deployed and you realize that your demo pipeline has worked.
What Azure DevOps exactly is. To understand that, we need to understand what Azure is. And to understand Azure, I would be using this particular analogy. Now, if you talk about power consumption, it's fairly simple. I mean, you consume electricity and you pay for the amount or the units that you've consumed. If you've used maybe 100 units, you'd be charged for 100 units. And the important part here is you're not concerned about where the electricity has come from, who maintains it, how is it generated, how is it brought to your house, and stuff like that. I mean, even if you know about these things, it's not your concern how it is done. I mean, even if you do not have any knowledge about it, you can still survive very well. Similar as Azure or any cloud service provider that is there in the market. Let me tell you how. Now, if you talk about software development, you normally have to take care of a lot of things like building a software, building the infrastructure in first place, having servers in place, making sure that your servers, your resources are monitored and maintained. Now, the problem here is if you are doing all these things, you won't be able to focus on your business. And if you wish to focus on your business, you probably might need to hire quite a few people. Plus, servers and stuff like that is actually costly. What if I could tell you that you could actually go ahead and rent all these services like you rented the electricity and paid only for the units you used? Wouldn't that be nice? Well, this is what Azure does. It is a cloud service provider which actually lets you rent, compute, storage, database, analytics, and a number of other services. You only pay for the services you use and only for the time duration you use those services for. And that is why this analogy, which is very similar to how electricity is consumed and used. I hope the idea is clear to you what Azure is. To give you a little more specific definition, it is a popular cloud service provider which provides services I just talked about, and it is one of the best in the market. It is a Microsoft product, and we all know that Microsoft is a big fish when you talk about software market. And that is why Azure is one of the leading cloud service providers. It is second only to AWS, and it is actually catching up with AWS in a very good way. Now, AWS also has a DevOps approach, and as I've already mentioned, Azure is very much neck and neck with AWS. It also has its DevOps services, and these services that are provided by Azure are very good when you talk about comparing those with AWS DevOps services. Let's try to understand how Azure DevOps services go well with each other. And to do that, let's take a look at some of the components which Azure has to offer to you. Well, when you talk about Azure components, these are the major components which Azure has to offer to you. You have your Azure pipelines, you have your Azure boards, Azure artifacts, Azure repos, and Azure test plans. If you remember the definition of DevOps, I talked about continuous integration and continuous deployment. Let me throw in some light on what it is exactly. Now, when you talk about continuous integration and continuous deployment, what you mean to do here is you wish to continuously build softwares and continuously deploy those to the end users. Again, if there are any releases, any changes that need to be done, those should be implemented right away, and the latest version should be available to all the people that are working on that software. I mean, if I actually go ahead and build a particular software, now, if there are like 15 people working on that, and if I make some changes to that software, that change should be given to everyone, right? So this is where continuous integration and deployment comes into picture. It aims at keeping everyone on the same page and ensuring that software development happens at a faster rate. And to do that, you have something called as Azure pipelines. Now, when you talk about continuous integration and deployment, you need a line, maybe a tunnel where you can actually carry out these processes, right? That tunnel, that line, that pipeline is something that is provided by Azure pipelines. I mean, you can actually go ahead and build any kind of software and use different kinds of platforms that Azure supports. And when I say Azure supports, well, Azure supports so many platforms that I believe there is hardly any software or any framework that you wish to use that you cannot using Microsoft Azure. And that is why building pipelines with Microsoft Azure becomes very easy. Now, if you talk about building pipelines in general, it is a very simple and a very easy to implement kind of a process, because it is just clicks away when you talk about Microsoft Azure. And once the pipeline is ready, integrating it with different softwares becomes very, very easy. Now, again, if you are building a software, you might be having maybe hundreds of people working on that software. In that case, you need a software or something that would let you keep track of all these things, help you plan better, help you have everyone on the similar pages, and help you keep track of all these things. Now, this is where Azure boards come into picture. It readily integrates with Power BI. Now, if you people know what Power BI is, it is a data visualization and business intelligence tool, and it is one of the best in the market. It is very neck and neck with Tableau, which again is a great tool. And what Microsoft Azure boards do is they let you integrate Power BI into Azure DevOps environment, where you can actually go ahead and take a look at the data in real time and have various graphs, charts, so that your assessing or the way in which you keep track of all these things becomes a lot more easier. Next, we have Azure Artifacts, and what it does is it lets you take into consideration various packages or feeds that you generate. Now, when I say this, you can do that from both private and public resources. Apart from that, whether it's Maven, whether it's NewGen, whatever it is, everything is taken care by your Azure Artifacts. When you're talking about continuous integration and deployment, your repositories become very important. And Microsoft Azure lets you have any kind of repositories that are there. If you take a look at Azure Repos, it has almost everything that is needed to deal with repositories. If you're building a software, it needs to be tested. And with Azure test plans, you can do end-to-end testing, and it ensures full coverage for your tests. So these are some of the components that ensure DevOps process is carried out very well with Microsoft Azure. And that is why Azure and DevOps go very well hand in hand. Now let's move further and take a look at the demo part. So guys, in order to understand how Microsoft Azure works or how the Azure DevOps stuff works, we would be switching into Azure Portal. Now, Azure, as I've already mentioned, is a cloud service provider, and we are going to see how Microsoft Azure can be used to carry out DevOps operations. To do that, you can actually go ahead and visit Azure's website. Just open their website, and then you have this place called as Portal where you can click in. Now, guys, if you have an account, it would ask you to sign in. Just go ahead and sign into your account, and you are more than good to go. for people who are completely new to Microsoft Azure, let me tell you a thing that they have something called as a free tier where you can actually go ahead and create a free account. You have to enter in your credit card details, but Microsoft Azure won't charge you for that. Once you create an account, Microsoft Azure gives you certain free credits which you can use for a particular duration of time. Now, I cannot see my credits here, but normally you can actually go ahead and take a look at the amount of credits that Microsoft Azure has to offer to you. It is somewhere around, if I'm not wrong, it is close to $200 if I'm not wrong. Yeah, that is what it is. So probably you would be able to utilize the services for free. And how do you do that? You use that credit that is made available to you. So if there is a particular service that you want to use, you can pay the bills using the credit that is made available to you, and you won't be charged for the services that you use. There are certain limits on the services that you use. Suppose if you actually go ahead and create a server and you let it open for a long time, create a database on top of it, you might be charged heavily for that. But I would suggest that you actually go ahead and take a look at certain documentation that Microsoft Azure has to offer to you. And as long as you stay in the specified limits, you won't be charged anything. So I would suggest that you actually go ahead and put in your credit card, debit card details and get an account created. Once you create an account, this is what the Microsoft Azure portal or the interface looks like. So we have our account, which is up and running. Now we are going to go ahead and carry out DevOps practices, right? So how do we do that? We switch into DevOps. You can just come to the search console and type DevOps here, Azure DevOps, or you can just go ahead and type Azure DevOps somewhere here. The reason I'm doing this is I want to show you how the interface looks like. So this is what it would look like when you start. And if you click on start free, you would be redirected to this page. Now again, guys, first you need to create an organization. Think of organization as an environment. I mean, if your company is actually planning to build a software, they would be having a structure to do that, right? So if your company is planning to actually go ahead and build a particular software, they would be having a template, a structure to do that, right? So when I say an organization, I'm talking about a structure. How do you create an organization? It is very simple. Here's an option here. If you click on new organization, it would ask you for the name of the organization. You enter the name and your organization gets created. Now that we have an organization, our next step should be to go ahead and create a project. How do we do that? Again, click on project. There would be an option here once you create an organization saying that you want to create a project. You should say yes on it. Again, that is how the interface looks for somebody who has started fresh. If not, this is what it would look like. So I can just go ahead and enter the project name. Let's say demo project for today. I'm bad at naming conventions, so forgive me for that. Description, sample project would do. Again, guys, the complexity of project is not important here. I'm just trying to explain certain stuff to you. So please pardon this simpleness of this particular project. Again, guys, once you do enter in the details, it gives you an option. Do you want it public or private? When you say public, anyone on the internet can have access to it. More of an open source kind of stuff. If not, you can stick to your private thing and you can give access to the people you want to take a look at your project. Having said that, if you select private, you can just say create project and your project gets created. Okay, guys, so the project is created. It took a longer while than normal. If your internet is not working that well, at times it takes this time. So once the project is ready, guys, you are actually free to go ahead and do the stuff. Now, these are the components that we talked about. At the bottom, you can see these components. You have your boards, repos, pipelines, test plans, artifacts, and you can actually go ahead and create all of those. Let's start by creating a pipeline first, guys. So all you have to do is say new pipeline. Now again, guys, how do you actually go ahead and create a pipeline? What do you do for that? Do you go ahead and use an existing piece of code that you have? Do you have repositories that you want to do? Or do you want to type in your own code? You can do anything you want. You can use Azure repos, which are made available to you for free. GitHub, we all know, is a popular place to have your repositories kept. And if you wish to do that, you can import repositories from your GitHub as well. To do that, you have to actually just go ahead and click on this icon. That is what I'm going to do in this session. I'm going to use a GitHub repository. So you have to click on this thing and you have to authorize your GitHub repository or your GitHub account rather. Now my account is already authorized with Azure, so I don't think it should ask me for reauthorization. You can actually go ahead and authorize your GitHub account. Once you do that, you're free to actually go ahead and import repositories from your GitHub. Now, if I go to GitHub, this is my demo account. So I have one repository that I have it here. My repositories. You can see this is a Python repository, guys. As I've already mentioned, you can use any platform you want when you talk about Azure. Python is something that is simple, and I wish to stick to that. Now, this repository is something that is made available to you by Microsoft Azure as well. Do not worry, I would be sharing in this link. If not, you can visit Microsoft Azure Docs for Azure DevOps and you would get this link as well. So once you have this link, you have to fork this thing into your GitHub. For people who do not know what GitHub is, well, think of it as a storage place where you can actually go ahead and store your repositories. Now, repositories is nothing but it is a piece of code or a software which you can actually go ahead and store it here, which you can give access to others as well. Something that is called as open source, where others can actually go ahead and take in your piece of code, maybe modify it and give it to you, or modify it and use it for their own purpose. So this is what GitHub does. It is a place where you can put in your codes, you can have a master branch for it, and you can give access to certain people who can make changes to that code. Now, how do people make changes to it? They have this option which is called as forking your GitHub repository. When I say forking it, that means I'm actually creating a copy or a branch of this particular repository and I'm using it for my own sake. Once I make changes to it, I can submit those changes to the main repository or to the master branch of it. So this is what GitHub is. And the process which we saw here, it would ask you to authorize your GitHub account. And if you've already forked that particular repository, it would be available here in the suggestion. As you can see, it has been forked here. So I have this repository here, which I've selected. So it opens my YML file, which is there, which I can actually go ahead and edit. What does this thing do? It considers Python Django framework. It tests a Django product or project rather on multiple versions of Python. And it has steps that lets you analyze code, save, build artifacts, deploy them, and more. So this is what this piece of code does for you guys. And won't be getting into the details of what this code does, but again, it's a sample repository. You can actually go ahead and study it a little more. Once you do that, all you have to do is just run this piece of code. As simple as that, guys. You have to run it. What this code does is it creates a pipeline for you. And when I say it creates a pipeline, it lets you probably actually go ahead and make codes, make changes to the codes, and submit those to the master branch. We would be doing that. Do not worry about that. As you can see, Microsoft Azure gives you continuous feedback and update as to what is happening, where it is happening, and how it is happening. This might take maybe half a minute or so because quite a few things that are happening. As you can see, it's telling you what has happened, right? I mean, the processes, you can see the tasks happening. It is performing tests and stuff like that. See, these are the number of processes that have taken place. You've prepared a job. It has initialized an agent to take care of it, initialized the job, got resources for it, used Python version, exported the project path, then it installed certain prerequisites, it ran tests, it published the test results, and then this is what happened. Post job get sources. If you wish to have more details, you can click on this icon and it would give you the details about what has happened here. So you can do that as well. Or you can just probably come back to pipelines and see that there's a pipeline that has been created. Now, guys, if I actually go ahead and commit changes to this piece of code, that is my YML file or the files that I have in this repository, those would be reflected here. You can see the status here. We are going to do that, but let me show you some other things as well. If I click on analytics, it should give me analytics of what has happened here, whether there were any failures, whether the code ran properly and stuff like that. Test failures is not available because we do not have a plugin here. When I say plugin, okay, it did not find any test results is what it is saying. So let's just go ahead and do certain things and probably this would be more clear to you guys. Do not worry about that. Going back to the history part. If I take a look at the summary part, it would tell me what has happened here. Test succeeded, build pipeline succeeded, manually queued, and this is what has happened. Now, guys, can I just go ahead and put in certain other details? Can I make certain changes here? Let's try to understand what can be done. Now, again, I have this Git repository with me, right? So let's just go ahead and play with it a little and commit certain changes. To do that, first, go to the pipeline. This is the pipeline I'm concerned about. And probably I must be getting certain details that I'm looking for. they're not here. So let's go back a little. Projects, lines again. Here you have this option called as status badge. Now, what is the status badge? See, this is what the status badge looks like. It tells that, okay, whether the pipeline you built was built correctly or not. So if you are a developer, you would be wanting your code to be green, right? I mean, everything should be checked green. Everything should be nice and ready and successful. So this is what the badge does. So we are going to go ahead and use this piece of badge to add to our code so that now this is a sample stuff. I mean, it's not that important, but if we do go ahead and make or add this badge to our piece of code, it would show that a certain change was made in the code or in the file, and that would be reflected in the pipeline, something that is important when you talk about CI/CD. So let's do that with this simple example. So I come to the pipelines here, my pipeline, and then I scroll down. You would be having this README file where you can make changes. How do we do that? I say edit. And then I add in a piece of code here. Say, let's add a new piece of code somewhere here maybe. Okay, there you go. Again, guys, do not get into the details of the complicacy of this stuff. It is fairly easy, and do not judge me for that either. I mean, as I've already mentioned, my aim is to just go ahead and show you how the concept or the stuff works. So it is very basic, guys. I've just gone ahead and made some change to this piece of code. I've actually just gone ahead and added the badge here. So I'm just going to go ahead and say commit changes, update readme file. Yes, please do that. Commit directly to the master branch, or should I commit it to the new branch that I did? Let's say master branch for now. So the change was committed here. So if I come here and if I just go to pipelines and select my pipeline, open it. Yeah, there you go. The change has been reflected. Update readme. So this file was updated. So again, guys, this is what I'm talking about. Continuous integration and deployment. That is what it means. I mean, if I make change to this piece of code, and if somebody else wants to access it, it or my software should give me the latest copy, right? So this is what this piece of code is doing. In my pipeline, if I just go ahead and pick a certain piece of code, I make change to it, that change gets reflected. And this is what DevOps does. And this is what Azure helps you do. It lets you bring in the whole GitHub concept into Azure, and it helps you go ahead and work with CI/CD in a much better way. Again, I talked about some other stuff as well. Repos, you have your boards, you have quite a few things that you can do. If you talk about overview in general, you have something called as dashboard. So if I click on this icon here, so I have this dashboard that is created by default. Oh, there is no dashboard here. Or if there is a dashboard, it does not have widgets. So I'm going to add a widget. Let's say I need a widget for build history. So I click on it and I say add. So I say done editing. So if I just refresh this thing, so if I just come here and select this particular pipeline and I say save, it will reflect the changes that has happened. What happened with or what is happening with this particular dashboard or with this particular project. So it would give me details like these. And as I've already mentioned, when you create dashboards, you can actually go ahead and integrate Power BI, which is a very popular business intelligence and BI tool basically. So you can actually go ahead and take in or consider all those features as well. Apart from that, you have all the other stuff that you can actually go ahead and play with. Again, to use analytics or to understand how analytics work with this thing, you actually would have to go ahead and do two things. One, you would have to go ahead and integrate your plugin for analytics. Once you do that, you can go ahead and implement quite a few things. To do that, you can actually come here and you can do quite a few things. You can take your GitHub connections. You can integrate your GitHub with your Azure. You can actually go ahead and integrate quite a few other things. See, you have options like service connections, agent pools, retention, parallel jobs, and stuff like that. So you can take care of all those things as well. Boards, again, you can go ahead and add items here. Items as in you can put in states where you want to put in details for certain things, like there are particular bugs that have particular priorities. Based on your project, you can add in those items saying that, okay, this is the criticality of those items and stuff like that. It is fairly easy. You can just click on create a new item, whether it's a bug, whether it's a feature, issue, whatever it is. You can go ahead and you can add that here. and you can keep track of all those things in the form of dashboards or boards here. Repos, you can actually go ahead and when you click on files, you can see the repos that you're using and stuff like that. You can go to the marketplace and you can take in the repos that Microsoft Azure supports. Pipelines, we've seen what it is. Test plans, you can go ahead and launch proper test plans as well. And you can create your own artifacts or your feeds as well by using Azure Artifacts. So yeah, guys, this is pretty much what this session had to offer to you people. We did go ahead and create a pipeline. We saw how to commit changes and how those changes get reflected when you use an Azure pipeline. And we also saw what dashboards are and how do they work.
What is Google Cloud Platform? Google Cloud Platform is a suite of cloud computing services and management tools offered by Google. GCP runs on the same cloud infrastructure that Google uses internally for its end-user products such as Google Search, Gmails, Google Photos, and YouTube. GCP is one of the leading cloud service providers along with Amazon Web Service and Microsoft Azure Cloud and owns 7% of the total cloud market share. Gartner has positioned Google as a Magic Quadrant leader among the furthest 3 positioned vendor. Google Cloud's global network spans across 25 regions with 76 zones and is available for the users from over 200 plus countries and territories. Now, a region is a specific geographical location where you can host your resources. A region can have 3 or more zones. Also, many enterprises are increasingly adopting Google Cloud Platform because the services offered by Google Cloud are more secure and cost-effective. Now, let us take a look at the core services provided by GCP. First is the Google Compute Engine, which is Google Infrastructure as a Service virtual machine offering. It allows customers to use powerful virtual machines in the cloud as server resources instead of acquiring and managing server hardware. Second is the GCP Cloud Storage. It can store the entire organized databases, raw video streams, and even the matrix for machine learning models. It is an object storage system. Its records maintain both the identity and the structure of any class of data given to it. Third is networking. Now, GCP provides tools that makes it easier to manage and scale your networks. It provides a single place to publish, discover, and connect all application services, reducing the management and operational complexity. The next service domain is big data. Now, GCP provides multiple services like Dataflow, Dataproc, and Data Fusion to help you create a complete cloud-based big data infrastructure that supports big data storage and analysis. The advantage of hosting big data infrastructure in the cloud is that it provides unlimited data storage and easy option for parallel big data processing and analysis. Next, GCP also provides all the tools developers and the development team need to be productive while writing, deploying, and debugging applications hosted in the Google Cloud. The next service domain is identity and security. With GCP IAM, you manage access control by defining who has what access for which resources. It lets the administrator authorize who can take action on specific resources, giving you full control and visibility to manage Google Cloud resources. Next is the GCP IoT service, which provides an intelligent IoT platform which is scalable, fully managed, and integrated. It lets you connect, store, and analyze data at the edge and in the cloud. The next service domain is artificial intelligence. GCP provides fast, scalable, and easy-to-use AI offerings, including an AI platform, video and image analysis, speech recognition, and multi-language processing. This was about Google Cloud Platform. Now let us move on to the next topic and see what is Google Kubernetes Engine. Google Kubernetes Engine provides a managed environment for deploying, managing, and scaling your containerized application using the Google infrastructure. The GKE environment consists of multiple machines, specifically compute engine instance, which are grouped together to form a cluster. Now, a cluster is the foundation of Google Kubernetes Engine. The Kubernetes objects that represent your containerized application all run on top of your cluster. Now, to understand GKE better, let us understand its architecture and its working. As you know, all Kubernetes objects that represent your containerized application run on top of a cluster. It is a foundation of GKE. A cluster consists of at least one control plane and multiple worker machines called nodes. These control plane and node machines run on Kubernetes cluster orchestration system. The control plane runs the control plane processes, including the Kubernetes API servers, scheduler, and core resource controllers. The control plane is responsible for deciding what runs on each and every node. This can include scheduling workloads like containerized applications and managing the workload's lifecycle, scaling, and upgrades. The control plane also manages network and storage resources for those workloads. Now all the interaction with the clusters are done via Kubernetes API calls, and the control plane runs the Kubernetes API server processes to handle those requests. You can make Kubernetes API calls directly via HTTP/gRPC or indirectly by running commands from the Kubernetes command line client, that is kubectl, or interacting with the UI in the Cloud Console. Now coming to the nodes. Now nodes are the worker machines that run your containerized application, which is your containers and other workloads. They run the services that are necessary to support the containers running in your workloads. Each node is managed from the control plane, which receives update on each node's self-reported status. Next, we have something called the user pods. Now, pods are the most basic and smallest deployment object in Kubernetes. It can contain one or more containers. So now when the pod runs multiple containers, the containers are managed as a single entity, and it shares the pod's resources such as networking and storage. They're connected to various GCP services such as VPC networking, persistent disk, load balancer, and other cloud operations. This was the architecture of GKE. Now let us understand its working. GKE works with containerized applications. These containers, whether for application or batch jobs, are collectively called as workloads. And before you deploy these workloads on GKE, you must first package it into a container. Now to create a continuous integration and continuous delivery pipeline, you can use Cloud Code to write your application, then send the code to a repository which launches a build process in Cloud Build. This build process builds container images from a variety of source code repository. These container images are stored in container registry and are ready to be deployed in the Google Kubernetes engine. You can then create a GKE cluster using Cloud Console UI, gcloud command line interface, or the APIs. After this, with a few clicks, you can deploy your application on GKE. Now I guess you have some idea about Google Kubernetes engine. Now let us move on to the next topic and see some of the advantage of Google Kubernetes engine. With Google Kubernetes engine, you gain the benefits of advanced cluster management features that Google Cloud provides. First is load balancing for compute engine instance. Google Cloud offers server-side load balancing so you can distribute incoming traffic across multiple virtual machine instances. Load balancer can scale your application, support heavy traffic, detect and automatically remove unhealthy virtual machine instances using health checks, and route traffic to the closest virtual machine. This is a managed service, which means its components are redundant and highly available. So if a load balancing component fails, it is restarted or replaced automatically and immediately. The next benefit is auto scaling. GKE's cluster autoscaler automatically resizes the number of nodes in a given node pool based on the demand of your workloads. You don't need to manually add or remove nodes or over-provision your node pools. Instead, you specify a minimum and maximum size for the node pool, and the rest is automatic. The next benefit is auto-updating. Auto upgrades will help you keep the nodes in your cluster up to date with the cluster control plane version when your control plane is updated. With auto update, you don't have to manually track and update your nodes when the control plane is updated on your behalf. It also provides better security by automatically ensuring that security updates are applied and kept up to date with the latest Kubernetes features. The next benefit is monitoring and logging. Google Kubernetes engine includes native integration with cloud monitoring and cloud logging. When you create a GKE cluster running on the Google Cloud, Cloud Operations for GKE is enabled by default and provides a monitoring dashboard specifically tailored for Kubernetes. With Cloud Operations for GKE, you can control whether or not cloud logging collects application logs. You also have the option to disable the cloud monitoring and cloud logging integration altogether. These were some of the benefits of Google Kubernetes engine. Now let us move on to a demo part and see how to deploy a containerized application on Google Cloud Platform. So in a demo, we are going to package a sample web application into a Docker container image and then run that container image on a GKE cluster. So for that, I've logged in into a GCP account. Now it is very simple to create a new GCP account. All you have to do is enter your debit card or credit card detail and give your address. Then you might be charged maybe ₹1 for it, but even that will be refunded later. Now as you sign into a new account, GCP will provide you $300 of free credit. You can use this amount to explore Google Cloud services. You won't be charged until you choose to upgrade, and it will be valid for 90 days. So first, let us create a new project. So we'll just go here, select a new project. We can name a project anything we want. So we'll just name it Kubernetes. Let the rest be same and we'll just create it. Now our project is created. We'll just select it. So for our demo, we're going to use Cloud Shell. Now Cloud Shell is an online development and operational environment. It can be accessed from anywhere with the browser. The reason we're using Cloud Shell is we do not have to install any command line tools for a demo. So we'll just click on Activate Cloud Shell over here. Then you can see a Cloud Shell terminal which is being created at the bottom of your screen. So the first step, as I've mentioned before, is to build a container image. For this tutorial, we're going to deploy a sample web application called Hello App, which is a web server written in Go programming language. It responds to all requests with the message Hello World on port 8080. But before we deploy the Hello App to GKE, we must package the Hello App source code as a Docker image, and to do that, we need the source code and the Dockerfile. Now the Dockerfile contains information about how the image is built. So first, let us download the source code and Dockerfile for the Hello App application. Git clone https github.com Google Cloud Platform Kubernetes engine samples. So the Hello App application is available in this website. So we've just mentioned the website URL over here. Just click on enter. So it says that the directory already exists. So we get a message saying the directory already exists. So we'll just change the directory. Next, we have to set the project ID environment variable to the Google Cloud project ID. You can find the project ID over here. But I guess my project ID is the project ID environment variable. So let's just confirm it. So for that, we'll just type echo $. Next, you have to set project ID environment variable to your Google Cloud project ID. So for that, you have to type export project ID is equal to, you can find your project ID over here. So you can just copy it from here and paste it over here. The project ID variable associates the container image with your project's container registry. Now to confirm a project ID, we'll just type echo $project ID. Here you can see this is a project ID. After confirming the project ID, it is time to build Docker image for the Hello App. So for that, we'll type docker build space -t space gcr.io/$ project ID / Hello App version 1. Now this is the name given to a Docker image, and GRE refers to the container registry. Oh, we just forgot one more thing over here. That is space a dot. Now it will ask you to authorize Cloud Shell. You can just select authorize over here. Now you can see a Docker image is being created. We'll just extend this. Now you can see our Docker image was successfully built. Now to just confirm if a Docker image was built, we'll just type Docker images. Now you can see a Docker image is built. It was created a minute ago and the size of it. After this, we have to push our Docker image to the container registry so GKE clusters can download it and run the container image. So for this, we are going to enable the container registry API. We'll just type gcloud services enable container registry dot googleapis.com. Next, we have to authenticate to container registry by configuring the Docker command line tool. For that, we're going to type gcloud authenticate configure Docker. Now this is just a warning message saying that we have a lot of credential and it might be slow. So now we have authenticated our container registry. Now we have to push the Docker image to the container registry. So for that, we're going to type Docker push the name of our Docker image. Now a Docker image is being built in the container registry. Now you can see our Docker image is pushed to our container registry. Now the next step is to create a Google Kubernetes engine cluster. So for this, we're just going to minimize it and just go to Kubernetes. You can either select Kubernetes engine from here, or you can just type Kubernetes over here. Kubernetes engine. We'll just click on enable over here. Now this might take a couple of seconds. You can scroll down and read an overview about it. You can read about Google and the various other products which are offered by them. Now this is what the Google Kubernetes engine console would look like. So it will ask us to first create a Kubernetes cluster. So we'll just go ahead and create one. Now we have two options over here. One is standard and the other one is autopilot. In standard, you manage your cluster's underlying infrastructure, which will give you node configuration flexibility. And in autopilot, GKE provisions and manages the cluster's underlying infrastructure. So we'll just go with standard over here and click on configure. So we can name our cluster whatever we want. We'll just name it cluster hello app. You can select any zone from here. These are the available zones. So we'll just select a maybe US West one. Now you can select the zone which is nearest to you. You can select the version. We'll just go to static version and just create a cluster. Now creating a cluster might take a couple of minutes. So we'll wait for some time and refresh it to see if it is created or not. You can see there is a green tick over here, which means our cluster is successfully created. We have already pushed the Docker image to a container registry. The next step is deploying the sample application to Google Kubernetes engine. For this step, you have to create a Kubernetes deployment to run the application on the cluster and also create something called the horizontal pod autoscaler, which scales the number of pods. It can be anywhere from 1 to 5 based on the CPU load. So for that, we'll go to workloads and click on deploy. We have an existing container image, so we'll just select it. Go to select. This is our project ID and this is the name of the Docker image. So we'll just expand it and select this. Our Docker image is selected. We'll click on continue. Now we have to configure it. So we can name our application anything we want. So we'll just name it demo application. We'll let the namespace be default. Next we have label, which is basically for identification. So we'll let the key be app and the value be demo application. We'll not make any changes in that. And this is our cluster on which the demo application is going to be deployed. Now when we see the YAM, okay, so we have an error here. We cannot use uppercase. So we'll just make it lowercase, demo application. Now when we see the YAML file, you can see two Kubernetes API resources about to be deployed into your clusters. The first one is deployment, and next is the horizontal pod autoscaler. Next, we'll just click on deploy, and our deployment is being created. Now this might take only a couple of seconds. Here you can see the CPU usage, memory usage, and a disk usage, but as of now there is no data available. Now if you go to details, you'll see a cluster name, the namespace which I have mentioned, when was it created and at what time, the labels, how many replicas were made. There were 3 replicas which were made. So after the deployment, we're going to expose the sample application to the internet. So for that, we have an option here called as expose. So we'll just click on this. In the target port, we'll select 8080. Now this is the port the Hello app container listens to, as I had mentioned at the starting of the demo. The service type, let it be load balancer itself. And we can name our service anything we want. Let it be demo application service itself. and we're just going to click on expose over here. Now a new service has been created and it is waiting for a load balancer with an external IP to be created. Now this might also take a couple of seconds. Now a service has been created. So when we go to details, you can see the cluster name, the namespace, when was it created, the label, the ports, the type load balancer, and external endpoint. So we'll just click on this, or you can just copy this and paste it in a new tab. So when we click on this, we are directed to a sample application. So here is a sample web application. Now you see our sample application is exposed to the internet through Kubernetes service. And here is the hello world message with the version and the host name.
Let's start with understanding why should you use Terraform. There are some great pre-existing tools like Ansible, Chef, Puppet, and SaltStack. But then what makes Terraform better than these tools? First reason is that Terraform is a server orchestration tool. All the above mentioned tools were created for server configuration, meaning that their primary goal is to install and manage software on the already existing server. Terraform concentrates more on server provisioning, with software container deployment left to Docker and Packer. The next reason is the immutable infrastructure. With Chef, Salt, Puppet, or Ansible, any software update must be run in place. Thus, every server grows a unique record of updates throughout its lifecycle. This can quite often lead to so-called configuration drift when the differences in these configurations lead to bugs. Terraform addresses the issues by utilizing an immutable infrastructure approach, where every new update of any parameter creates a separate configuration snapshot. This way, updating the development environment goes smoothly and is completely bug-proof. The next reason is the declarative code style. While Chef or Ansible forces you to write step-by-step procedural instructions for reaching the desired state, Terraform prefers describing the desired each state of the system, and the tool itself deals with reaching the goal state. But why is it better? With the procedural code, you need to think of all the recent events and processes that took place in order to write clear instructions. But with Terraform, you simply order the tool to do something with the currently active state of the system. This is why the code base remains quite small and easily understandable. The fourth reason is the client-only architecture. Terraform leverages the cloud provider's API for provisioning the infrastructure, which removes the need of additional security checks, running a separate configuration management server, and multiple software agents. Ansible does this by connecting through SSH, yet the capabilities are quite limited. So, what is Terraform? Terraform is an open source infrastructure as a code tool developed by HashiCorp. It is used to define and provision the complete infrastructure using an easy-to-learn declarative language called HCL, or HashiCorp Configuration Language. Terraform supports multiple providers such as AWS, Azure, Kubernetes, Google Cloud, and many more. Now let's understand Terraform better through a use case. Rapider is an agile, innovative company. They are providers of strategic cloud consulting, cloud migration, DevOps automation, managed services, and security consulting. So once their client was looking for a cloud agnostic tool to orchestrate the infrastructure onto multiple public clouds. They wanted the infrastructure to be up in a matter of few minutes. The client had different environments like production, staging, and QA to test. Database backups were also included as a part of infrastructure setup. DevOps engineers at Rapider reviewed and analyzed the client's requirements and came up with a solution of using Terraform to codify the provisioning of infrastructure onto public cloud. Not only infrastructure, but Rapider also automated the application deployment process by integrating GitLab to improve the software development and accelerate the software delivery. The solution provided by Rapider also took care of database backup for a situation when the infrastructure is destroyed. Using this solution, the client is now able to test their application and deploy it on production environment without downtime. So the overall benefits that a client could experience include the client's ability to create the infrastructure over multiple public clouds within a matter of few minutes. Next is that the client has the flexibility to launch the infrastructure as and when needed. Furthermore, the automated deployments help the client push the application into production seamlessly, thereby reducing the time to market. Also, the automated backup of the database ensures that they always have a copy of their latest database. Moving ahead, let's understand Terraform lifecycle. It includes initialize, plan, apply, and destroy. Terraform init initializes the working directory, which consists of all the configuration files. Terraform plan is used to create an execution plan to reach a desired state of the infrastructure. Terraform apply then makes the changes in the infrastructure as defined in the plan, and the infrastructure comes to the desired state. Terraform destroy is used to delete all the old infrastructure resources which are marked tainted after the apply phase. Now let's see how Terraform works. Terraform core uses two input sources to do its job. The first input source is a Terraform configuration that you as a user configure. Here you define what needs to be created or provisioned. The second input source is a state where Terraform keeps the up-to-date state of how current setup of infrastructure looks like. So what Terraform core does is it takes the input and it figures out a plan of what needs to be done. It compares the state and checks what is the current state and what is the configuration that you desire in the end result. It figures out what needs to be done to get that desired state in the configuration file. The second component of architecture is providers for specific technologies. This could be cloud providers like AWS, Azure, or other infrastructure as a service platform. It gives you the possibility to create infrastructure on different levels. Terraform has over hundreds of providers for different technologies, and each provider then gives Terraform user access to its resources. For example, AWS provider gives you access to hundreds of AWS resources like EC2 instances, the AWS users, etc. With Kubernetes provider, you can access commodities, resources like services and deployments, namespace, etc. So this is how Terraform works, and this way it tries to help you provision and cover the complete application setup from infrastructure all the way to the application. Moving ahead, let's see how to install Terraform. Now to install Terraform, let's go to its official website. So the system I'm using is a 64-bit Linux system, so I'll install Terraform for that. I'll copy the link first. Then what we need to do is open the terminal. Then we write wget and we paste the link we had copied and enter. So now Terraform will get installed. Okay, so Terraform has been installed. Since it's a zip file, let's unzip it now. And this is the file name. Let's copy that. Now let's move Terraform to a location. Let's see what the location will be. So we'll be moving Terraform to this location. Okay. Now that it has been successfully moved, let's see the Terraform version that we have. So it's 14.5. Okay. So by writing Terraform and entering, you'll see what all commands Terraform provides you. So these are all the commands. It also includes init, plan, apply, destroy, as we discussed before. There's something also called as validate that you can use, and several other commands. Now that we have installed Terraform in our system, let's move ahead with our demo. So let's just clear screen. Okay. Now what we need to do is we are going to create a directory and we are going to name it Terraform demo. Okay. So let's move into that directory now. Now what we are going to do is we are going to create a configuration file, Terraform configuration file over here. So let's write gedit and the file name. So let's name it demo1.tf. So this is the extension that we need to put for any Terraform configuration file that we are going to create here, and hit enter. Okay, so the gedit file, Terraform configuration file has been created. Here is where we are going to put all the configuration we need. So initially, let's try to create an EC2 instance in Amazon Web Services and then destroy that EC2 instance. Okay, so what we need to do here is Terraform provides you with everything, every support that is there for your code online. So let's say AWS provider, Terraform. Okay, so you can see the usage here. This is what we need to define that we want to create or use AWS service. Let's paste this here. Okay, so it asks for region, access key and secret key. So what are access key and secret key here? We'll get that from Amazon Web Services. Let's see how. So I'm going to create a user over here. I'm going to give it Terraform. And I'm going to give it a programmatic access. Along with that, administrator access. And next. So let's give this as my demo. And value as Terraform. Okay, let's just keep it to Terraform. So this is the summary. And let's create it. So user has been created, and this CSV file is what we need to download to get the, the access key and the secret key. Okay, we have the file here. Let's open it. So this is the access key here. Let's copy this and we are going to paste it here. And we have the secret key. Again, let's copy and paste it here. Okay, so for region, let's create this for US East 2. Okay, now we are going to put what resources we need. Since we are creating EC2 instance, let's so what we need is just this part for now for creating our instance. Let's paste it here. Okay, so it says we want to create AWS instance. Let's change this to, and this AMI is for US West 2. So every time you change the region, AMI is going to change. So let's find it for US East 2. So let's check. So we are on US East 2 right now. And you can see there are no instances running. Okay, so suppose we want to create an instance. We want to launch one. So here you can see the AMI for US East 2. Let's copy that. And we'll paste this here. Okay. So I think this is enough. We don't need to add anything else. We have provider AWS and we have given the region, access and secret key. We want to create AWS instance and AMI and instance type as T2 micro. Let's keep it that way. Okay.
Let's save the file and close it. Now let's go back to the terminal. And now what we are going to do is initialize it. Then let's apply Terraform plan. Okay, you can see here one in the plan, which is the EC2 instance we want to create. And then finally Terraform apply. So it asks for an approval from you. So you just write yes over here. Okay, it says one added. Let's go back to AWS and see if the EC2 instance in US East 2 has been created. Okay, so you can see the instance has been created here. Okay, yeah. So one instance is running and we are in US East 2. So the instance has been created. Okay. Now what we need to do is we want to destroy this instance that we have created. Now simply what we need to do here is Terraform destroy, and this will destroy that instance. Okay, you can see one destroyed over here. Let's see if it has been destroyed. So you can see we had an instance over here, but it has been destroyed now. So this was a very simple and basic demo that I have shown you here. Now let's do something a little more complicated. Let's try to add some more services that AWS provides you. So let's clear the screen. Okay. Now what I'm going to do is we have the same gedit file over here. You can see the demo 1. Okay. So we have written a code partially over here. Let's include some more things and additional features in this code itself. So just remember that this instance has been already destroyed. So while we initialize plan and apply, this instance is going to be created again if we keep this code. Okay. So I want to create this instance again. But apart from that, what I want to do is I want to create another EC2 instance in some another region. So let's see how to do that. For that, let's copy this. Okay. So all I need to do is, suppose I want to create another instance in US East 1. So let's change this. The access key, secret key is going to remain same because we are making it through the same user. Okay. Let's create another resource here because we want to create one more instance. Okay, let's name this something like US East 1. Okay, and just remember the AMI is going to change for US East 1. Okay, so let's search for that AMI now. Okay. Yeah, okay, there is no instance over here. So suppose we want to create one. So you can see the AMI here for Linux. So let's copy this, and so this is the US East 1. Let's paste this here. So you can see the AMI differs from region to region. Okay. So we have done this now. What we need to do is, how will this resource understand that it wants to create an EC2 instance in US East 1? So for that, what we are going to do is we are going to create an alias. So let's put this as okay. So this is done. We have added the alias over here. So let's refer this to this part, okay, this alias that we have created. How we are going to do that is by writing provider is equal to AWS dot whatever alias we have provided here, copy pasted. Okay, so this is done. Now apart from this, let's see, we want to create an S3. So okay, S3 bucket. Okay, so for S3, this is what we need. So let's copy these and paste it here. Okay, so let's change this to something. Let's keep this. So one thing to remember is that the bucket name has to be unique. So let's try to make a unique name over here. Okay, let's keep this. Let ACL be private. Let's change this to my Terraform bucket. And let's keep this dev-env. Okay. Apart from this, what we are going to do is we are going to add versioning over here. So why we are adding versioning here is because we want to preserve, retrieve, and restore every version of every object stored in our Amazon S3 bucket. So that's the reason we have added the versioning block over here. Okay, so looks fine. Let's save this. Okay, so we have one EC2 instance in US East 2, another in US East 1, and one S3 bucket. So remember that in case of US East 2, we haven't used any alias. So what it is going to do is it is going to refer to this default one where there are no alias, nothing provided for it, to refer. So it's going to refer this by default, US East 2. Okay, let's save this. And let's close this. Okay. Let's open the terminal and let's initialize again. Then plan. Okay, so you can see 3 over here, 2 EC2, 1 S3. Let's apply it. Okay, so you can see 3 added. Let's check it now in AWS. Okay, so we are in US East 1. So we will have 1 EC2 here. Okay, so we can see one instance running. Okay, so we have one instance running over here. Let's check it in US East 2. Okay, so we have one instance successfully running over here as well. And let's check our S3 bucket. Okay, so you can see we have one S3 bucket created over here successfully. Great. Now, let's say we want to add a VPC, one subnet, and also want to create relational database system. Okay, so more 3 things, VPC, subnet, and RDS. So what we can do is we can actually add to this rather than creating another file. So let's open this again. Okay, so below this, let's start adding. But one thing to remember is that we haven't destroyed any of this yet. The 2 EC2 instances and S3, we haven't destroyed them. So what we are going to do is we are going to add to this. Okay, so what we are going to add, let's start with VPC. So Okay, so let's copy this. This is what we need to create a VPC and paste it here below. Okay, so it says resource we want to create is AWS VPC. Let's give this a name as dev. Okay, cider block. Okay, let's keep this and let's keep this default. Okay, let's change the tag name to something else. Let's keep it dev VPC. Okay, so that's done. Now suppose you also want to create subnet. So let's search for that. Okay, let's copy this and paste it here. Let's again change a little bit. Let's give it a name as sub. Let's keep the cider block same. And let's change it to dev subnet. Okay. So one thing to see over here is we need VPC ID over here. But since we haven't created a VPC yet, how will we give the VPC ID over here? So there is a way to do that. So what we are going to do is let's just copy the whole thing that we have over here. Copy this and paste it here. We don't want the double inverted commas. Okay. So this is how we are going to give the VPC ID to our subnet. Okay. It's the same as this over here. Just AWS VPC dot dev dot ID. Okay. This is how it will get the ID of the VPC. Okay. So this is done. Apart from that, as we said, suppose we want to create RDS. Let's see what to do for that. So you can see the basic usage here. Let's copy this. And let's make some changes. We want engine version as 8.0.19. Okay. And let's change this to 8.0. Okay. So we are going to add one more line over here, which is we don't want to create a snapshot of this RDS that we are creating. Okay. Suppose this is some dummy RDS that we have created. We don't want any backup for this. So we are going to provide it that we don't want a snapshot. Okay. Okay. So we have written skip final snapshot and we have kept it true. Okay. So it won't create a snapshot. Okay. So that is done. Let's maybe change the name to my Terraform DB. Okay. Username. Let's keep this the same. Okay. This is just an example. So overall, what all we have added to this, we have created one VPC, subnet, and RDS. Let's save this. Okay, and close it. Let's go back to the terminal and initialize it. Then Terraform plan. Okay, so you can see here that 3 to add. So we already have 2 EC2, 1 S3, and apart from that, we are adding one VPC, subnet, and RDS. Okay, so let's apply. Okay, so we can see 3 added. Let's go and check. Let's check this in our AWS console. So we can see that S3 is still running, the one we had created before. So the 3 things we have created now is VPC, subnet, and RDS. Okay, let's check those now. So we can see the VPC we have created is now available. It's running. And this one is a default VPC that was already present. Apart from that, let's check subnets. So see, our subnet is present over here and it's running. Rest are default. Okay, apart from that, let's check RDS. So we can see one database instance here. Let's see. Okay, so you can see the RDS we had created for MySQL, that's running now. Okay, now suppose everything that we have created now, we want to destroy it. Okay, imagine how much time would it take to destroy all of these through console. Now let's see how we are going to destroy it through Terraform. So all we need to do here is Terraform destroy. So what all will it destroy? Everything that we have created in that file, everything is going to be destroyed, which includes our 2 EC2s, one S3, VPC, subnet, and RDS. Okay, everything has to be destroyed through one single command. Okay, let's see. So you can see 6 over here. So let's see if it destroys everything. Okay, so it says 6 destroyed. Let's check one by one. Okay. Now currently we are in RDS. Let's refresh this and see. Okay, so you can see the RDS has been deleted now. It is destroyed. So let's next see VPCs. So we can see the VPC we had created is deleted. The one present over here is the default one. Let's check the subnet. Okay, again the subnet we had created has been destroyed, and these are just the default subnets that are present. Apart from that, let's see EC2. So currently we are in US East 2, right? Okay. So you can see there are no instances running over here. Okay. So the instance we had created has been destroyed now. Let's check S3. As you can see, no buckets over here. So the S3 we had created is also destroyed. Okay, now let's go back to EC2 and we are going to change our region to US East 1. So remember we had created one more instance in different region using alias. Let's see if that has been destroyed as well. Okay. So you can see there are no running instances. Okay. So the instance we had created in US East 1 also has been destroyed. This is just one example of how multiple services AWS provides, and you can do everything through infrastructure as code rather than going through console, okay? So you can do this with other cloud platforms as well, like Azure, Google Clouds, and there are many more. So this was just a simple example for AWS.
Let's have a complete overview at the DevOps engineer's salary based on experience, areas, and other factors. Starting with the DevOps engineer's average salary. According to Glassdoor, the national average salary of a DevOps engineer in India is 7 lakhs per annum. That ranges between 4.4 lakhs per annum to 15 lakhs per annum. Whereas in United States, the national average salary for a DevOps engineer is $1,10,728 per annum. That ranges between $80,000 per annum to $2 lakh per annum. If we see based on experience, then a DevOps engineer with 2 to 3 years of experience can make approximately 5.7 lakhs per annum. If he or she has 3-4 years of experience, then they can earn 6 lakhs per annum. With 4 to 5 years, they can earn around 12.7 lakhs per annum. A DevOps engineer with 5 plus years of experience, on the other hand, can earn roughly around 15 lakh per annum. Well, these numbers accurately indicate a bright career as a DevOps engineer. Well, it is a known fact that the people in different countries get different pay for same work. Let's see how much the salary of a DevOps engineer varies based on geography. As discussed before, in India, the salary range of a DevOps engineer is between 4 lakh per annum to 15 lakhs per annum. In United States, it ranges between 80,000 US dollars to 200,000 US dollars. If we talk about in United Kingdom, then there the average salary of a DevOps engineer ranges between 29,000 euros to 67,000 euros, which is equal to around 26 lakhs per annum to 67 lakhs per annum. Whereas in UAE, the DevOps engineer salary ranges between 15,000 AED to 54,000 AED, which is around 3 lakhs per annum to 12 lakhs per annum in Indian rupees. In Australia, the average salary range of a DevOps engineer ranges between 130,000 Australian dollars to 150,000 Australian dollars. In Canada, the salary range is between 115,000 Canadian dollars to 156,000 Canadian dollars, which is approximately around 70 lakhs per annum to 90 lakhs per annum in Indian rupees. In Singapore, the average salary range of a DevOps engineer ranges between $75,000 to $98,474 per annum. In Germany, it ranges between $24,000 to $1,90,000 per annum. And lastly, in Philippines, the average salary range of a DevOps engineer is between 110,000 Philippine peso to 180,825 Philippine peso. So these were the top countries which have a huge demand for DevOps engineers. Now let's go ahead with DevOps engineer salary based on company. According to LinkedIn, there are over 23,000 plus DevOps engineers job openings at the top companies in India. Starting with Tata Consultancy Services. Here, the DevOps engineer can earn around 4.2 lakhs per annum to 8 lakhs per annum. In Tech Mahindra, the average salary range of a DevOps engineer is between 4.1 lakh per annum to 8 lakhs per annum. In Wipro, it is around 3.8 lakhs per annum to 9.5 lakhs per annum. IBM offers around 4.2 lakhs to 11.9 lakhs per annum for a DevOps engineer. Whereas in Accenture, the DevOps engineer can earn around 4.6 lakhs to 10.5 lakhs per annum in India. Capgemini offers 4.5 lakhs to 10.5 lakhs per annum to a DevOps engineer. HCL Technology also offers 4.2 lakhs per annum to 10 lakhs per annum to a DevOps engineer. As companies seek to stay ahead of their competition through DevOps related technologies, demand for DevOps engineers is surging. As I had said before, that there is a 75% rise in listing of DevOps jobs, and even the DevOps skills have increased to 15%. Now, based on 14,000 plus jobs, the most in demanding skills required to become a DevOps engineers are as follows. First is programming knowledge and Linux fundamentals. To become a DevOps engineer, there are several programming languages you need to learn in addition to specific DevOps tools. But there are three most common languages used in DevOps tools that are Ruby, Python, and JavaScript. It's advisable to learn at least one of these programming languages so as to work with the DevOps tools. DevOps engineers must also know about some of the fundamentals of operating system. Linux is preferably the most important operating system that is required in DevOps. So it has been counted as one of the top skills in DevOps. Next is source code management. Well, source code management is a DevOps automation tool that maintains a track of versions made on the program. So you must know some of the SCM tools in order to run the history of changes in the particular code and to check the different versions, compare them, and then merge them. Next is application building. Well, the application building in DevOps is nothing but a process of planning, designing, creating, testing, and deploying a software application in order to perform various business operations. So you must be familiar with the whole phases of the software development. That is the top skills required as a DevOps engineer. You must also be familiar with some of the automation tools and the CI/CD tools. So, automation tools allow you to outsource repetitive functions to automate that particular program. So, you must know how to automate things. Like everything should be automated. You should know like where to automate the thing or which process can be automated and in order to make the process faster. And the CI/CD approaches help you consistently make minor improvements in the IT infrastructure. So you should be familiar with some of the best CI/CD tools. Next is application testing. Here, you need to track the day-to-day running of IT infrastructure through testing. So you need to identify areas of inefficiency in the system and mitigate potential issues before they arise. So here you check the relevance, representativeness, equity, repeatability, cost effectiveness, scalability, and transparency. Next is application deployment. The application deployment is all about the process of installing, configuring, updating, and enabling one application or group of applications that make a software system available for use. You facilitate a particular URL on a server and deploy that particular application. So you should know how to deploy a particular application. Next is monitoring application. So, as a DevOps engineer, you should know how to constantly track software and system to help resolve system errors quickly. As DevOps engineers, it is specifically concerned with reducing the length of time between when the error was detected and when it has been fixed. So, this one is one of the top skills which is required as a DevOps engineer. Therefore, in order to bring the productivity and making it more time efficient and cost effective, it is an important task to monitor and to solve the particular errors in that particular software. Next is cloud providers. Well, we all know the top three cloud platforms: Azure, GCP, AWS. So you must be familiar with any of one of those clouds while you are working with DevOps, because when you have deployed a particular software or an application, you need to have a backup or storage. As a DevOps engineer, you should know how to integrate cloud with that particular application. So these were the top skills for a DevOps engineer. Now, as we discuss these top skills, now let us see some of the top job descriptions from our top companies, and let's see what are their requirements for a DevOps engineer. So this is a requirement from HCL Technology. They require a DevOps engineer, and their must-know skill, as you can see here, is they should have an experience in DevOps infrastructure, and then you must be expertise with hosting tools, configuration management tools like Ansible, Terraform, Chef, Puppet. So these are the different tools of DevOps which are necessary while the whole process software development process runs. Then you should also have strong problem solving skills and ability to write scripts and scripting languages. You should also be familiar with different programming languages like Python, Go, PowerShell scripting, Java, and many more. And you should also be familiar with different environments like Windows and Linux. So Linux is more preferred in while you're working with DevOps. Let us look on to another job description. So this is from Wipro Limited. They are in demand for a DevOps engineer. So as a DevOps engineer, you should know the CI/CD tools as specified, and you should know how to plan and execute the DevOps pipeline. That is how to like the whole process of the software development, that planning, coding, building, testing, and staging, releasing, and configuration, and all the monitoring of that particular application. So these things you must be familiar with. Then you should also know how to manage the IT infrastructure as per the requirement. Then you must know the DevOps tools and some of the automation tools. You should also know how to use tools to automate testing and deploy in the DevOps environment. So these were the top skills as we discussed above, and you can also see in these job descriptions. So top companies are in huge demand for these DevOps engineers, and with these skills, it is sure that you will be hired as a successful DevOps engineer.
First, you need to understand that there are two main parts when creating an application. The development part, where software developers programs the application and testing of application, and the operation part, where the application is deployed and maintained on a server. And DevOps is a link between the two. Now, this is a bit too abstract, so let's dive into the details to really understand the DevOps tasks and which tools are needed to carry out these tasks. Concept of software development. It all starts with the application. Developers team which program an application with any technology stack, different programming languages, build tools, etc. And they will of course have a code repository to work on the code in a team. One of the most popular ones today is Git. Now you as a DevOps engineer will not be programming the application, but you need to understand the concept of how developer works, which Git workflow they're using, also how the application is configured to talk to other services or databases, as well as concepts of automated testing and so on. Operating system and Linux basics. Now that application needs to be deployed on a server so that eventually user can access it, right? That's why we're developing it. So we need some kind of an infrastructure, on-premises server or cloud server. And these servers need to be created and configured to run our application. Again, you as a DevOps engineer may be responsible for preparing the infrastructure to run the application. And since most of the server where applications are running are Linux servers, you need to have a knowledge on Linux. And you need to be comfortable using the command line interface because you will be doing most of the stuff on the server using command line interface. So knowing basic Linux commands, installing different tools and software on servers, understanding Linux file system, basics of how to administer a server, how to SSH into the server, and so on. Scripting language. In addition, since you are closely working with developers and system administrators, to also automate some of the tasks for them, you will most probably need to write script. Maybe small application to automate tasks like doing backups, system monitoring tasks, cron jobs, network management, and so on. In order to be able to do that, you need to know a scripting language. Now this could be an operating system specific scripting language like Bash or PowerShell, or what's even more demanded, a more powerful and flexible language like Python, Ruby, or Golang, which are also operating system independent. Again, Here you just need to learn one of these languages, and Python without a doubt is the most popular and demanded one in today's DevOps space. Easy to learn, easy to read, and very flexible. Python has libraries for most of the database's operating system tasks as well as for different cloud platforms. Version control. Now with these automation tools and languages, you write all of these automation logic as code, like creating, managing, and configuring infrastructure. That's why the name infrastructure as code. Now, how do you manage your code? Just like the application code, you manage this also using version control like Git. So as a DevOps engineer, you also need to learn Git, build automation, and CI/CD. Now we have developers who are creating new features and bug fixes on one side, and we have infrastructure or server which are managed and configured to run the application. The question now is how to get these features and bugs fixed from the development team to the server to make it available to the end users. So how do we release the new application version basically? And that's where the main task and responsibilities of a DevOps comes in. With DevOps, the question is not just how we do this in any possible way, but how we do this continuously and in an efficient, fast, and automated way. So first of all, when the features or bug fix is done, we need to run the tests and package the application as an artifacts like jar file or zip, etc. so that we can deploy it. That's where build tools and package manager tools comes in. Some of the examples are Maven and Gradle for Java application, NPM for JavaScript application, and so on. So you need to understand how this process of packaging, testing, application work. As I mentioned, containers are being adopted by more and more companies as a new standard. So you will probably be building Docker's image from your application. As the next step, this image must be saved somewhere, right? In an image repository. So Docker Artifact repository or Nexus or Docker Hub, etc. will be used here. So you need to understand how to create and manage artifact repository as well. And of course, you don't want to do all of this manually. Instead, you want one pipeline that does all of these in a sequential step. So you need build automation. And one of the most popular build automation tools is Jenkins. Of course, you need to connect this pipeline with the Git repository to get the code. So this is a part of continuous integration process where codes changes from the code repository get continuously tested. And you want to deploy that new features or bug fix to the server after it's tested, built, and packaged, which is a part of continuous deployment process, where code changes get deployed continuously on a deployed server, and there could be some additional steps in the pipeline, like sending notification to the team about the pipeline state or handling failed deployment, etc. But this flow represents the core of the CI/CD pipeline, and the CI/CD pipeline happens to be at the heart of the DevOps tasks and responsibilities. So you as a DevOps engineer should be able to configure the complete CI/CD pipeline of your application, and the pipeline should be continuous. That's why the unofficial logo of DevOps is an infinite cycle. Because the application improvement is infinite, new features and bug fixes gets added all the time that needs to be deployed. Infrastructure as code. Now let's say this is our production environment. Well, in your project, you will of course need development and testing or staging environment as well to properly test your application before deploying it to the production. So you need that same deployment environment multiple times. Creating and maintaining the infrastructure for one environment already takes a lot of time and is very error prone. So we don't want to do it manually 3 times. As I said before, we want to automate as much as possible. So how do we automate this process? Creating the infrastructure as well as configuring it to run your application and then deploying your application on that configured infrastructure. It can be done using a combination of 2 types of infrastructure as code tools. Number 1 is infrastructure provisioning tools like Terraform, for example, and configuration management tools like Ansible or Chef, etc. So you as a DevOps engineer should know one of these tools to make your own work more efficient as well as make your environment more transparent, so you know exactly in which state it is and easy to replicate and easy to recover. Containers. Nowadays, as containers have become the new standard, you will probably be running your application as containers on a server. This means you need to generally understand concepts of virtualization and also be able to manage containerized application on a server. One of the most popular container technology today is Docker, so you will definitely need to learn it. Container orchestration. Now application will run as containers, right? Because we're building Docker images and containers needs to be managed.
For smaller application, Docker Composes or Docker Swarm is enough to manage them. But if you have a lot of containers, like in case of big microservices, you need a more powerful container orchestration tools to do the job, most popular of which is Kubernetes. So you need to understand how Kubernetes work and be able to administer and manage the cluster as well as deploy application in it. Cloud providers. Now let's go back to the infrastructure where our application is running. Nowadays, many companies are using virtual infrastructure on the cloud instead of creating and managing their own physical infrastructure. These are infrastructure like AWS, Microsoft Azure, Google Cloud, etc. One obvious reason for that is to save costs of setting up your own infrastructure. But these platforms also manage a lot of stuff for you, making it much easier to manage your infrastructure there. So for example, using a UI, you can create your network configuration firewall, route tables, and all part of your infrastructure through services and features these platforms provide. However, many of these features and services are platform specific. So you need to learn them to manage infrastructure there. So if your application will run on AWS, you need to learn the AWS and its services. Now AWS is pretty complex, but again, you don't have to learn all these services that it offers. You just need to know those concepts and services that you need to deploy and run your specific application on the AWS infrastructure. Networking and security. You also need to know basics of networking and security. For example, to configure firewall to secure the application, but also open some ports to make application accessible from outside, as well as understand how IP addresses ports and DNS works. However, to draw a line here between the IT operation and DevOps, you don't have to have advanced super operating system or networking and security skill and be able to administer these servers from start to finish. There are own professions like network and system administrator, security engineers, and so on that really specialize in one of these areas. So your job is to understand the concept and know all these to the extent that you be able to prepare the server to run your application, but not to completely take over the managing the server and the whole infrastructure. Monitoring. Now when you have all these maybe thousands of containers running in Kubernetes or hundreds of servers, how do you track the performance of your individual application? Or whether everything runs successfully, whether your infrastructure has any problems, and more important, how do you know in real time if your users are experiencing any problems? One of your responsibility as a DevOps engineer may be to set up monitoring for your running application, the underlying Kubernetes cluster, and the server on which the cluster is running. So you need to know a monitoring tools like Prometheus or Nagios, etc. DevOps tools. So at this point, you may be thinking, how many of these tools do I need to learn? Do I need to learn multiple tools in each category? Also, which one should I learn? Because there are so many of them. Well, you should learn one tools in each category. One that's the most popular and most widely used. Because once you understand the concept well, building on that knowledge and using an alternative tools will be much easier. If, for example, you need to use another tools in your company or project, so as you see, these are a lot of technologies that you need to learn as a DevOps engineer, and it might be overwhelming. So if you're thinking you don't know where to start or where to learn all these, then we at Edureka have created a complete DevOps training where you can learn all these technology in a structured way.
Now let us start with our first question. Now the first question is, can you explain the shift left to reduce failure concept in DevOps? Now, to understand what this means, we must first understand how the traditional SDLC cycle works. The traditional cycle has two major sides. The planning, designing, and development phases comprises the cycle's left side, and stress testing, production staging, and user acceptance are all part of the cycle's right side. So, shifting left in DevOps simply means moving as many tasks that normally occur at the end of the application development process as possible into the earlier stages of application development. As you can see from the graph, if the shift left operations are followed, the chances of error occurring during the later stage of application development are greatly reduced because they will have been identified and solved during the early stages. Now, one of the most common way to achieve shift left in DevOps is to have a collaboration with the development team to create deployment and test case automation. So this is the first and the most obvious steps towards shifting left. This is done due to the well-known fact that failures in the production environment are frequently not seen earlier. These failures can be traced back to the development team's use of various deployment procedure while developing these features. Then a second common ways is production deployment procedure are not always the same as development procedures. There may be difference in tooling and the process may also be manual at times. Now, both the development and the operation teams are expected to take ownership of developing and maintaining standard deployment procedures that make use of the cloud and pattern capabilities. So this contributes to the assurance that the production deployments will be successful. Pattern capabilities are used to avoid configuration inconsistencies in the various environments being used. So this will necessitate collaboration between the development and the operation teams to create a standard process that guides developers in testing their application in the development environment in the same way that they test in the production environment. Then we can further say to implement a shift left strategy in a DevOps environment, it is important to have the right tools and processes in place. So this may include continuous integration and continuous delivery tools that allow developers to build, test, and deploy code quickly and efficiently. It may also involve adopting agile development methodologies, which emphasizes rapid iteration and the early and continuous delivery of valuable software. In summary, shift left is a practice in the software development and testing process that aims to detect and fix issues as early as possible in the process. By shifting activities that are typically done later in the process to earlier stages, companies can improve the quality of their product, reduce risk, and increase efficiency. Now coming to the next question we have, do you know about postmortem meeting in DevOps? So let us see how we can answer this following question. In the context of DevOps, a postmortem meeting, also known as a post-incident review or a post-incident debrief, is a meeting that takes place after an incident has occurred in order to review what happened and identify what can be done to prevent similar incidents from occurring in the future. Now, the goal of a post-mortem meeting is to improve the system or process that has involved in the incident rather than assigning blame to individuals. So post-mortem meeting can be helpful for a number of reasons. They provide an opportunity for teams members to come together and discuss the incident in a structured way and to identify any problems or issues that may have contributed to the incident. They also allow teams members to share their insight and perspective on what happened, which can help to identify the root causes and the potential solutions. There are a few key steps that should be followed in a post-mortem meeting. Number one is review the incident. Now, this involves discuss what happened, including the symptoms, causes, and the impact of the incident. Now, the second is identifying the root causes. Now, the team should work together to identify the underlying cause of the incident rather than just the symptoms. Next is determine corrective actions. Based on the root cause identified, the team should brainstorm potential solution or corrective action that could prevent similar incidents from occurring in the future. Coming to the next point, we have implement corrective actions. Now, the team should work together to implement the agreed upon corrective actions. Then we have the follow-up. So it is important to follow up on the corrective actions to ensure that they have been implemented effectively and that the issue has been resolved. Postmortem meetings can be an effective way to improve processes and systems, but they are only as useful as the actions that are taken as a result of them. It is important to follow through on a corrective actions that are identified and to keep track of their effectiveness over time. Coming to the next question, we have, what is the concept behind sudo in Linux operating system? So let us see how to go about with this answer. The sudo command in Linux allows the user to execute command as another user, usually the super user or the roots. This is useful in cases where a user needs to perform actions that require elevated privileges, such as installing software or modifying system files. When the user tries to run a command using sudo, the system checks for the following to see if the user is allowed to run the command as another user. If the user is allowed, then the system prompts for the user's password, and if it is entered correctly, then it runs the command. If the user is not allowed, the command is not run and the user is given an error message. One of the benefits of using sudo is that it allows the system administrator to grant specific users the ability to run specific commands as another user, rather than giving all users full root access. Now, this can improve the security by limiting the actions that users are able to perform on the system. However, there are a few potential downsides to using sudo. One is that it can be confusing for users who are not familiar with it, as they may not understand why they are being prompted for a password when they're trying to run certain commands. Another is that it requires an additional step for users to run commands that require elevated privileges, which can be inconvenient. Overall, sudo is an important tool for managing user privileges on a Linux system. It allows the system administrator to grant specific users the ability to perform specific tasks that require elevated privileges, while also providing a means of logging and auditing the commands that are run on the system. So that was about the concept behind sudo in a Linux operating system. Now, moving on to the next question we have, can you explain the architecture of Jenkins? As you all know, Jenkins is the most important tools used in DevOps. So let us see the explanation of the following question. Jenkins is a popular open source continuous integration and continuous delivery tools that is used to automate the build, test, and deployment of software projects. Now you can see here is an overview of the architecture of Jenkins. Now we have the master-slave architecture. Now Jenkins uses a master-slave architecture to distribute the build and test loads to multiple machines. The master node is responsible for scheduling and dispatching build jobs to the slave nodes, as well as recording the build results and publishing the artifacts. The slave nodes are responsible for executing the build jobs assigned to them by the master. This allows Jenkins to scale to support large and complex projects with many builds and tests. Now the next we have is the plugins. Now Jenkins has a rich plugin ecosystem that allow it to integrate with a wide variety of tools and services. For example, you can use the plugin to integrate Jenkins with a version control system like Git, test tools like JUnit, and deployment tools like Ansible. Now this allows Jenkins to customize to fit the needs of your projects. Next we have is the web UI or the user interface. Jenkins provides a web-based user interface that allows you to configure and manage your builds, as well as view the build results. The web UI is accessible from any web browsers, which make it easy to use Jenkins from anywhere. Here's an example of how Jenkins could be used in a project. A developer pushes code changes into the project Git repository. Jenkins now receives a notification of the code change and trigger a build of the project. Now the Jenkins master node dispatches the build job to a slave node. The slave node checks out the code from the Git repository and run the build script, example like a Maven build. Now, if the build is successful, Jenkins publishes the build artifact in a jar file to a repository that is your Nexus. Now, Jenkins sends a notification to the development teams about the build status. Now, if the build is successful, Jenkins can also trigger automated tests and deployment. I hope this helps. Now, let me know if you have any questions about Jenkins or would like to know more information. This architecture allows Jenkins to scale horizontally by adding additional slave nodes as needed to handle the workload. It also allows the master to delegate tasks to slaves that have the necessary resources and tools to execute them, which can improve the efficiency of the build process. Now coming on to the next question we have, can you explain the infrastructure as code concept? Let us see how we shall answer this following question. Infrastructure as code is a software development practice in which infrastructure is treated as a version entity that can manage using version control system, just like the application code. The goal of an infrastructure as code is to allow users to create, manage, and deploy infrastructure in a repeatable and automated way. One key benefit of IAC is that it allows infrastructure changes to be tracked and audited in the same way the code changes are. It also makes it easier to roll back changes if something goes wrong. This can be particularly useful when managing large and complex infrastructure environments that include many different components. Infrastructure as code refers to the practice of managing infrastructure in a version control file rather than manually configuring resources through a user interface. The imperative approach is similar to writing a script or a set of instructions that tells the system exactly what to do in order to achieve the desired outcome. It is similar to how you will manually set up and configure your infrastructure. The declarative approach, on the other hand, involves defining the desired state of the infrastructure and letting the system figure out how to reach that state. This approach is more like writing a configuration file that specifies what the end result should look like rather than specifying the steps that it needs to get there. Now, both approaches have their own benefits and drawbacks. and it is up to the users to decide which one is more suitable for their needs. Now, there are several tools and technologies that can be used to implement the IAC, including configuration management tools such as Ansible, Chef, and Puppet, which allow users to describe and manage the desired state of their infrastructure. CloudFormation and Terraform, which are tools for creating and managing infrastructure on cloud platforms such as AWS and Azure. Custom scripts and tools that allow users to automate infrastructure tasks using languages such as Python or Bash. Now, IC can be applied to a wide range of infrastructure components, including servers, databases, networking configuration, and many more. So by using IAC, organization can more easily manage and maintain the infrastructure in a consistent and reliable way. Now, moving on to the next question we have, what is pair programming? A pair programming is a software development technique in which two programmers work together at one workstation. Now, one programmer called the driver writes code while the other called the observer or navigator review each line of the code as it is typed in. So the two programmers switch roles frequently. Pair programming can be an effective way to reduce defects in code, improve code readability, and share knowledge among team members. It can also be an effective way to train new programmers or to familiarize programmers with a new code base. Now coming to the next question, we have what is a blue or green deployment pattern? Now let us see how to answer this following question. Blue-green deployment is a strategy for rolling out updates to software systems that allows for minimal downtime and disruptions to users. Now the basic idea is to maintain two identical environments, one called blue and the other called green. So the blue environment is the current production environment, where the green environment is a new version of the software that has been deployed but is not yet live. To perform a blue or green deployment, the new version of the software, that is the green version, is first deployed into the green environment. Now this can be done by building the software and deploying it into the staging environment, or by using a continuous delivery pipeline to automatically build and deploy the software. Now once the green environment is up and running, traffic is redirected from the blue environment to the green environment. Now this can be done using a load balancer or by changing the DNS records to point to the green environment. Once the traffic has been redirected, the blue environment can be taken offline for maintenance or decommission. Now this allows the teams to roll back to the blue environment if there are any issues with the green environment without any downtime or disruptions to the users. For example, let's say you have a web application that you want to update. Now the current version of the application is running in the blue environment, and you have to deploy a new version of that application to the green environment. Now to perform the blue or green deployment, you will first test the green environment and to ensure that it's working properly, right? So once you are confident that the green environment is stable, you will redirect traffic from the blue environment to the green environment using a load balancer or a DNS records. Now once the traffic has been redirected, you can take the blue environment offline or you can decommission it. There are several benefits to using a blue-green deployment. First, it allows you to minimize